Hello everyone. The question says that what is the force between two small charged spheres having charges of 2 into 10 to the power minus 7 coulomb and 3 into 10 to the power minus 7 coulomb placed at 30 centimeter apart in the air. So here we have to find out force between two small charged spheres. So we have to find out electrostatic force. Now the expression for electrostatic force is given by Coulomb's law, which states that the electric force between two charged particles acts between the line connecting them, and it is inversely proportional to the distance separating them, and it is directly proportional to the product of those two charges, and also the same charge repel each other and opposite charges attract each other. Now this can be summarized in a mathematical equation like this. Now Fe equals to K times Q1 Q2 divided by R square, where Q1 and Q2 are the magnitude of the charges, R is the distance of separation, and K is the constant, and for air it is 9 into 10 to the power 9 coulomb square per Newton meter square. Now here in this question we have been given the value of those two charges and the distance separating them. So we can easily substitute these values in the equation, and then we can find out what is the force. So substituting these values, we get force as equal to 6 into 10 to the power minus 3 Newton. Now since we have been given the charges that are both positive, so we can say that since charges are of same sign, that is positive sign, so that the force will be repulsive in nature. Thank you. The question says that the electrostatic force on a small charge sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. Now what is the distance between these two spheres, and what is the force on the second sphere due to the first? So here again, this is the force between two charged particles governed by Coulomb's law that we saw in the previous lecture, that says that force is equals to K times Q1 Q2 divided by R square, where Q1 and Q2 are the magnitude of charges and R is the distance of separation between them. And opposite charges attract each other and like charges repel each other. Now here we have been given two opposite charges, so the force will be attractive in nature. We have been given the magnitude of force between them, that is 0.2 Newton, and we have been also given the value of Q1 and Q2, that is the magnitude of charge on those small spheres, that is 0.4 microcoulomb and minus 0.8 microcoulomb. So we have to find out distance of separation, that is R in between them. So here F is given, K we all know that its value is constant, and for air it is 9 into 10 to the power 9. Now Q1 and Q2 is also given, and R we have to find out. So we can, after substituting this in the given equation, we get the value of R as 12 centimeter. Thank you. The question says that check the ratio Ke square by G-MEMP is dimensionless. Look up the table of physical constants and determine the value of this ratio. What does this ratio signify? So here in question, the scenario is of two particles, namely electron and proton, and this ratio represents the ratio of the electrostatic force to that of the gravitational force. So we know the expression of electrostatic force, that is F, if we represent it by Fe, that would be equal to K times charge on electron, and it is represented by E, multiplied with charge of proton, again it is E, divided by distance of separation, that is R square. Now if we represent the distance of separation by R, then it would be Ke square by R square. Now similarly, we can write the expression for gravitational force like this. Fg would be equal to G, that is gravitational constant, times mass of electron times mass of proton divided by R square. Now if we find out the ratio, that is Fe by Fg, that would be equal to this given quantity, that is Ke square by G, mass of electron times mass of proton. So we have to find out this ratio, and we have to determine the value of this ratio, and we have to say what does this signify. Now we know already that what does this signify. The ratio signifies the ratio of electrostatic force to that of the gravitational force, and if we find the value of it, then we can find by how much quantity electrostatic force is higher or lower than that of the gravitational force. So here we know that K is the Coulomb's constant, that is given by 8.988 into 10 to the power 9 meters square per coulomb square. Similarly, charge of electron, we know the value, and we have to take this value from the table. And G, the value of G is also known. The mass of electron and mass of proton is also known. So substituting these values in this expression, we will get the value of K E square by G MEMP equals to 2.27 into 10 to the power 39. Now this ratio represents the relative strength between electrostatic and the gravitational force, and we see here that force of electrostatics is 2.27 into 10 to the power 39 times that of the gravitational force. That is, electrostatic force is much higher than that of the gravitational force, and it is higher by the order of magnitude this much. Thank you. The question says that explain the meaning of the statement electric charge of a body is quantized. Why can one ignore quantization of electric charge when dealing with the macroscopic, that is large scale charges? So here quantized means discrete, and in terms of electric charges, quantized means it is integral multiple of the smallest or the elementary charge unit, and that elementary charge unit is charge of proton or charge of electron represented by minus e. So mathematically we can represent the phenomena of the electric charge of a body is quantized as Q equals to n times c, where n is the integer. So if the body is having a net negative charge, then it would be in minus multiple of whole number of e, and if it is in positive, then n would be positive. Now the question is, why is charge quantized? A charge on any body is by the virtue of transfer of electrons and protons, and they transfer in whole numbers. So, and this is the fundamental unit of charge, that is E. Now they both carry equal charges, thus the charge always remains the integral multiple of E. Charge on a body is always the integral multiple of E. Now the second part of this question is, why can one ignore quantization of electric charge when dealing with macroscopic, that large scale charges? So the elementary charge is really small as compared to typical macroscopic charges. For example, if we have charge of 1 microcoulomb on any body, then it would be composed of 6.25 into 10 to the power 12 electrons. Now this number of electrons is quite massive, and therefore the charge always appears continuous for macroscopic charges, and the quantization can be ignored for macroscopic phenomena. Thank you. The question says that when a glass rod is rubbed with a silk cloth, charges appear on both. A similar phenomena is observed with many other pair of bodies. Explain how this observation is consistent with the law of conservation of charge. So the law of conservation of charge says that in an isolated and closed system, total charge remains constant. So let us understand the physical significance of it. Let us assume that there are two bodies, A and B. Body A and B, initially they are both neutral, and after rubbing, body 2 electrons transferred from body A to B. There is exchange of 2 electrons. Now body B will acquire more electrons, so it will be minus 2e net charge, and on body A, since it is deficient of 2 electrons, so it will be having plus 2e charge. So initially they both were neutral, and finally total charge in this system is equals to 0. So this is what law of conservation of charge says, that in an isolated and closed system, total charge remains constant. So initially we saw that glass rod and the silk cloth are both neutral, and after rubbing, just like in this A and B body, we saw that glass becomes positively charged and this silk cloth becomes negatively charged. Now which of the bodies will give up electrons depends upon the triboelectric series. So this is the triboelectric series. So in this series, the glass, we see that it has tendency to give up electrons to the highest, and below comes the silk. That is, if we rub glass and silk together, then glass has higher tendency to lose electrons than silk. So obviously when we rub these two, then glass will become positively charged and the silk will become negatively charged. Now since these two bodies are isolated and the system is closed in the sense that there is no any foreign electrons that is coming to the system of glass and silk. The question says that 4 point charges QA, that is of 2 microcoulomb, QB of minus 5 microcoulomb, QC of 2 microcoulomb, QD of minus 5 microcoulomb are located at the corners of a square ABCD of side 10 centimeter. What is the force on charge 1 microcoulomb placed at the center of the square? So there are 4 charged particles, namely QA, QB, QC and QD, and they all are arranged in a form of a square. Now if we assume that the square has 4 vertices of namely ABCD, and the particles are arranged at the corners ABCD, namely QA as 2 microcoulomb, QB as minus 5 microcoulomb, QC as 2 microcoulomb and QD as minus 5 microcoulomb. We have to find out what is the net force on charge 1 microcoulomb placed at the center of the square. Now let us assume that the center of the square is O, where 1 microcoulomb of charge is there. Now we have to find out what is the net force on this 1 microcoulomb charge. So we know that electrostatic force is given by Coulomb's law, and mathematically it is expressed as force equals to K times QA QB divided by R square, where QA and QB are the charge of the particles A and B, and Coulomb's law also states that the force between these two particles would be along the line joining these two particles, and it also says that like charges repel each other, that is if the charges have same sign they will repel, and if the charges have opposite sign then they will attract each other, and R is the distance of separation between them. So individually we have to calculate the forces acting by all those 4 particles on this charge at the center. So we see that force AO would be equal to, after applying this formula we will get a force of 3.6 Newton. Now since the charge at the center O and QA have both same sign, that is they both are positive, then the force will be repulsive in nature. Similarly with QC and O, it will be 3.6 Newton because magnitude of the charges are same, and again it will be repulsive. So, and since this is a straight line AOC, so they both will cancel out each other. Similarly we can see about this diagonal, that is DOB. Now force OB would be attractive in nature because this is positive in sign and this is negative in sign, and the magnitude would be given by 9 Newton after applying this formula. And similarly FOD would be equal to 9 Newton as well. Now they both will be attractive and they both will attract this 1 microcoulomb charge equally in opposite directions, so again they will cancel out each other. Now we saw that there are opposite forces and they are of equal magnitude and they all are cancelling out each other, so net force on this 1 coulomb charge particle would be 0. Thank you. The question says that an electrostatic field line is a continuous curve, that is the field line cannot have sudden breaks. Why not? So let us first understand a few properties of the electrostatic field lines. The first is field lines start from positive charge and end at the negative charge. That is, the field lines start at positive charge and they will end at negative charge. The origin of the field lines are from the positive charge and they end at negative charge. The second is, in a charge-free space, the electric field lines can be taken to be continuous curve without any breaks. That is, the electric field lines are continuous curves without any breaks in a charge-free space. Now, the question asked that an electrostatic field line is a continuous curve, that is, the field lines cannot have certain breaks. Why not? So this continuity arises because electric field is a vector field with a defined magnitude and direction at every point in space. That is, there is no any space where we can assume like there was a field line and there is a gap and the field line is continuing like that. So this is not practically or physically possible because charges cannot disappear. The force cannot disappear on a charge over here if the charge particle is over here, and it can't disappear and reappear over here. So a break in the field would imply an indefined or infinite electric field, which is physically impossible. So that is the reason why electric field lines are continuous curves without any breaks. Now the second question said that explain why two field lines never cross each other at any point. Now the third property of field lines says that two field lines can never cross each other. If they do, at the point of intersection there would be ambiguity in the direction, which rejects the concept of field line. We know that each electric field line has a definite direction. Now let us assume that this is a field line and this is another field line. We are assuming that the field line are crossing. Now at this point of intersection, this field line is saying that I have a direction in this way and this field line is saying that I have a direction this way. Now at this point we have got two directions, which is practically impossible. So the field lines can never cross each other at any point. The question says that 2-point charges QA, that is of 3 microcoulomb, and QB is of -3 microcoulomb, are located 20 centimeter apart in vacuum. What is the electric field at midpoint O of the line AB joining these two charges? And if a negative test charge of magnitude 1.5 into 10 to the power -9 coulomb is placed at this point, that is the middle point, what is the force experienced by this test charge? So this is the pictorial representation of the question. So there are 2 points A and B on which QA and QB charges are put respectively, and they are 20 centimeter apart. Now the scenario is there is a test charge in the middle of the line joining these two charges, that is AB, and the test charge has a magnitude of 1.5 into 10 to the power -9 coulomb. Now we have to find out what is the electric field at midpoint of the line joining AB. So electric field is given by K times Q divided by R square, and the direction of electric field is from positive charge to the negative charge. So the direction of electric field would be from charge A to charge B. Now we know that K is the Coulomb's constant, that is 8.99 into 10 to the power 9 Newton meter square per Coulomb square. So after substituting these values, we will get the magnitude of electric field. Now electric field, the contribution of electric field at the midpoint would be because of charge A and as well as charge B. So we will find out electric field due to charge A and due to charge B as well, and we all know that electric field, total electric field would be the vector summation of electric field due to individual charges. Now since these two are in the straight line, so we can simply add it, as the direction of electric field is going to be same from A to B in both the due to both the charges. So EA upon calculation is 2.697 into 10 to the power 9 Newton per Coulomb. Similarly, EB is 2.697 into 10 to the power 6 Newton per Coulomb, and total electric field would be equal to 5.394 into 10 to the power -6 Newton per Coulomb. Now direction of electric field would be from A to B. Now the calculation of force on the test charge. So F test can be given as the magnitude of charge times E total. Now since the test charge is negative, so its direction would be from B to A. The direction of force would be from B to A, because positive charges attract the negative charge and negative charge repels the negative charge. So B is negatively charged and A is positively charged. So the magnitude of force would be equal to 8.091 into 10 to the power -3 Newton, and it would be directed from B to A. Thank you. The question says that a system of two charges QA and QB, that is of magnitude 2.5 into 10 to the power -7 coulomb and -2.5 into 10 to the power -7 coulomb, located at points A 0 -15 centimeter and B 0 plus 15 centimeter respectively. What are the total charge and the electric dipole moment of the system? So we can clearly see that the charges are of equal magnitude and opposite sign, separated by a distance of 30 centimeter from 0 minus 15 centimeter to 0 plus 15 centimeter on the z-axis. So this is a case of electric dipole. Now we have to find out what is the total charge and what is the electric dipole moment of this system. So this is the pictorial representation of the question that is given. On the negative direction, on the negative side of the z-axis, there is a point at 15 centimeter from the origin, that is A, where the charge of 2.5 into 10 to the power -7 coulomb is there, and on the right hand side we have got a charge of -2.5 into 10 to the power -7 coulomb, that is on point B. So we know that electric dipole is defined as charge multiplied with the distance separating them. So the charge is 2.5 into 10 to the power -7 coulomb multiplied with distance, that is 15 centimeter plus 15 centimeter would be 0.3 meter, and thus we get the electric dipole of 7.5 into 10 to the power -8 coulomb meter. Now since this is an electric dipole, the equal and opposite magnitude of charge is there, so the total charge would be equal to 0. And the direction of electric dipole is from negative charge to positive, so it would be from point B to A. The question says that an electric dipole with a dipole moment of 4 into 10 to the power minus 9 coulomb meter is aligned at 30 degree with the direction of uniform electric field of magnitude 5 into 10 to the power 4 Newton per coulomb. Calculate the magnitude of torque acting on the dipole. So the question talks about interaction of an electric dipole in an uniform electric field. Now, since electric dipole is composed of positive and negative charge of equal magnitude, and if they are put in electric field, then they will experience force, and thus net torque will be produced. So this is the pictorial representation of this question. In the thin blue line from left to right, we see that uniform electric field is there of magnitude 5 into 10 to the power 4 Newton per coulomb, and this diagram that we see, that is of the electric dipole. At point A, there is a negative charge, and at point B, there is a positive charge. And we know that the negative charge experiences force on the opposite direction of the electric field, and the positive charge experiences force in the direction of electric field. Now, taking component perpendicular to the electric dipole axis, we will get EQ sine 30 degree on both the sides for both the charge. Now, calculating the net torque, we will see that it is equals to QD times E sine 30 degree, where E is the magnitude of electric field, that is uniform, D is the distance of separation between the charges, and Q is the magnitude of charge. So this is going to be the magnitude of torque, which can be represented by P E sine theta, where P is the electric dipole moment. Now QD represents the electric dipole moment, so we can write torque as P E sine theta. Now, using the values that has been given in the question, we get the torque of 10 raised to the power minus 4 Newton meter acting on the electric dipole presented in the uniform electric field. Thank you. The question says that a polythene piece rubbed with wool is found to have a negative charge of 3 into 10 to the power minus 7 coulomb. Estimate the number of electrons transferred from which to which. Is there a transfer of mass from wool to polythene? So we see that when polythene piece was rubbed with wool, it gained negative charge. That is, the electron from wool transferred to the polythene piece. So this part of the question is estimate the number of electrons transferred from which to which. So from which to which, we already know that if polythene becomes negatively charged, then the wool must lose those electrons to give polythene the extra electrons. Thus it became negatively charged with a magnitude of 3 into 10 to the power minus 7 coulomb. So we have to find out number of electrons. We know that charges are quantized, so we can express charges with an integral multiple of the elementary charge particles, and elementary charge is 1.6 into 10 to the power minus 19 coulomb, and here we are dealing with the negative charge, so the transfer of electrons is from wool to polythene. Now if we have to find out number of electrons transferred, then we can divide the total charge transferred divided by the elementary charge, then we will get the total number of electrons transferred, and thus it's of value 1.88 into 10 to the power 12 electrons. Now we also have to find out, is there any transfer of mass from wool to polythene? So this number of electron has been transferred, so there must have been some mass transfer also taken place. Now if we find out the mass that has been transferred, we get the value of 1.71 into 10 to the power minus 18 kg. The question says that two insulated charged copper spheres A and B have their centers separated by a distance of 50 cm. What is the mutual force of electrostatic repulsion if the charges on each is 6.5 into 10 to the power minus 7 coulomb? The radii of A and B are negligible compared to the distance of separation. So the question is talking about two charged spheres, and we have been given that the radii of A and B are negligible compared to the distance of separation, so we can treat those sphere as the particle with a charge of 6.5 into 10 to the power minus 7 coulomb, and they are separated by 50 centimeter. So what is the mutual force of electrostatic repulsion? Since both the charges have same magnitude and same sign, so the force would be repulsive force. Now the magnitude of force can be given by Coulomb's law, that is given by K times Q1 Q2 divided by R square, where Q1 and Q2 are the charges on both the spheres and R is the distance of separation between them. So the magnitude of force would be 0.01 into 0.0152 Newton. Now since both the charges Q1 and Q2 are of same sign, so the force will be repulsive. The second question says that what is the force of repulsion if each sphere is charged double the amount and the distance between them is halved. Now the case is the charges have been doubled, that is Q1 is now 2Q1 and Q2 is now 2Q2 and R is now R by 2. So initially when the charges were Q1, Q2 and the distance of separation was R, we termed the force as F. Now the new force F dash would be equal to 16 times F. So because the 2 multiplied by 2 equal to 4 and now R square would be R by 4. Now 4 will go in the numerator and will give us 16. So F dash would be 16 times the initial force and of magnitude 0.2432 Newton. Thank you. The question says that figure 1.30 shows tracks of 3 charged particles in a uniform electric field. Give the signs of 3 charges. Which particle has the highest charge to mass ratio? We are seeing in this diagram that there is a positive charge and there is a negative charge, and the electric field lines flow from positive charge towards negative charge. So the charged particles who are attracted towards the positive charge is going to be negatively charged, that is 1 or 2. They are going to be negatively charged, and the particles that are attracted towards the negative charge is going to be of positive charge. So particle 3 is going to be a positively charged particle. Now the second part of the question was which particle has the highest charge to mass ratio. So we need to understand what charge to mass ratio is and how it affects the movement of charged particles. Now let us assume that there are 2 charged particles A and B of charges Q and QB, and for now we will assume that they are of equal charge, that is QA equals to QB. Now in an electric field of magnitude E, force on particle A would be QA times E and the force on particle B would be QB times E. Since QA equals to QB, we will see that force on A is equals to force on B. Now we will see the dependence of acceleration. So acceleration is defined as force divided by mass, and we see that acceleration is inversely proportional to the mass, and we also see from Coulomb's law that force is directly proportional to the magnitude of charge. Thus acceleration is also directly proportional to the charge. So if the ratio QIM is higher, the acceleration is going to be higher, and the direct consequence of acceleration is the deviation from the linear path. So those particles that is going to be having highest deviation from the linear path, they are going to have the highest charge to mass ratio. And in this all these 3 charged particles, we see particle 3 is having greater deviation. So particle 3 is going to have the highest charge to mass ratio among all these 3. Thank you. The question says that consider a uniform electric field E that is of magnitude 3 into 10 to the power 3 I cap Newton per Coulomb. What is the flux of this field through a square of 10 centimeter on the side whose plane is parallel to YZ plane? And the second question is what is the flux through the same square if the normal to its plane makes 30-degree angle with the x-axis? So here electric field is directed towards the x-axis because we can see here I cap and we have the magnitude given. Now flux is a measure of number of electric field lines passing through a surface. So the surface here is in the subject is square of side 10 centimeter, that is 0.1 meter in length. Now the formula for flux is EA cos theta, where E is the electric field and A is the area, and cos theta is the angle between the electric field and the area vector. So here in the first case the square is just perpendicular to the x-axis, so its area vector is going to be in the direction of x-axis. Now the angle between area vector and the electric field is going to be 0, so we can substitute cos 0 over here. Now the flux in the first case would be 30 Newton meter square per Coulomb. Now in the second case we see that the square has been tilted and it is making now 60-degree angle with the x-axis. So here theta would be equal to 60 degree. Now substituting the same, we will get the result as 15 Newton meter square per Coulomb. Thank you. The question says that what is the net flux of uniform electric field of exercise 1.14 through a cube of side 20 centimeter oriented so that its faces are parallel to the coordinate plane. Now we know from the previous exercise that electric field was given as 3 into 10 to the power 3 I cap Newton per coulomb, or it was directed towards the positive x-axis. Now from Gauss law we know that net flux through any closed surface depends upon the charges enclosed, and it is given by the expression phi net, or the net flux, is equals to Q enclosed divided by epsilon naught. Now Q enclosed is the charge enclosed by that area. Now in this question we have been given that the cube of side the side of cube is of 0.2 meter, but there is no any statement suggesting any charge inside the cube, so phi, or the flux, is going to be 0 according to Gauss law. And also we can say that the field lines enter, the uniform field lines enter and exit the cube, and thus net flux through the cube is going to be 0. Thank you. The question says that careful measurement of electric field at the surface of the black box indicates the net outward flux through the surface of the box is 8 into 10 to the power 3 Newton meter square per coulomb. Now what is the net charge inside the box? So here we see that we are being talked about electric flux. There is outward electric flux through the surface of the black box, 8 into 10 to the power 3 Newton meter square per coulomb. So the question talks about the concept of Gauss law, which states that total electric flux through the Gaussian surface would be equal to Q enclosed divided by epsilon naught. Here Q enclosed is the charge enclosed inside the Gaussian surface, and epsilon naught is the constant. Now it states that total flux either outward or inward that Gaussian surface would be equal to this value. Now we have been given the flux and we are being asked about the net charge inside the box. So here in this expression we see that the value of flux is given and we are being asked about Q enclosed, and epsilon naught is a constant, so we already know the value. So using this formula we can find out what is the net charge inside the box. So solving this we will get the value of 0.07 microcoulomb. Now the second part of the question said that if the net outward flux through the surface of the box were 0, could you conclude that there were no charges inside the box? We can't conclude that there are no charges inside the box if the total flux is 0, because total flux may result out to be 0 if Q enclosed is equals to 0. Now Q enclosed equal to 0 can happen due to many reasons. The first is equal amount of positive and equal amount of negative charges there, then also the total charge will be equal to 0. So we cannot say that there were no charges that resulted in no flux. Rather we can say that there was charge, but there was equal and opposite charge which cancelled out the effect of flux. That's why we are getting 0 flux. The question says that a point charge plus 10 microcoulomb is a distance 5 centimeter directly of the center of the square of side 10 centimeter as shown in the figure 1.31. What is the magnitude of electric flux through the square? Hint: think of a square as a face of a cube with an edge of 10 centimeter. Now we are being asked about the flux through this square face of a cube, thinking of a cube. Now here we can apply the Gauss law as well. Now Gauss law states that the total electric flux outward or inward through a Gaussian surface would be equal to total charge enclosed within the surface divided by epsilon naught, that is the constant. So we are being asked about the electric flux through this square. Now the particle is at the center of this square. Now here we can exploit the symmetric nature of a cube. We can assume a Gaussian surface of a cube of side this 10 centimeter. Now we can assume that the particle is inside the Gaussian volume of cube of side 10 centimeter. Now after finding out the flux toward outward, since it is positive charge, so outward the volume, we can divide it by 6 because this square would represent one of the face of that cube. So that's how we can get the flux through this square. So using this approach we can get the flux of the cube as 1.13 into 10 to the power 6 Newton meter square per coulomb, and since square is one of the face of the cube we can divide it by 6, and since it is symmetrical, all 6 faces are same, so we can get the flux as 1.88 into 10 to the power 5 Newton meter square per coulomb. Thank you. The question says that a point charge of 2 microcoulomb is at the center of the cubic Gaussian surface of 9 centimeter on edge. What is the net electric flux to the surface? So the question is saying that there is a charged particle of magnitude 2 microcoulomb inside the center of a cube that is of side 9 centimeter. Now what would be the electric flux through the surface? So we can assume that this is the Gaussian surface of cube of side 9 centimeter. Now we can apply Gauss law as here. Gauss law states that total flux outward or inward through the Gaussian surface would be equal to total charge enclosed within the surface divided by epsilon naught. Now we can use this formula straightforward to find out the flux outward of this surface, outward of this Gaussian surface. So we can get the expression, we can substitute the values of the expression in this expression, and we will get the value of 2.26 into 10 to the power 5 Newton meter square per coulomb. Thank you. The question says that a point charge causes an electric flux of minus 1.0 into 10 to the power 3 Newton meter square per coulomb to pass through the spherical Gaussian surface of 10 centimeter radius centered on the charge. So here electric flux is given, the value of electric flux is given, and it is passing through the spherical Gaussian surface of 10 centimeter of radius. Now we can assume it as phi 1. Now if the radius of the Gaussian surface were doubled, how much flux would pass through the surface? And the second question is, what is the value of point charge? So here we can apply Gauss law to find out the point charge. We know that Gauss law states that total flux through the Gaussian surface would be equal to Q enclosed within the surface divided by epsilon naught. Now here electric flux is given, and we are being asked about the Q enclosed, that is charge enclosed within the Gaussian surface. So we can get the value of Q enclosed by multiplying this flux with epsilon naught. Now the first question said that if the radius of the Gaussian surface were doubled, how much flux would pass through the surface? Now let us assume that the first case where radius was r, the flux would be equal to phi 1, and the second case where r is doubled would be equal to phi 2. So here we see that in both these Gaussian surface, the total charge enclosed doesn't change, so the flux would also not change. So that's why we can say that the flux remains same even if the radius is doubled. And the charge enclosed, as I told you earlier, we can find it using this formula. Charge enclosed would be minus 8.85 nanocoulomb. Thank you. The question says that a conducting sphere of radius 10 cm has an unknown charge. If the electric field 20 cm from the center of the sphere is 1.5 into 10 to the power 3 Newton per coulomb, points radially inwards, what is the net charge of the sphere? So the question is saying that there is a conducting sphere of radius 10 cm and it has some charge, due to which there is an electric field 20 cm away from the center, and the value of electric field is 1.5 into 10 to the power 3 Newton per coulomb, and this electric field is towards the sphere. So since this electric field is directed towards the sphere, so we can say that there is a negative charge inside the sphere. Now we have to find out what is the net charge on the sphere. So by Gauss law we know that for a spherical charge distribution, electric flux would be equal to Q enclosed divided by epsilon naught. Here electric flux is the multiple of electric field multiplied with the surface area of the surface enclosing this charge. Now for a sphere, the surface area of a sphere would be 4 pi r square. Now E dot 4 pi r square would be equal to Q enclosed divided by epsilon naught. Q enclosed is the charge inside the Gaussian surface. Now we can find out the expression for Q enclosed as here as E dot 4 pi r square multiplied by epsilon naught. Here E would be equal to 1.5 10 to the power 3 Newton per coulomb, and this is the surface area of the sphere of radius 20 cm, and this is epsilon naught. Now we know that the electric field is pointed towards the sphere, so there is a negative charge inside the sphere. Thus the charge will be minus 6.67 nanocoulomb. Thank you. The question says that a uniformly charged conducting sphere of 2.4 meter diameter has a surface charge density of 80 microcoulomb per meter square. Find the charge on the sphere. And the second question is, what is the total electric flux leaving the surface of the sphere? So by definition of surface charge density, we know that surface charge density sigma is defined as total charge divided by surface area. Now using this expression, we can find out the value of total charge on the sphere, as Q would be equal to sigma times A. Now A for the sphere would be equal to 4 pi r square. So the value of charge on the sphere would be 1.44 microcoulomb, 1.448 microcoulomb. Now the second question was, what is the total electric flux leaving the surface of the sphere? Now we can assume a Gaussian surface around this sphere, and as per Gauss law, flux through the Gaussian surface would be equal to total charge enclosed by the Gaussian surface divided by epsilon naught. Now since this Gaussian surface would be enclosing this charge, this magnitude of charge Q, 1.448 microcoulomb, and we can use this expression now for finding the flux. So flux would be equal to 1.64 into 10 to the power 8 Newton meter square per coulomb. Here we see that while assuming Gaussian surface, we can assume Gaussian surface that covers this sphere of any radius. So just the sphere should be inside the Gaussian surface. The question says that an infinite line charge produces a field of 9 into 10 to the power 4 Newton per coulomb at a distance of 2 cm. Calculate the linear charge density. So we have to calculate the linear charge density given that the infinite line charge produces a field of 9.9 into 10 to the power 4 Newton per coulomb. So let us assume that this is the infinite charge line, and at a distance of 2 cm away from this line charge, the electric field is of this much magnitude is produced. So what is the linear charge density, or lambda? Lambda is defined as total charge divided by length of the line. So we have to find out this value of lambda. Now we have an expression for electric field due to an infinite line charge, and that says that E is equals to lambda by 2 pi epsilon naught r. Now we can find out lambda using this expression, and that would be given by E into 2 pi epsilon naught r, and using this expression we have got the value of as lambda as 0.1 microcoulomb per meter. Now how this expression came, let's understand it a little bit deeper. Now let's assume that this is the line charge. In this question it is of positive charge, so we can assume it as a positive charge. Let us assume that there is a point r at a distance of r away from this line charge. Now we have to find out, either we have to find out Q, that is the charge on this line, or we have to find out electric field, or we have to find out flux. Now we can use Gauss law over here. Now we can assume a Gaussian surface, a cylindrical Gaussian surface over here of radius r. Now electric flux outward of this upper and lower face of the cylinder would be 0, because electric field would be perpendicular. So it would be 0 from this face and this face as well. So the only electric field contribution would be from the curved surface area, and from the Gauss law we know that flux is given by Q enclosed divided by epsilon naught. Now flux is defined as E multiplied by surface area. So E dot the curved surface area of cylinder is equals to 2 pi r multiplied by length, or the height. This is the length. That would be equal to Q enclosed. Now Q enclosed would be given by lambda times L. Lambda is the linear charge density multiplied by length L divided by epsilon naught. Now here we see that the expression of E would become L would cancel out each other. Now lambda divided by 2 pi r epsilon naught. Now this is the same expression we used in the upper question to solve the question. So it comes from here as per the Gauss law. Thank you. The question says that two large thin metal plates are parallel and close to each other. On their inner faces, the plates have surface charge densities of opposite sign and of magnitude 17 times 10 to the power minus 22 coulomb per meter square. So the configuration is like this. There are two plates. I have symbolized them as red and the black one. They are carrying opposite charges of charge density sigma equals to 17 times 10 to the power minus 22 coulomb per meter square. We have to find out what is the electric field in the outer region of the first plate, that is this region, outer region of the second plate, that is this region, and between the plates, that is this region. Now we can leverage the Gauss law in this, which states that net flux from any surface is equals to Q enclosed, that is the charge enclosed in that surface, divided by epsilon naught. Now flux is given as E dot ds, or the dot product of electric field and the area vector. Now the geometry in subject is of thin metal plates parallel to each other. Now we can assume it as like this. Now we can assume the Gaussian surface to be of a parallelepiped like this one in the green box that we can see. Now the electric field due to this thin metal plate would be parallel to these all four faces, this one, this one, this one, and this one. So they won't contribute to the electric flux, because we know that dot product angle between them would be 90 degrees, so it would result out to be 0. Now the flux due to this number 1 phase and number 2 phase will be counted, and they both will add up to 2EA. Now A would be the area enclosed of this surface. Now sigma A would be the charge enclosed in this parallelepiped. Now this flux, this is quantities flux, and this is the charge enclosed divided by epsilon naught. Now from this we can know that E is equals to sigma by 2 epsilon naught. So for this region of our interest, that is away from both of the plates and near the first plate, we can make a Gaussian surface that would enclose both the charges, and thus they both are having equal and opposite surface charge density. And since Gaussian surface is enclosing both the plates, so the net charge would be 0. So electric flux due to both these metal plates at point A would be equal to 0. Similarly at B it would be equal to 0, and at C it would add up because they both are of opposite charge, and Gaussian surface of this would result EA. Gaussian surface of this positive plate would result the electric field as sigma by 2 epsilon naught. Similarly by the negative plate it would result out to be sigma by 2 epsilon naught, and they both will be of same direction, from away from the positive charge and towards the negative charge like this one. Now they both will add up, since their angle between them is 0, so they both will add up, and the vector addition would be sigma by epsilon naught, and this would give us 1.92 into 10 to the power minus 11 Newton per Coulomb. Thank you. The question says that two charges 5 into 10 to the power minus 8 Coulomb and minus 3 into 10 to the power minus 8 Coulomb are located 16 centimeters apart. At what points on the line joining the two charges is the electric potential 0? Take the potential at infinity to be 0. Now we know that the notion of potential says that the electric potential V at a point P due to a charge Q at a distance R is given by V equals to 1 by 4 pi epsilon naught multiplied by Q by R. Here this is K, that is Coulomb's constant, and K times Q by R. Now the net potential energy due to multiple charges is the algebraic sum of the potential due to individual charges. So potential energy of a system of charge is just given by algebraic sum of individual potential on that point. For example, if Q1, Q2, Q3 are 3 charges and they are separated by a point P by the distance of R1, R2 and R3 respectively, so Vp, or the potential due to this 3 system of charges at point P would be given by the algebraic sum of the individual potential. Now the question said that two charges Q1 and Q2 are there. Q1 is of positively charged, that is 5 into 10 to the power minus 8 Coulomb, and Q2 is minus 3 into 10 to the power minus 8 Coulomb. We have to find out the point between the line, or the point on the line joining these two charges. So let us assume that there is a point P over which the potential due to these two charges is 0. Now as we have studied just now that potential due to a system of charges is the algebraic sum of the potential due to the individual charges. So we will find out potential at point P due to Q1 and Q2, and we will sum it and we will equal it to 0. Now solving this equation we will find out the value of x. Now by the value of x we will get the point at which the potential due to charge Q1 and Q2 equals to 0. Now similarly proceeding with that strategy, we see that potential due to charge Q1 would be equal to KQ1 divided by x, and potential due to charge Q2 would be equal to KQ2 by 16 minus x, because if this is x, then the total distance is 16 centimeter, then this distance would be 16 minus x, or 0.16 meter minus x. Now proceeding with the calculation, we will get the value of x as 10 centimeter, that is 10 centimeter away from point Q1. The potential due to these two charges would be equal to 0. Now there would be another case where the point may lie outside these two charges on the same line. So let us take the second case as like this. Q1 and Q2 are here, they both are 16 centimeter apart, and let us assume that point x, the point P at a distance x away from the Q1 charge on the side of Q1 charge. Now proceeding similarly like before, we will get the equation Now after solving this, we will get the value of x to be minus 0.4 meter. Now minus suggests that, so since we have taken this distance as our desired assumption that the potential at this side would be 0, now we have got the value of x as 0.4, minus 0.4. So minus suggests that this point lies on the other side of the charge and by 40 centimeter away from this point q1. So 40 centimeter away from q1 on the right side would be somewhere here. Now 40 minus 16 centimeter would be 24 centimeters. So 24 centimeter away from charge q2, or 40 centimeter away from charge q1 on the right side. Thank you. The question says that a regular hexagon of side 10 centimeter has a charge of 5 microcoulomb at each of its vertices. Calculate the potential at the center of the hexagon. Now the system of charge here is a hexagonal pattern. Now on each vertex of the hexagon there is a 5 microcoulomb charge present, and we have to find out what is the potential at the center of the hexagon. From the previous exercise, we also know that potential at a point P, which is at a distance r from the charge q, is given by Vp equals to k q by r, where q is the magnitude of the charge and r is the distance of separation between the point of our interest and the charge, and k is the Coulomb's constant. Now for the system of charges, this potential is just the algebraic sum of the contribution of individual charges to the potential, because potential is a scalar quantity. Now for this system of charge, that is a hexagon pattern, we will have to find out potential at the center. Each side of hexagon makes 60 degree as a center, which makes it an equilateral triangle. Now for the equilateral triangle, each side is same, that is each side of hexagon is 0.1 meter. So the distance of center from the vertex would also be equal to 0.1 meter. Now finding out potential of the system, we can write it as Vp equals to summation of kqi by ri, where I varies from 1 to 6 because there are 6 charges, and that would be, since the distance of separation is same, so we can simply write it as 6 times k q by r, where q is the charge on the vertex and r is the distance of separation between the vertex and the center. Now that will give us a value of 2.7 into 10 to the power 6 volts. Thank you. The question says that two charges 2 microcoulomb and minus 2 microcoulomb are placed at points A and B 6 centimeter apart. Identify an equipotential surface of the system and what is the direction of electric field at every point on this surface. Now we know that electric potential is defined at a distance r from the charge q as kq by r. Now here a term used is equipotential surface. So equipotential surface is a surface on which electric potential remains constant. No work is done in moving a charge along this equipotential surface. The system of charge is given as there are 2 points A and B, that is 6 centimeter apart, and on A there is a positive charge of 2 microcoulomb and on B there is a negative charge of 2 microcoulomb. We have to find out equipotential surface of this charge configuration. So let us proceed by general approach. Electric potential at any point P would be given by kqa by r1 plus kqb by r2. Now here qb is negative of q1, so we can write it as 2 into 10 to the power minus 6 by r1 minus 2 into 10 to the power minus 6 by r2 whole multiplied by k. Now for Vp to be constant, that is potential to be constant, r1 and r2 along the path should be constant. Now we know that the locus of a point equidistance from two fixed points is always a straight line representing perpendicular bisector of the segment joining the given point. That is, the locus of point that is equidistance from these 2 points should be this perpendicular bisector between these 2 points. Now the equipotential surface would be a plane located between the charges at a distance of 3 cm from each charge. The electric field at every point on the equipotential surface is directed perpendicular to the surface, pointing from positive charge of 2 microcoulomb to negative charge of minus 2 microcoulomb. Thank you. The question says that a spherical conductor of radius 12 cm has a charge of 1.6 into 10 to the power minus 7 coulomb distributed uniformly on its surface. what is the electric field inside the sphere, just outside the sphere, and at the point 18 centimeter from the center of the sphere. So here in this question, a sphere is given which is a conductor, and it has a radius of 12 centimeter, and it has a charge of 1.6 into 10 to the power minus 7 coulomb distributed over its surface. Now we have to find out electric field in three different areas. The first is inside the sphere, and the second is just outside the sphere, and third is at a point 18 centimeter away from the center of the sphere. Now we know for a property of conductor that any excess charge inside the conductor resides on the surface of the conductor. No net charge is present inside the conductor. So for the first part of the question that said that what is the electric field inside the sphere, we can apply Gauss law inside the sphere. Assuming that there is a Gaussian surface inside the sphere, there would be no charge inside the Gaussian surface. Thus, flux would be zero because there would be no charge inside the Gaussian surface. Thus, electric field would be zero. So, for the answer of first part of the question, that what is the electric field inside the sphere, the electric field inside the sphere is going to be zero. The second part of the question says that what is the electric field just outside the sphere. So, for this, we can assume that for a point outside the conductor of radius 0.12 meter, we can consider all the charges Q to be present at the center. Now by Gauss law, we can say that phi net, or the flux net through the Gaussian surface, would be equal to Q enclosed divided by epsilon naught. Now Q enclosed is the charge enclosed by the Gaussian surface. Now flux is defined as the dot product of electric field and the area. Now area of the surface area of the sphere would be equal to 4 pi r square, and E is the electric field. Now here we are assuming the whole sphere to be the Gaussian surface. So the charge on the sphere would be Q enclosed, and area would be 4 pi r square because we are assuming the sphere as the Gaussian surface. Now E would be equal to 1 by 4 pi epsilon naught multiplied by Q by r square, where r is the radius of the sphere. While calculating, we will come to the conclusion that electric field just outside the sphere would be equal to 10 to the power 5 Newton per coulomb. Now the third question said that what is the electric field at point 18 centimeter from the center of the sphere. Now in this case, we can assume that entire charge is concentrated at the center, and thus we can take Gaussian surface to be a sphere of radius 18 centimeter, and thus like previously we can calculate electric field like using this formula, and we will come to the conclusion that electric field is 4.4 into 10 to the power 4 Newton per coulomb. Now in this question, one of the most important thing that we applied as a property of conductor was the net charge on the conductor resides on the surface of the conductor, not inside the volume. Thank you. The question says that a parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. What will be the capacitance if the distance between the plate is reduced by half and space between them is filled with a substance of dielectric constant 6? So we know that a capacitor is a device that is used to hold charge, and capacitance is the ability of the component or circuit to collect and store energy in the form of electrical charge. Now capacitance of a parallel plate capacitor is defined by C equals to epsilon naught A by D. So here we see that there are geometrical components in the formula of capacitance, that is A and D, which is A is the surface area and D is the distance separating the plates, and the capacitance with the dielectric material between the plates is given by K times C naught, and K is the dielectric constant. So the first question said that what will be the capacitance if the distance between the plate is reduced by half. Now it is saying that if the distance between these two plates of a capacitor is half, then what would be the capacitance? So if distance between the plate is half from, let us assume that earlier it was D and now it is D by 2. The capacitance, which was earlier C naught, would be changed to CF. We have assumed that the new value of capacitance would be CF. Now C naught, that is earlier capacitor, when the distance of separation was D, the formula would be epsilon naught A by D, and now since it is half, it would be equal to epsilon naught A by D by 2. Now we can see here that CF would be equal to 2 C naught, that is capacitance will increase if the distance between these two plates is halved. Now the second part of the question said that, and the space between them is filled with the substance of dielectric constant 6. Now the space between these two plates is now fixed with dielectric constant of 6, a substance which is having dielectric constant of 6. So we know that the formula for capacitance with the dielectric constant is given by K times C naught, that is K is a dielectric constant. So we can say that since the dielectric constant of that material is 6, so the final capacitance would be 6 times C naught. So the final capacitance when the distance between the plate is halved and the space between them is filled with the dielectric material of constant K equals to 6 would be equal to 2 times 6 times C naught, which will be given by 12 times the previous value, that is 8 picofarad that was given. So the final capacitance would be equal to 96 picofarad. Thank you. The question says that 3 capacitor, each of capacitance 9 picofarad, are connected in series. What is the total capacitance of the combination? And the second question is, what is the potential difference across each capacitor if the combination is connected to a supply of 120 volt? Now we are here given 3 capacitors which are connected in series, and we have to tell what is the total capacitance of the system. And in the second question we have to find out what is the potential difference across each capacitor. So one of the most important property of a capacitor is that when capacitors are connected in series, then each capacitor connected has equal amount of charge. That is, when they are connected in series like this, then if this capacitor has charge Q, plus Q and minus Q, then each of this capacitor will have same charge. So the first question asked about C equivalent or total capacitance of the combination. Now the C equivalent for series combination is given by the summation of reciprocal of each capacitor. So 1 by C equivalent equal to summation of each capacitor 1 by C, where C is the capacitance of each capacitor. Now as per the given question, each capacitor is of capacitance 9 picofarad, so the total capacitance would be equal to 3 picofarad as per the calculation. Now the second question asked about the potential difference between each of this capacitor. Now each capacitor is connected in series over here, and we have to find out what is the potential difference across this one, that is V1, V2 and V3. So potential difference across each capacitor is given by V equal to Q by C, that is charge contained by that capacitor divided by the capacitance. Now we have already discussed earlier that charge carried by each capacitor would be same, and it is given by C times V. Now calculation of C times V will give us a charge of 360 picofarad. That is 360 picofarad of charge is available on all the capacitors. Now calculating voltage for the same would be V equal to Q by C, that will give us 40 volt. So each capacitor would have 40 volt across, the potential difference across each capacitor would be of 40 volts. Thank you. The question says that 3 capacitors of capacitance 2 picofarad, 3 picofarad and 4 picofarad are connected in parallel. What is the total capacitance of the combination? And the second question is, determine charge on each capacitor if the combination is connected to a 100 volt supply. Now the parallel connection is like this. The question is saying that there are 3 capacitors. We have named it as C1, C2 and C3. They are connected in parallel. Parallel connection means they all are receiving the same voltage or same potential difference as that of the source. So there are certain properties that are worth noting when capacitors are connected in parallel. The capacitors that are connected in parallel has the same potential difference across each other as that of the source. So each capacitor here, C1, C2 and C3 will have a potential difference across each other of 100 volts. Now the second property is that they store charge independently of each other, in contrast with that of in series connection where each capacitor stored equal amount of charge. Now the first question asks that what is the total capacitance of the combination. Now so the C equivalent in this case should be 2 plus 3 plus 4 picofarad, that would be equal to 9 picofarad. And the second question says that what is the charge on each capacitor. So charge on capacitor is given by Q equals to C multiplied by V, where C is the capacitance and V is the potential difference. Now each is having the same potential difference of 100 volts, and the capacitance varies as given, that is of 2, 3 and 4 picofarad respectively. Now similarly we can use this formula C multiplied by V to find out the charge in each capacitor, and we will get as 200 picofarad, 300 picofarad and 400 picofarad. Thank you. The question says that in a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 to the power minus 3 meter square, and the distance between the plate is 3 millimeter. Calculate the capacitance of the capacitor. If the capacitor is connected to a 100 volt supply, what is the charge on each plate of the capacitor? Before attempting this question, we should have our concepts clear about capacitance. That capacitance is a measure of capacitor's ability to store charge per unit voltage. For a parallel plate capacitor, the formula for capacitance is epsilon naught A times D, where A is the area of plate of the capacitor and D is the distance of separation between them. Now the question said that calculate the capacitance of the capacitor, and the second question was, if this capacitor is connected to a 100 volt supply, what is the charge on each plate of the capacitor? So once we know the formula for capacitance, we can easily calculate it, because epsilon naught here for air is given by 8.85 into 10 to the power 12 minus 12 farad per meter, and A is given, that is area of the plates, and D is also given, that is the separation between the plates. Area is 6 into 10 to the power minus 3 meter square, and D is 3 millimeter, or it is 3 into 10 to the power minus 3 meter. Now substituting these values, we will get a value of 17.7 picofarad for the capacitance. And for the charge on capacitor, given the potential difference, we know its expression is C times V, or capacitance times voltage. Now capacitance is 17.7 and voltage given is 100 volt. So its result would be 1.77 nanocoulomb. Thank you. The question says that explain what would happen if in the capacitor given in exercise 2.8, that is the previous exercise, a 3 millimeter thick mica sheet of dielectric constant 6 were inserted between the plates while the voltage supply remained connected, and the second case is after the supply was disconnected. So here two cases has been given, and the event that is occurring is the capacitor previously calculated of capacitance 18 picofarad, and the charge accumulated on that capacitor was 1.8 nanocoulomb. Now this capacitor is being subjected to two conditions. The first is, while the potential difference is maintained, or external supply is there to maintain the potential difference across this capacitor, a dielectric material of constant 6 is being inserted. Now we have to find out what will happen. And the second case is, the dielectric material is being inserted while the voltage source or the potential difference is not being maintained. That is the case 2. So in the first case, the capacitance will change, and the capacitance with dielectric constant is given as C equals to K times C naught, where K is the dielectric constant and C naught is the capacitance in vacuum. So previously calculated value was the capacitance in vacuum, that is of 18 picofarad. So new capacitance would be equal to 6 times 18 picofarad, that is 108 picofarad. Now since voltage maintained of 100 volt, so it will not change. The capacitance has changed to 108 picofarad. So the charge accumulated will also change, because C has changed and V has remained constant, and charge is given by C times V. So the new charge contained would be equal to 10.8 nanocoulomb. So we see here that while the potential difference was maintained, the capacitance has increased, and also charge storage has increased, because there is a source available for charge. Now the second case was, the dielectric material was being inserted while the potential difference was not being maintained. So in this case, we can see that Q before the dielectric material was being inserted, and after the dielectric material has been inserted, the charge on the capacitor will remain same. So the potential difference is given by Q by C, and this capacitance has increased, because we know that C is given by K times C naught. So the voltage would be equal to, voltage across the capacitor would be equal to 16.67 volt. So in this case, we see that capacitance has increased just like before, but voltage has decreased, because charge has remained constant. And in the previous case, this was not the case. In the previous case, there was a charge sink and source available. That's why the charge rearrangement took place, while in this case there was no any sink or source of the charge. That's why the potential difference dropped while Q remains same. Thank you. The question says that a 12 picofarad capacitor is connected to a 50 volt battery. How much electrostatic energy is stored in the capacitor? Now in this circuit there is a battery and there is a capacitor, and this is a battery and this is a capacitor, and the capacitance of the capacitor is 12 picofarad and the voltage of battery is 50 volt. Now we have to tell how much electrostatic energy is stored in the capacitor. The electrostatic energy stored in a capacitor is given by the formula half CV square. C is the capacitance and V is the voltage across the capacitor. So upon using this formula with the given data, we can calculate the electrostatic energy stored in the capacitor, and that would be equal to 1.5 into 10 to the power minus 8 joule. Thank you. The question says that a 60 picofarad capacitor is charged by a 200 voltage supply. If then disconnected from the supply and is connected to another uncharged 600 picofarad capacitor, how much electrostatic energy is lost in the process? The case is, once the capacitor of 600 picofarad capacitance is charged by a 200 volt supply, now it is the battery or the voltage source is disconnected, and in place of that source there is another capacitor, uncharged capacitor of 600 picofarad is implemented in the circuit. Now the circuit is like this in a series. It is asking that how much electrostatic potential energy is lost in the process. So we have to calculate electrostatic potential energy in the first case and the second case, and now we have to find out the difference between both. Now potential energy or the electrostatic energy is given by half CV square. Now initial electrostatic potential energy would be equal to half 600 picofarad multiplied by 200 volt square. Now that would give us 12 microjoule. Now after the capacitor is removed with the battery or the voltage source and connected to another uncharged capacitor, the total charge on both the capacitor is going to be same. Charge in case 1 and charge in case 2 is going to be same. Now charge rearrangement will take place, and thus since the capacitor in second case is connected in series, so we will get the equivalent capacitance as C1 plus C2, and that would give us 1200 picofarad, and voltage across the capacitor would be equal to Q by C equivalent. Now Q, we know that Q is going to be same because there is no any supply to pump extra charge. So Q would be equal to C1 V1, where C1 and V1 are the initial capacitance of the circuit, and the voltage divided by C equivalent, that is C equivalent becomes 1200 picofarad, so we will get the voltage as 100 volt. Now the final energy after connection is going to be equal to half C equivalent multiplied by final voltage square. Now that would give us 6 microjoule. Initial energy was 12 microjoule and final energy we have got as 6 microjoule. So there is a difference of 6 microjoule, or 6 microjoule is lost in the process. Thank you. The question says that a storage battery of car has an EMF of 12 volt. If the internal resistance of the battery is 0.4 ohm, what is the maximum current that can be drawn from the battery? So here the question is, there are two components. There are one component in this circuit, that is a battery of EMF 12 volt with the internal resistance of 0.4 ohm. Now we have to find out how much maximum current can be drawn from the battery. So the maximum current can be, in order to find out the maximum current that can be drawn from the battery, we need to get rid of all those extra components. So we have to close the circuit with just the battery with the internal resistance of 0.4 ohm. So after closing this circuit, we can give the expression for current as potential difference divided by resistance. Now here resistance is just the internal resistance of the battery, no other component. So V would be equal to 12 volt and the resistance would be equal to 0.4 ohm. Now using this formula, we get the value of maximum current as 30 ampere. That is, if there is no any other electrical component connected to the circuit, we can get a maximum current of 30 ampere with this 12 volt battery and internal resistance of 0.4 ohm. Thank you. The question says that a battery of EMF 10 volt and internal resistance of 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, what is the resistance of the resistor? What is the terminal voltage of the battery when the circuit is closed? Now given here the question is, this is the circuit where there is a 10 volt battery and the internal resistance of the battery is 3 ohm. and in series there is a resistor of unknown resistance connected. We have termed it as RO, and we have to find out what is the terminal voltage across the battery of the circuit. So we can apply Kirchhoff's loop rule over here, that says that potential difference across a closed loop is always equals to 0 in a closed circuit. Now we can start from the battery over here, from this point. Now from this point moving leftwards towards the direction of current, we can see we have met here a negative of 10 volt, so we will write minus 10 volt. And since current flows from higher potential to lower potential, so this potential, the potential at left point is always going to be higher than the right point if it is going from left to right. So it would be written as potential difference across the resistor R can be written as R times I, that is this one. Similarly across this resistor also, moving here, we can write it as I times 3 ohm. Now we have been given that I is 0.5 ampere, so we can substitute the value of I in this equation. Now we will get the formula. Now we will get the value of R as 17 ohm. Now we have to calculate the voltage across this cell, that is this cell. Now potential difference across this cell is will be composed of the cell, that is 10 volt plus its internal resistance. So we can move from here, from the left point of the cell. Now it is 10 volt minus, since we are moving in the opposite direction of the current flowing, so we will get here the lower potential, so it would be equal to minus of 3 times the current, that is 0.5 ampere. So we will get a value of 8.5 volt across this battery. Thank you.
The question says that at room temperature, that is 27 degrees centigrade, the resistance of a heating element is 100 ohm. What is the temperature of the element if the resistance is found to be 117 ohm, given that the temperature coefficient of the material of the resistor is 1.7 × 10⁻⁻⁴ per degree centigrade. Now this question talks about the relationship between resistance and temperature, and which is given by resistance as temperature T with respect to the reference temperature T0 is equal to R0, that is the resistance at the reference temperature multiplied by 1 plus alpha. Alpha is the thermal coefficient of resistance and it is material specific, multiplied by final temperature minus initial temperature, or the delta T. So in this question we have to find out the value of final temperature given the final resistance, initial temperature, thermal coefficient of resistivity. So after substituting the values in this formula, we can easily calculate the value of T, because this is the only unknown over here. Now substituting the values, we will get T equals to 1027 degrees centigrade. That is the final temperature at which the resistance was 117 ohm is 1027 degrees centigrade. Thank you. The question says that a negligibly small current is passing through a wire of length 15 meter and uniform cross section of 6 × 10⁻⁷ meters square, and its resistance is measured to be 5 ohm. What is the resistivity of the material at the temperature of the experiment? So we have to find out the resistivity in this question, and we know that resistivity is related to the resistance as R as the resistance is equals to resistivity rho multiplied by length of the conductor divided by cross section area of the conductor. Now resistivity of a material is a material specific property that quantifies how strongly a given material opposes the flow of electric current. It is represented by rho, as we saw in this expression. Now in this question we have been given the length, that is 15 meter, cross section area we have been given, and resistance is given 5 ohm. Unknown is the resistivity rho, so it can be easily found by rearranging this formula. So rearranging and substituting the values, we will get a value of resistivity as 2 × 10⁻⁷ ohm meter. Thank you. The question says that a silver wire of resistance 2.1 ohm at 27.5 degrees centigrade and a resistance of 2.7 ohm at 100 degrees centigrade determine the temperature coefficient of resistivity of the silver. So this question talks about the temperature dependence of resistance, that is given by the formula R at temperature T equals to initial temperature, or the reference resistance at reference temperature R0 multiplied by 1 plus alpha, that is the temperature coefficient of resistivity, multiplied with delta T, or the difference in the final temperature and the reference temperature. So in this question we have been given the initial temperature, initial resistance at that temperature, final temperature we have been given, and the final resistance at the final temperature has been given. Now in this formula we have been given all these four values, that is RT, R0, T and T0. We have to calculate alpha. So in this substituting all these values in this formula, we can easily calculate alpha. We will get a value of alpha as 0.00394 per degree centigrade. Thank you. The question is saying that a heating element using nichrome connected to a 230 volt supply draws an initial current of 3.2 ampere, which settles after a few seconds to a steady value of 2.8 ampere. What is the steady temperature of the heating element if the room temperature is 27.0 degrees centigrade? The temperature coefficient of resistance of nichrome averaged over the temperature range involved is 1.7 into 10 to the power minus 4 per degree centigrade. Now this question is using temperature dependence of the resistor, which is given by the mathematical formula RT, resistance at temperature T, equals to R0, that is the reference temperature resistance, multiplied by 1 plus alpha, that is temperature coefficient of resistance, multiplied with delta T, or final temperature minus initial temperature, or the reference temperature. Now in this question we have been given the potential difference, that is constant in this temperature range, I0 initial current through the resistor, IT, that is the final current through the resistor, initial temperature we have been given, and the temperature coefficient we have been given. So we have to find out what is the steady temperature, that is T final we have to find out. T initial is given and we have to find out T final. So calculating the initial resistance, we can use this formula V by I. Since potential difference is same, so V would be equal to 230 and initial current is 3.2 ampere. So we will get R0, or the initial resistance, as 71.875 ohm. Now final resistance we can also calculate, which can be calculated using the same formula, just using the final current, or the current at temperature T. We will get a value of 82.143 ohm. Now we know RT, that is the final resistance, R0, we have been given alpha, we have been given T0. We also need to find out T, so substituting the values we will calculate for T, that is the final temperature. Now T will be 867 degrees centigrade. Thank you. The question says that determine the current in each branch of the network as shown in figure 3.20. So this figure shows a network of resistors and a cell, and we have to find out current in each and every branch. So let's proceed with the Kirchhoff's loop rule, which says that potential difference across a loop is 0, and we know that current flows from higher potential to lower potential. We have decided to go with 3 loops. The first loop is A, B and D, the second loop is B, C and D, and the third loop is A, B, C and E, that is this outer loop. So in the first loop, that is ABD, we see that we have assumed the current in this direction from A to B. So the potential difference is going to be positive from A to B because the current is flowing from A to B. So we can write it as 10 times 10, that is the resistance, times I2. Similarly, in the arm BD, we get 5 times I4. Now in arm AD, now the loop direction is opposite to that of the current, that is current is flowing from A to D, but our loop is from D to A. So we will write it as minus of I3. Now equating it to be equal to 0, we see that it is 2I2 plus I4 minus I3 equals 0. Now similarly in loop BCD, we see 5I2 minus I4 minus 10I3 plus I4 minus 5I4 equal to 0. This will give us I2 minus 4I4 minus 2I3 equals to 0. Now similarly in the loop ABCE, that is AB, C and E, we will see that 10 times I2 plus 5 times I2 minus I4 minus 10
plus 10 times I1 would be equal to 0. Now this will give us 5I2 minus I4 plus 2I3 equals to 2. Now rearranging these equations, we will see we have three unknowns, that is I2, I4 and I3, and we have three equations. So after solving this, we will get the value of I2, I3 and I4 as I2 equals to 4 by 17 and I4 equals to minus 2 by 17 and I3 equals to 6 by 17. Now now we can find the current in each branch as it is in the form of either I2, I4 and I3, and we can write I1 as equals to either I2 plus I3, or we can write it as I2 minus I4 plus I3 plus I4, or it would be equal to I2 plus I3 only. So current in branch AB would be equal to I2, that is 4 by 17. Current in branch BC, that is this branch, would be equal to I2 minus I4. That will give us 4 by 17 minus 2 by 17. So the current in branch I4 is minus 2 by 17, that is I4 is this branch. In branch BT, we have got current minus in the direction. That implies that our assumed direction is opposite to that of the flowing current direction. So that is, if we have assumed that I4 is flowing from B to D, then the actual current would be flowing from D to B. And that's why the minus sign is there. So using the same approach, we can find the current in BC, AD and BD and AE as well. The current in AE would be equal to I1. Now I1, as I said before, it is given by I2 plus I3, so we can simply add 4 by 17 and 6 by 17 and we will get as 10 by 17. 4 by 17 plus 6 by 17, that will give us 10 by 17. Now each of these currents will be in ampere. Thank you. The question says that a storage battery of EMF 8 volt and internal resistance of 0.5 ohm is being charged by a 120 volt DC supply using a series resistor of 15.5 ohm. What is the terminal voltage of the battery during charging, and what is the purpose of having a series resistor in the charging circuit? So this is the circuit diagram of this question. There is a battery of 120 volt which is acting as the source battery for charging the battery, that is of 8 volt EMF. Now also there is a 15.5 ohm resistance through the battery, through the source battery in series, and the internal resistance of this 8 volt battery is 0.5 ohm. We have to calculate what is the terminal voltage of the battery during charging, that is, we have to calculate the voltage across this cell. Now we can run a loop and assume that anti-clockwise current is flowing in this circuit. I have assumed I to be in this direction. So let us proceed from this battery. So at point here we have 120 volt potential difference. So I have written 120 volt. Now at this point we can see that since the direction of current that is flowing is from left to right. So this point will be of high potential and this point will be of low potential. So we can write as 15.5 times AI. Now proceeding to this resistor, we will see again that in our assumed direction the current is flowing from right to left, so this will be the higher potential point, so we can write it as 0.5 times I. Now this is the lower potential, that is minus terminal of the battery, so we can write it as 8 volt minus 8 volt. And now once we have passed this cell, we have reached this same wire over here that we have started, so it is, our loop is completed. Now we can write summation of all this equal to 0, so we will get a value of I as minus 7 ampere. That means our assumed direction of current was opposite, so a current of 7 ampere is flowing in this direction. Now once we have known the value of current in this circuit, so we can easily calculate potential difference across any of these components. Now this is the battery component, this is the charging battery component over which we have to find out the potential difference, terminal voltage of the battery. So voltage across this charging battery can be given by the potential difference across this component, so it would be equal to 8 volt plus, since the current is flowing in this direction, that is the clockwise direction from
left to right. So this will be a point of higher potential now. So we can write it as plus 0.5 times the current. So 8 volt plus 7 times 0.5, that will give us a value of 11.5 volt. The question also asked, what is the purpose of having a series resistor in the charging circuit? The thing is, why do we use a series resistor in a charging circuit? The series resistor limits the current flowing through the circuit. Now without a resistor, the current would be very high due to the large voltage difference between the DC supply and the battery's EMF, potentially damaging the battery of the circuit. By controlling the charging current, the resistor helps in safe and steady charging of the battery, reducing the risk of overheating or overcharging. Thank you. The question says that the number density of free electrons in a copper conductor estimated in example 3.1 is 8.5 into 10 to the power 28 per meter cube. How long does an electron takes to drift from one end of the wire 3 meter long to its other end? The area of cross section of the wire is 2 into 10 to the power minus 6 meter square, and it is carrying a current of 3 ampere. Now this question is a continuation of example 3.1, which employed calculation of average drift velocity. Now in this question we have to find out how long will an electron take to drift from one end of the wire to another end, given that there is a current of 3 ampere flowing through the wire, and we have been given the dimension of wire, that is the cross section of wire we have been given. It is of 2 into 10 to the power minus 6 meter square, and the length of the wire is also given, that is 3 meter, and the number density of electron is also given, that is 8.5 into 10 to the power 28 per meter cube. In order to find out how long does an electron take to drift from one end to another, or the time duration that the electron will take to travel 3 meter given a current, we will have to calculate the drift velocity, and time duration can be calculated by dividing the length of the wire divided by the drift velocity. So at first, the expression for Vd or the drift velocity can be related to current using this expression, that is Vd equals to I divided by NEA, where N is the number density of the free electrons, I is the current through the conductor, and E is the elementary charge, and A is the cross section area. Now calculating drift time, we can divide it by length, that is L by Vd, and that will give us L times NEA divided by I, that is the current. So substituting the values, we will get a value of 2.72 into 10 to the power 4 seconds, or when divided by 3600 we can get it into hour, and that will be equal to 7.55 hours or 7.5 hours. Thank you. The question says that a circular coil of wire consisting of 100 turns, each of radius 8 cm, carries a current of 0.4 ampere. What is the magnitude of the magnetic field at the center of the coil? So this question focuses on Biot-Savart's law, which says that the magnitude of magnetic field dV is proportional to the current I, the element dl, and inversely proportional to the square of distance r. Its direction is perpendicular to the plane containing dl and r. Thus, we can express it as magnetic field is proportional to I dl and the cross product of r divided by r cube in the vector form. Now, the constant of proportionality here, mu naught by 4 pi, where mu naught is the permeability of the media. So, implementing Biot-Savart law for this circular coil, we get to know that the magnetic field due to this current carrying one coil would be equal to dB, and since dB is perpendicular to the plane containing the position vector and the current, so it will have some angle theta with the x-axis, and the component of this dB would be along the x-axis and this y-axis, if we assume this direction to be the y-axis. Since this is a circular coil or circular symmetry, so this perpendicular component will cancel out, so we will be only left with the x component or dB cos theta. Now here cos theta would be equal to, since this is theta, so this would be equal to 90 degree minus theta,
and this angle is going to be theta. Now cos theta would be equal to r by small r. Let's proceed. So dB cos theta, we can write it as mu naught by 4 pi. Here dl, the integration of dl is going to be 2 pi r, because it is a circular coil, this coil. So we can write it as I times 2 pi r as dl, cross product r is the position vector, divided by r cube, and the small r is can be given by Pythagoras theorem, that is x square plus the radius of this coil under root, now whole cube, multiplied by cos theta. Cos theta would be equal to capital R by the position vector small r. Proceeding further, we see that this can be simplified back to mu naught I r square by 2 under root x square plus r square whole cube. Now since at the center of coil, we can say that x is going to be equal to 0, because at center of the coil, if the point P is at the center of the coil, we can say that x equals to 0. Now substituting x equals to 0 in this equation, we get mu naught I by 2r. Thus the magnetic field at the center of the coil with the current I and the radius of the circle as r is given by mu naught I by 2r, and the direction of magnetic field is going to be in the x direction, or in the plane perpendicular to the circle. Now also here it has been given that there are 100 number of coils. Now we have assumed here that the coils are closely wound, or it is closely packed, so thus the magnetic field will add up. Now since number of turns is 100, so magnetic field will be 100 times the magnetic field due to one coil. So B would be equal to n times mu naught I by 2r, and substituting these values, we will get the value of B as 314 micro Tesla. Thank you.
The question says that along a straight wire carries a current of 35 ampere. What is the magnitude of magnetic field B at the point 20 centimeter away from the wire? Now, since the question is saying that there is a wire of infinite length which is carrying current, and I have assumed it from bottom to top over here, like in this figure, and there is a point which is r distance away from this straight line, and we have to find out magnetic field at this point. Now in order to find out magnetic field at this point, we can employ here Ampere's circuital law, which says that for the infinite current carrying conductor, magnetic field at a distance r outside the wire of infinite length is given by mu naught I by 2 pi r. And since we know the values of mu naught and the value of current is given, and the distance of separation between the wire and the point is given, that is 20 centimeter or 0.2 meter. By substituting the values, we will get the answer as 3.5 into 10 to the power minus 5 Tesla. And the direction of magnetic field would be from the right, in the right hand side of the wire, the magnetic field will be going inside the plane, and in the left side it will be coming out of the plane. Thank you. The question says that along a straight wire in the horizontal plane carries a current of 50 ampere in north to south direction. Give the magnitude and direction of B, that is the magnetic field, at a point 2.5 meter east of the wire. So here is a physical demonstration of this question. Now we have assumed the horizontal plane as this table. Now M to N, that is M is in the north as directed in the image, M is in the north side and N is in the south side of this table. So there is a current flowing from M to N, or from north to south, and its magnitude is 50 ampere, and a point P is there away from this line MN, which is at 2.5 meter east, that is on the right hand side of this wire, and we have to find out magnetic field at this point, and we also need to give the direction of magnetic field at this point P. So from Biot-Savart law, we know that the magnetic field due to long straight current carrying wire at a distance r is given by mu naught I by 2 pi r, where mu naught is the permeability of the free space, and I is the current, and r is the distance between the point P and this wire. So after substituting these values, we will get a value of 4 micro Tesla, that is there is a 4 micro Tesla magnitude of magnetic field at this point P. Now if we want to know the direction of this magnetic field, then we can use right hand thumb rule, where the thumb is in the direction of the current, so the face over
the palm will face the direction of this magnetic field, and we will see that it is upward. So the direction of this magnetic field is going to be upward. Thank you. The question says that a horizontal overhead power line carries a current of 90 ampere in east to west direction. What is the magnitude and direction of the magnetic field due to the current 1.5 meter below the line? So we have imagined that this is the line in which current is flowing from east to west direction, and below there is a point P where we have to find out the magnetic field. Now we know that the magnetic field due to straight current carrying wire is given by mu naught I by 2 pi r. For using this formula, we have been given the appropriate data points, where we have been given the current, we have been given the r, that is the distance away from this line. So after substituting these values, we will get the value of magnetic field, and it is 12 micro Tesla. Now again, we can find out the direction of magnetic field by using right hand thumb rule. So from right hand thumb rule, we can say that the direction of magnetic field at this point P is out of the paper, or we can symbolize it as a dot. Thank you. The question says that what is the magnitude of magnetic field per unit length on wire carrying current of 8 ampere and making an angle of 30 degree with the direction of uniform magnetic field of 0.15 Tesla. So the question is saying that there is a uniform magnetic field of magnitude 0.15 Tesla, and there is a current carrying wire. The magnitude of current is 8 ampere and it is making an angle of 30 degree with the uniform magnetic field. So what is the force per unit length on that wire? So we know that magnetic force on a current carrying wire in a uniform magnetic field is given by I L cross B, where L is the length vector of the wire and B is the magnetic field and F is the force vector, I is the current through the wire. Now force per unit length can be defined as F/L equals to IB sin theta. Now IB sin theta comes from L cross B. As in the question, the wire made a 30 degree angle with the magnetic field. So we can substitute our given values in this formula to find out what is the force per unit length. So substituting these values, we will get the force per unit length as 0.6 Newton per meter. Thank you. The question is saying that a 3 centimeter wire carrying a current of 10 ampere is placed inside solenoid perpendicular to axis. The magnetic field inside the solenoid is given to be 0.27 Tesla. What is the magnetic force on the wire? So this is the solenoid, and we have assumed the magnetic field in the solenoid to be in the right to left direction of magnitude 0.27 Tesla, and there is a current carrying wire perpendicular to the axis of solenoid. So we have assumed that there is a current that is flowing from down to top, and the magnitude of the current is 10 ampere and the length of the wire is 3 centimeter. So we know that magnetic force is given by F equals to ILB, where I is the current and L is the length of the wire and B is the magnetic field. By substituting the given values in this formula, we will get a value of 0.081 Newton. The question says that two long and parallel straight wires A and B carrying currents of 8 ampere and 5 ampere in the same direction are separated by a distance of 4 centimeter. Estimate the force on a 10 centimeter section of the wire A. We know that parallel wires carrying currents exert magnetic forces on each other due to the interaction of their magnetic fields, and the direction of force is given like, if the current in the wire is along the same direction, then the force will be attractive in nature, and if the current flows in opposite direction, then the wires will repel each other. Now magnitude of this magnetic force is given by mu naught I1 I2 by 2 pi d, where I1 and I2 are the current in each wire, and mu naught is the permeability of the free space, and its magnitude is 4 pi into 10 to the power minus 7 Tesla meter per ampere, and L is the length of the wire under consideration, and here d is the distance of separation distance between the two wires. Now we have been given the value of I1 and I2, that is the current in both the wires. We have also been told that they are in same direction, current is flowing in same direction, and we have been given the distance of separation of the wires. Now we have to calculate force on the 10 centimeter section of wire, that is 0.1 meter. So after substituting the data that has been given in the above formula, we come to the result that the force of 2 into 10 to the power minus 5 Newton is applied by wire A on wire B or wire B on wire A, and the force is attractive in nature because the current is flowing in same direction. Thank you. The question says that a closely wound solenoid 80 centimeter long has 5 layers of winding of 400 turns each. The diameter of a solenoid is 1.8 centimeter. If the current carried is 8 ampere, estimate the magnitude of B inside the solenoid near its center. B is, that is, magnetic field. We have to calculate the magnetic field of solenoid inside the solenoid that has a diameter of 1.8 centimeter and it is 80 centimeter long and it has 5 layers of 400 turns each winding. So actually it has 5 into 400 turns, that is 2000 turns of wire. So we know that a solenoid is a coil of wire that generates magnetic field. When the current flows through it, the magnetic field B inside the ideal solenoid is uniform and can be calculated using this formula mu naught n times I, where mu naught is the permeability of the free space and n is the number of turns per unit length and I is the current carried by the solenoid. Now we have been given the following data. The n, that is number of turns per unit length. We have been given that there are 4 layers of 500 windings each, so there will be 2000 windings and the length of the solenoid is 80 centimeters, so we will write as 0.8 meter. Now the number of turns per unit length would be 2500 per meter. Now after substituting these values in the formula, we will get a value of 2.25.1 micro Tesla. Thank you. The question says that a square coil of side 10 cm consists of 20 turns and carries a current of 12 ampere. The coil is suspended vertically and normal to the plane of the coil makes an angle of 30 degree with the direction of the uniform horizontal magnetic field of magnitude 0.80 Tesla. What is the magnitude of torque experienced by the coil? So there is a coil in the magnetic field. If we arrange the plane of coil like this, then it is making 30 degree with the direction of magnetic field. So we have to find out what is the torque on this magnetic coil. Now we know that the torque on the magnetic coil is given by NIAB, where N is the number of turns in the coil and I is the current through the coil, A is the area of the coil and B is the magnetic field strength and theta is the angle between the magnetic field and normal to the plane of the coil. So here theta would be equal to 30 degree because normal to the plane of the coil makes 30 degree with the magnetic field, and the area, for the calculation of area, we will take the square of side 10 centimeter because the coil is of shape square, and N is 20 here because there are 20 turns and I current is given with the magnitude of 12 ampere. So substituting all those data in the given formula, we will come to a result of 0.96 Newton meter. Thank you. The question says that two moving coil meters M1 and M2 have the following particulars: R1, N1, A1 and B1, that is resistance, number of turns, area and V1 is given for both the coil meters M1 and M2, and we have to determine the ratio of current sensitivity and the voltage sensitivity of M1 and M2. So current sensitivity is defined as deflection per unit current, or it is also proportional to NBA by K, where N is the number of turns in the coil and B is the magnetic field and A is the area of the coil and K is the spring constant. Now here we have to find out the ratio of current sensitivities of the second coil versus first coil. So by dividing both the sensitivities, that is sensitivity of M2 by M1, we will get this expression N2B2 A2 by A1 N1 V1 A1. Now substituting the values, we will get a ratio of 1.4. Similarly, the voltage sensitivity is defined as the current sensitivity divided by the resistance in the coil. So voltage sensitivity of second coil to that of the first coil would be equal to the current sensitivity of the second coil divided by first coil multiplied by resistance of the first coil by the resistance of second coil. Now after substituting these values, we will get the result as 1.0. Thank you. The question says that in a chamber, a uniform magnetic field of 6.5 G, where 1 G stands for 10 to the power minus 4 Tesla, is maintained. An electron is shot into the field with a speed of 4.8 into 10 to the power 6 meter per second, normal to the field. Explain why the path of the electron is a circle and determine the radius of circular orbit, given that E is 1.5 into 10 to the power minus 19 coulomb and mass of electron is 9.1 into 10 to the power minus 31 kg. Here E is the charge on electron, and we know that it is 1.6 into 10 to the power minus 19, but in the question it is given 1.5. We'll be using 1.6 into 10 to the power minus 19 coulomb. The total force on a charge moving with the velocity v in the presence of magnetic and electric field B and E respectively is called the Lorentz force, and it is given by Q times V cross B, which is the magnetic force, and Q times E, that is the electric force. Now in this scenario there is no any other charge particle, so we can neglect this force and we will solely focus on this magnetic force, that is Q times V cross B. This force is perpendicular to both velocity and the magnetic field. A charged particle entering the field with the velocity perpendicular to the field moves in a circular path due to the centripetal force provided by the magnetic force. Now since this force is perpendicular to the initial velocity, so this force will act as a centripetal force. Now that will enable the particle to move in a circular path. So force, the magnetic force which is acting as a centripetal force is given by Q times V times B. R will come out to be mv by qb, where m is the mass of electron and E is the charge on electron and V is the velocity of electron and B is the magnetic field. Now substituting this, we will get a radius of 4.2 centimeter. So the radius of the circular motion that the charge will encounter is going to be 4.2 centimeter. Thank you. The question says that in exercise 4.11, obtain the frequency of revolution of the electron in its circular orbit. Does the answer depend on the speed of electron? Explain. Now we have to obtain here the frequency of revolution from the previous question. Now in the previous question, the electron was subjected to magnetic field perpendicular to its velocity. So there was a circular motion associated with that electron, and we had to calculate the radius of that circular motion. Now in this question, we have to calculate the frequency of rotation, and we have to also comment on whether the frequency of that revolution depend upon the speed of electron or not. So we know that frequency is given by omega by 2 pi. Now we also know that we also derived this expression from the previous question, that QVB, or the magnetic force on a charged particle with the charge Q and velocity V perpendicular to the magnetic field B, is equals to mv square by r. We can relate it with the centripetal force, and where r is the radius of rotation of the particle. So from this expression we know that r would be equal to mv by qb. Now we know that v by r is the omega. V by r can be written as omega. Now the expression of omega would be equal to qb divided by m. Now substituting the values from the previous question, we will get the value of frequency as, we will substitute omega in the expression of frequency from this equation. We will substitute omega as qb by m. So we will get frequency as qb by m into 2 pi. Now after substituting the values, we will get a value of frequency as 18 megahertz. Now from this expression, we see that frequency is independent of the velocity of electron. So we can comment here that the frequency of revolution is a fundamental characteristic of the particle and the magnetic field, unaffected by the speed of particle. And also we can see in this expression that there is no any term associated as velocity that is going to affect the frequency of rotation. So we can say that the frequency is unaffected by speed. So the answer to this question, does the answer depend on the speed of the electron, would be no, it doesn't depend upon the speed of electron. Thank you. The question says that a circular coil of 30 turns and radius 8 cm carrying a current of 6 ampere is suspended vertically in uniform horizontal magnetic field of magnitude 1 Tesla. The field lines make an angle of 60 degrees with the normal of the coil. Calculate the magnitude of the counter torque that must be applied to prevent the coil from turning. Would your answer change if the circular coil in A were replaced by planar coil of some irregular shape that encloses the same area? All other particulars are also unaltered. In this question, there is a coil that is suspended vertically in the uniform magnetic field, and its area vector is pointing 60 degrees with the magnetic field, and we have to find out how much torque would be required to prevent it from turning. So basically we have to find out what is the torque that is being applied on the coil. So we know that torque on the current carrying coil is given by the cross product of the magnetic moment and the magnetic field, and this simplifies to NIAB sine theta, where N is the number of turns, I is the current, A is the area of the coil that the coil encloses, and B is the magnetic field. And sine theta is the angle between the area vector and the magnetic field. Now we have been given this data. We need to find the area that we can find out since it is a circular coil. So pi r square, we will use this formula to find out the area, and substituting the values, we will get a value of 3.14 Newton meter. Now the second question also asks that whether if we replace it with some irregular shape of the same area, that of the circle, then will the torque change? So in this formula of torque, we see that it doesn't matter what is the shape of the coil, it only matters the magnitude of area. Since it is not changing, so the torque will also not change. So the answer would be no, the torque won't change on changing the shape of the coil. Thank you. The question says that a short bar magnet placed with its axis at 30 degree with a uniform external magnetic field of 0.25 Tesla experiences a torque of magnitude equal to 4.5 into 10 to the power minus 2 joule. What is the magnitude of magnetic moment of the magnet? Now in this question, there is a bar magnet that has been placed in the magnetic field, and it is making a 30 degree angle due to the influence of the torque that this magnetic field is putting on this bar magnet. Now we have to find out what is the magnetic moment of this magnet. Torque equals to mb sine theta. Now in this question, we have been given the torque on magnet, that is, we have been given this value tau. Theta we have been given, and we have been given the magnitude of magnetic field, that is B. So we only need to find out M, where M stands for magnetic dipole moment of this bar magnet. Now putting all those values in the given equation, we will get the value of M as 0.36 ampere meter square. Thank you. The question says that a short bar magnet of magnetic moment M equals to 0.32 joule per Tesla is placed in a uniform magnetic field of 0.15 Tesla. If the bar magnet is free to rotate in the plane of the field, which orientation would correspond to its stable or unstable equilibrium? What is the potential energy of the magnet in each case? Now a bar magnet is placed in the uniform magnetic field like in the previous exercise we saw, and the magnetic moment is given over here, and the magnitude of magnetic field is also given, that is 0.15 Tesla. Now we have to find out if the bar is free to rotate, now which orientation would correspond to its stable equilibrium and unstable equilibrium. And the second question is saying that what is the potential energy of magnet in each case. Now we know that a bar magnet in uniform magnetic field experiences a torque given by tau equals to mb sine theta, where m is the magnetic moment and b is the magnitude of magnetic field, and theta is the angle between magnetic moment and the magnetic field. And potential energy of the system is defined as minus mb cos theta, where m and b means same and theta means same as well. Now equilibrium, whether it is unstable or stable equilibrium, occurs when torque on the system is 0 or torque on the bar magnet is 0. Now we see that in this torque expression there is a component of sine theta. Now when sine theta is equals to 0, then this torque is going to be equal to 0. So sine theta is 0 in two cases, either theta is equals to 0 or theta equals to pi or 180 degree. Now when theta is equals to 0, the magnetic moment is parallel to the magnetic field, and when theta is 180 degree, then magnetic moment is anti-parallel to the magnetic field. Now theta 0 is called stable equilibrium and theta equals to 180 degree is called unstable equilibrium, because if we try to change the angle when it is at 180 degree, even a slight change would make it unstable, whereas if we try to change the angle when theta is equals to 0 degree, then it will restore to its same point at theta equals to 0. Finding out the potential energy of the system in stable as well as unstable equilibrium, since we have known the expression that the magnetic field of the system is given, the potential energy of the system is given by minus mb cos theta, so we can find out u for stable would be theta equals to 0, giving the expression of 0.048 joule minus of 0.048 joule, and for unstable it is 0.048 joule. Thank you.
The question says that a closely wound solenoid of 800 tons and area of cross section 2.5 into 10 to the power minus 4 meters square carries a current of 3 ampere. Explain the sense in which solenoid acts like a bar magnet. What is its associated magnetic field? Now, let's first understand what a solenoid is. A solenoid is a coil of wire designed to create a magnetic field when an electric current passes through it. The magnetic field inside the solenoid is uniform and resembles the field of a bar magnet. The resemblance occurs due to the alignment of magnetic field lines creating clear north and south pole. Now, how does the solenoid mimic a bar magnet? When the current flows through the solenoid, it generates a magnetic dipole moment, and the solenoid behaves like a bar magnet with a distinct magnetic moment pointing from south to north pole along its axis, that is inside. Now, magnetic moment is defined as M, that is equals to N times I times A, where N is the number of turns of the wire of the coil and I is the current flowing through it, and A is the area of cross section of solenoid. That is area of cross section of solenoid is this. Now, we have assumed here that this coil wounding is so tight that we can assume that each and every coil is a circle. So magnetic moment is defined as N times I times A. Now here the data has been given for the number of turns, the current in the solenoid, and the area of cross section. After substituting in this formula, we will get a value of 0.6 ampere meter square, which is the magnetic moment of this solenoid when the current is flowing through it. Thank you. The question is saying that if a solenoid in exercise 5.5, it is talking about the previous exercise, is free to turn about the vertical direction and the uniform horizontal magnetic field of 0.25 Tesla is applied, what is the magnitude of torque on the solenoid when its axis makes an angle of 30 degree with the direction of applied field? Now, previously we saw that there was a solenoid of 800 turns in which the current was flowing in the solenoid, and it has a cross section area that was given. Now, it was not subjected to any external magnetic field. Now, in this question, that solenoid is subjected to external magnetic field of magnitude 0.25 Tesla. So we can assume the problem to be like this. Magnetic field is from left to right direction of 0.25 Tesla magnitude, and the solenoid is making 30 degrees. The axis of solenoid is making 30 degree with this magnetic field. Now we have to find out torque on the solenoid. Now we know that torque on a magnetic dipole in the magnetic field is given by tau equals to mb sine theta, where m is the magnetic dipole moment. Now here solenoid will act as a magnetic dipole with the given magnetic dipole moment, and b is the magnitude of magnetic field, that is 0.25 Tesla, and sine theta, where theta is the angle between the solenoid axis or the magnetic dipole and the magnetic field, external magnetic field. Now, based on the previous data, we have the magnitude of magnetic dipole moment, that is 0.6, and we have been given the magnitude of magnetic field, external magnetic field, that is 0.25 Tesla and sine 30 degree. If we substitute these values in this formula, we will get the value of torque as 0.075 the Newton meter. Thank you. The question says that a bar magnet of magnetic moment 1.5 joule per Tesla lies aligned with the direction of a uniform magnetic field of 0.22 Tesla. What is the amount of work required by an external torque to turn the magnet so as to align its magnetic moment normal to the field direction and opposite to the field direction? And what is the torque on magnet in case 1 and 2? So here the question is saying that we have got a magnet which is under uniform magnetic field. So if we assume this to be the uniform magnetic field and this to be the magnetic axis, now we have to find amount of work required by an external torque to turn the magnet so as to align its magnetic moment normal to the field direction. So initially it was aligned in the magnetic field. Now we have to turn this magnet so as to align it perpendicular to the magnetic field. In the first case, normal to the field direction, and in the second case we have to align it opposite, that is from this state to this state. So upon turning the magnet normal and opposite, we have to find out what is the work done by external torque that is required. And the second question, we have to find out what is the torque on the magnet in case of 1 and 2. Now in second case, we have to determine if we have turned this magnet, then what would be the torque acting on this magnet. In the first case, like this, in 90 degree, and in the second case, that is theta equals to 180 degree, where theta is the angle between the axis of the magnet and the uniform magnetic field. Now we know that torque on a magnet is given by tau equals to mb sine theta, where m is the magnetic moment, b is the magnitude of the magnetic field, and sine theta, where theta is the angle between the magnetic moment of the magnet and the magnetic field. We also know that work done by external torque is equals to final potential energy minus initial potential energy, and the magnetic potential energy is defined as U equals to minus mb cos theta, where m is the magnetic moment, b is the magnitude of magnetic field, and theta is again the angle between m and b. So let's proceed to solving. So work required by the external torque in aligning the magnet normal to the field, that is from theta equals to 0 degree to theta equals to 90 degree. We will find the initial and final potential energies. Initial potential energy will correspond to the theta equals to 0 degree, and final potential energy will correspond when theta equals to 90 degree. So using the formula above, we have calculated U initial, that is equals to minus 0.33 joule, and U final would be equal to 0 joule, because cos 90 would be equal to 0. Now work done would be equal to U final minus U initial, and that would give us 0.33 joule. Now similarly, we will proceed to the second question that said that from theta equals to 0 degree to theta equals to 180 degree. So using the same approach, we will find the U initial, that is when theta equals to 0 degree, it would be equal to minus 0.33 joule, and U final would be equal to 0.33 joule. So the work done would be 0.33 joule minus of 0.33 joule, that would give us 0.66 joule. Now the second part question said that what is the torque on the magnet when theta is equals to 90 degree and when theta equals to 180 degree. So we saw earlier that torque is defined as mb sine theta, or the cross product of magnetic moment and the magnetic field. Here m is the magnitude of magnetic moment and b is the magnitude of magnetic field, and sine theta, where theta is the angle between m and b. So when theta equals to 90 degree, we will get torque of 0.33 Newton meter, and when theta equals to 180 degree, we will get a torque of 0 Newton meter. Or visualizing this, when the magnet is in this state, we will get a torque of 0.33 Newton meter, and when the magnet is in this state, that is opposite to the magnetic field, we will get a torque of 0 Newton meter. We also know that this position is the unstable equilibrium position. Thank you. The question says that a closely wound solenoid of 2000 turns, an area of cross section 1.6 into 10 to the power minus 4 meters square, carrying a current of 4 ampere, is suspended through its center, allowing it to turn in a horizontal plane. Now we have to find out what is the magnetic moment associated with the solenoid, and what is the force and torque on the solenoid if the uniform horizontal magnetic field of 7.5 into 10 to the power minus 2 Tesla is set up at an angle of 30 degree with the axis of solenoid. So there is a solenoid and that is hanging. So we can assume from the top view that the solenoid is this is the solenoid, and a uniform magnetic field of magnitude this much, that is 7.5 into 10 to the power minus 2 Tesla, is set up at an angle of 30 degree. The angle between this solenoid axis and the magnetic field is 30 degree, and we have to find out what is the magnetic moment associated with the solenoid. So magnetic moment will not be influenced by the magnetic field. So magnetic moment is defined as m equals to NIA, where n is the number of turn of the solenoid and I is the current flowing through it, and A is the area of cross section of the solenoid. We have been given the data, all three data. So we can find out the magnetic moment. And the second question says that what is the force and torque on the solenoid when this magnetic field is set up. So torque on the magnetic dipole is given by mv sine theta, that is m is the magnitude of magnetic moment and v is the magnitude of magnetic field, and theta is the angle between the magnetic moment and the magnetic field, and here it is theta equals to 30 degree. We also need to tell what is the force on the solenoid. So we know that since the magnetic field is uniform, no net force would be acting on this solenoid by the uniform magnetic field, so force is going to be 0. Now let us calculate the magnetic moment and torque on the solenoid. So magnetic moment would be equal to NIA, where N equals to 2000 and I is 4 ampere and area of cross section is 1.6 into 10 to the power minus 4 meter square. So we will get a value of 1.28 ampere meter square. And the second question said that what is the torque on the solenoid. Since we know that the magnetic field is uniform, so force is going to be 0. So calculating torque, we can use the formula mv sine theta, where m is 1.28 and the magnetic field is 7.5 into 10 to the power minus 2, that is given. So we will get a value of 4.8 into 10 to the power minus 2 Newton meter torque. Thank you. The question says that a short bar magnet has a magnetic moment of 0.48 joule per Tesla. Give the direction and magnitude of the magnetic field produced by the magnet at a distance of 10 cm from the center of the magnet on the axis and as well as the equatorial lines of the magnet. So if we assume that this is our magnet, bar magnet, and we have to find out the magnetic field at a point which is on the axis and on the equatorial line, that is the perpendicular bisector of the magnet. Now for a fact we know that a short bar magnet behaves as a magnetic dipole with a magnetic moment m. Now magnetic field at a point on axis or the bisector or the perpendicular bisector is given by the formula B on axis is mu naught by 4 pi multiplied by 2 into magnetic moment of the magnet divided by r cube, and on the equatorial position it is given by mu naught m by 4 pi r cube, where r is the distance from the center of the magnet to that point and m is the magnetic moment of the bar magnet. Now using this formula we can easily find out what is the magnetic field on the magnitude of magnetic field on the axis and on the equatorial point. So substituting the formula, we will get the magnetic moment on the axis as 9.6 into 10 to the power minus 5 Tesla, which will be along the magnetic moment, and on the equatorial position it will be 4.8 into 10 to the power minus 5 Tesla, which will be directed opposite to that of the magnetic moment of the magnet. Thank you. The question says that a short bar magnet placed in the horizontal plane has its axis aligned along the magnetic north-south direction. Null points are found on the axis of the magnet at 14 cm away from the center of the magnet. The Earth's magnetic field at the place is 0.36 Gauss and the angle of dip is 0. What is the total magnetic field on the normal bisector of the magnet at the same distance as the null point? That is from 14 cm from the center of the magnet. The question is hinting that it has given the magnetic field at the axis and we have to find out the magnetic field at the perpendicular bisector of the bar magnet. At 14 cm away from the center of the axis, there is a null point. And what is null point? Null point is the field due to a magnet is equal and opposite to the horizontal component of the Earth's magnetic field. Since the dip angle is 0, at null point, the net magnetic field is going to be 0. That is, the magnitude of magnetic field due to the bar magnet would be equal to the magnitude of magnetic field of the Earth's magnetic field, and its direction will be opposite. That's why it will cancel out each other. So in that way we have been hinted the magnitude of magnetic field at the axis of the bar magnet at 14 cm. And also we know that B at axis, magnitude of magnetic field at the axial position is given by mu naught 2m by 4 pi r cube, where m is the magnitude of magnetic moment, and at the equatorial position it is given by mu naught m by 4 pi r cube, and B at axis is equals to 2 into B at equatorial position. That is, B at axis is 2 times that of the B at equatorial point, where r is same. That is, if we find out the magnitude of magnetic field at the
10 centimeter away from the center of the magnet on the axial position, then let's assume that its magnitude is A. Then the magnitude of magnetic field at the equatorial position at the 10 centimeter away from the center would be equal to A by 2. So let's proceed. If at 14 centimeter from the center of the magnet there is a null point, then B at axis at 14 centimeter must be equal to B at earth, as we said, and that will be equal to 0.36 into 10 to the power minus 4 Tesla in opposite direction from that of the Earth's magnetic field. So we will get this expression, that is mu naught 2m by 4 pi r cube would be equal to 0.36 into 10 to the power minus 4 Tesla. Now total magnetic field at the normal bisector or the equatorial position at 14 centimeter is given by the magnetic field due to the earth plus the magnetic field due to the bar magnet. At the equatorial position, the direction of magnetic field by the bar magnet will be equal to the direction of magnetic field by the earth, so they both will add up. Now the total magnetic field would be contributed by that of the earth and the magnetic field by the magnet. Since we know that B by earth would be equal to 0.36 Gauss and B at magnet would be equal to half of that of the B at axis, and B at axis is 0.36 Gauss, so it would be equal to 0.18 Gauss. So the total magnetic field would be 0.54 Gauss. Thank you. The question says that if the bar magnet in exercise 5.13 is turned by 180 degree, where will the dew points be located? So basically it is referring to the previous exercise, that is 5.8. So in that question there was this bar magnet which was in the horizontal position with the magnetic field, and the null point was on the axis, and if we assume that this was the direction of magnetic field due to the bar magnet, that is Bm, we have shown it by that Bm. So the Earth's magnetic field was in the opposite direction, so on the axis there was the null point. So now the magnet has been reversed to 180 degree. So now its magnetic field on the axis has a direction opposite to that of the initial direction. That is, now it is from right to left, which can be seen over here. Now we have to find out new null point. So we know that at null point the net magnetic field is 0, that is magnetic field due to the magnet will cancel out the magnetic field due to the earth. So we have to find out at what point the magnetic field will be 0, the total magnetic field will be 0, or the null point of the magnet. So it will be on the equatorial position now, because along the axis the magnetic field gets aligned, the direction of magnetic field is same to that of the Earth's magnetic field, so we can't find it on the axial position, so it will be on the equatorial position. Now B at equatorial position is given by mu naught m by 4 pi r cube, where r is the distance from the center of the magnet. Now here we have to find out at what point r1 will the magnetic field due to the magnet will be equal to 0.36 into 10 to the power minus 4 Tesla, or the Earth's magnetic field, or the magnitude of Earth's magnetic field. So we have to find out r1 over here. Now we know from the previous question that mu naught into 2m by 4 pi r cube was equal to 0.36 into 10 to the power minus 4 Tesla, where r was 14 centimeter. So this is the magnetic field on the axis of the magnet, which was the case in the previous question. At r equals to 14 there was a null point, so it equals the magnitude of magnetic field to the earth. So we know this. Now we have to find out r1 for the same magnitude of magnetic field. So when we divide this both equations, we will get 0.14 meter or 14 centimeter by r1 cube, that is, this is the unknown, would be equal to 2. So from this equation we can find out r1, which will be equal to 11.1 centimeter. That is, the new null point will be at the equatorial position at 11.1 centimeter away from the center of the magnet. Thank you. The question says that predict the direction of induced current in the situation described by the following figure 6.15 from A to F. Now there are 6 figures. In all these figures, we have to find out what is the direction of induced current in the coil upon either a moving magnet or there is change in current in the nearby circuit. So we will use Lenz's law to find out the direction of current, and Lenz's law says that the direction of induced EMF will oppose the change in flux that created it. For example, we can see the demonstration over here. Like if the north pole of the bar magnet is coming close to a coil which is stationary, now we see that the flux is increasing, so the current will be induced in this coil such that north pole will be created over here, so that it will oppose the moving magnet towards it. So the current will flow in the direction that would create north pole, stronger north pole over here. Now similarly, when the magnet will move away from this coil, then south pole will be there because it will oppose the motion. Then it will create a south pole over here so that it attracts the moving magnet and it opposes the movement of the magnet. So let's use this to find out what is the direction of current in each of these diagrams. So in the first diagram, we see that the south pole of the magnet is approaching over the Q side of the circuit. So we can see from this figure that since south pole is coming near, so this current, induced current, will be such that south pole will be created over here momentarily, so that the direction, the movement of bar magnet will be opposed. So in order to create south pole over here, north pole must be created over here. So if we apply the right hand thumb rule, we can see that in order to create north pole in the left side, the current must flow through in this direction, anti-clockwise direction, that is QRP. So the direction of current is going to be QRP and Q again. Similarly, in this figure, we see that south pole is moving towards the Q point. So again, the induced current will be produced such that south pole gets created over here, and north pole gets created over here. So we can say that from the right hand thumb rule, the current will flow from PRQ in this circuit, and since north pole is moving away from this coil as in this diagram, so south pole will be created over here. So in order to create the south pole over here, north pole must be created over here, and applying the right hand thumb rule, we can say that the current will be in anti-clockwise direction in this circuit, which means that the current will flow from Y, Z and X. Let's move to the next figure. In this figure, we have tapping key just closed. Now here tapping, if the tapping key just got closed, it means the current started flowing, and when current start flowing, we see that the flowing current will create north pole over here and south pole over here. So the induced current in this circuit will be such that north pole gets created over here and south pole gets created over here. And by applying right hand thumb rule, we can say that again, in order to create north pole over here, the current should be in this direction, so it should be Y, Z, X. Now in this question, we see that rheostat settings being changed. So the pointer is decreasing the resistance, it means the current would be increasing in here, and this axis, Y, Z segment of this coil is much away from us than YX section of this coil. So if the current is increasing over here, north pole will be created over here and south pole will be created over here, and again we can say that north pole should be created in this coil over here and south pole should be created over here. Now since it is much nearer to us, so in order to create the north pole, the current must flow through YXZ, or we can say that the current will flow from, the direction of current will be from YXZ and again Y. Now in this diagram, we see that tapping key just released, or we can say that the current has just stopped. Now earlier when the current was flowing, we can see that this wire is hidden from the solenoid. It means that the circular turn is like this. Now earlier when the current was flowing, it would be such that the north pole should be here by right hand thumb rule, and south pole would be here. Now just after releasing this tap key, north pole has decreased, or we can say that the north pole of the magnet has been released. So south pole will be created over here, and north pole will be created over here. And for creating south pole over here, we can say that the direction of the current must be in this opposite direction, or x r y direction. And in this sixth figure F, we see that current is decreasing at the steady state. Now here in this line, the magnetic field direction would be such that the magnetic field will be 90 degree to the area vector of this coil. So we can see in this diagram that if that is the case, phi is going to be 0, as phi is the dot product of magnetic field and the area vector. So there would be no current that is produced in this circuit, in this coil. Thank you. The question says that use Lenz's law to determine the direction of induced current in situations described in figure 6.16. A wire of irregular shape turning into a circular shape. This figure describes a wire that is of irregular shape and it is turning back into a circular shape. And the second question is a circular loop being deformed into a narrow straight wire. So earlier it was a circular loop, now it has been transformed into a straight wire. So we have to find out what would be the direction of induced current in both the cases. In the first case, the magnetic field lines are going into the plane, and in the second case it is coming out of the plane. Now we will be using Faraday's law and Lenz's law in order to understand and find out what would be the direction of current in this cases. The Faraday's law says that the EMF, induced EMF, due to which the current would flow, would be equal to minus of d phi by dt, where d phi is the change in flux and where flux is the dot product of magnetic field and the area vector. And Lenz's law says that the direction of induced current will oppose the change in flux that created it. So we will have to focus on the flux and how it is changing, and the flux will be opposed, the change in flux will be opposed. That's how the current will be produced. So in the first case, we see that irregular shaped wire, when it turns out to be a circular shape, then the area will increase, or as flux was defined as B dot A. So since area will increase, d phi or phi will increase. So the induced current will oppose the increase in phi or the flux, or opposite magnetic field will be created. So initially the magnetic field was going into the plane, so magnetic field out of the plane will be created, and thus in order to create magnetic field out of the plane, that is coming out of the plane, the current has to flow in anti-clockwise direction, that is A, D, C and B. So by applying right hand thumb rule, we can say that if the current flows in anti-clockwise direction, then the magnetic field will be coming outward, and that's how the current will be induced. The current will be induced. In the second case, it says that the area is decreased or flux is decreasing, d phi is decreasing. So the induced current will support the flux to restrict it from decreasing, and thus the magnetic field will be in the same direction as before, or the magnetic field will continue to be out of the plane, and thus we will say that in order to have magnetic field out of the plane, just like before, the anti-clockwise direction current should flow, or A dash, D dash, C dash, B dash should be the direction of current. Thank you. The question says that a long solenoid with 15 turns per centimeter has a small loop of area 2 centimeter square placed inside the solenoid normal to its axis. If the current carried by the solenoid changes steadily from 2 ampere to 4 ampere in 0.1 seconds, what is the induced EMF in the loop while the current is changing? So here there is a small loop of wire of area 2 centimeter square is placed inside a solenoid. So just imagine that if solenoid is seen from its left or right along the axis as this, then there is a small loop of wire of 2 centimeter square placed inside the solenoid. Now we have to find out what is the induced EMF in this small wire, subjected that the solenoid, the current in this solenoid is changing from 2 ampere to 4 ampere in 0.1 second. Now if the current is changing, then obviously the magnetic field is going to be changing. Now if magnetic field is going to be changing, then there is a flux that is changing inside this loop as well, and flux is changing with time, so there will be induced EMF. Now Faraday's laws of electromagnetic induction says that the induced EMF E in the closed loop is proportional to the rate of change of magnetic flux phi b through the loop, and that is given by induced EMF is equals to minus d phi by dt. Now magnetic field inside the solenoid is given by B equals to mu naught Ni, where mu naught is the permeability of the free space, N is the number of turns per unit length of the solenoid, and I is the current. Now magnetic flux is defined as phi b equals to B dot A, that is the dot product of magnetic field and the area vector. Now for loop normal to the solenoid, as in the case of our question, theta is equals to 0, so the dot product will result out to be BA, as cos theta is equals to 1. Now let's calculate the induced EMF. So as we knew that induced EMF is given by minus d phi by dt, so we have to calculate the change in flux and we have to divide it by time, duration of time. So change in flux, we can see that, and since current is changing from 2 ampere to 4 ampere, so this value determines the delta T, and this is the number of turns per unit length in the solenoid, and this is the mu naught. So this results out to be the magnetic field of the solenoid, 4 pi 10 to the power minus 7 multiplied by 1500 into 2.0. So here 1500 comes from this data that has been given in the question, 15 turns per centimeter. Now if we divide, it has been given that 15 turns per centimeter. Now if we turn this centimeter to meter, then we will get 15 meter equals to 100 centimeters. So we will have to multiply it with 100. So we will get 1500 turns. So that's how we got 1500 multiplied by the area of the coil, that is 2 into 10 to the power minus 4 Weber, divided by time, duration of time, that is 0.1 seconds. So here we will get 7.54 microvolt. Thank you. The question says that a rectangular wire loop of side 8 cm and 2 cm with a small cut is moving out of the region of uniform magnetic field of magnitude 0.3 Tesla, directed normal to the loop. What is the EMF developed across the cut if the velocity of the loop is 1 cm per second in the direction normal to the longer side and shorter side of the loop? For how long does the induced voltage last in each case? So here magnetic field is normal to a rectangular loop. I have shown it with a magnetic field going into the plane, and the rectangular loop is lying on the plane of the paper of side 8 cm and 2 cm. The loop is placed normally to the magnetic field. Now when this loop is taken out of the magnetic field in either way, like in this way, parallel to the 2 cm side and parallel to the 8 cm side, so we have to calculate what is the induced EMF in both the cases, and also we have to find out what would be for how long does the induced voltage last. So we know that the EMF induced in a moving conductor in a magnetic field is given by this formula, E equals to minus d phi by dt. If the loop moves out of the magnetic field, then it is given that this expression turns out to be B times L times V, where B is the magnitude of magnetic field and L is the side of the parallel to motion and V is the velocity of the loop. Now there are two cases. At first, the movement is parallel to the 2 cm, or longer side is normal to the motion, that is movement is along 2 cm. So in this case, the velocity, we have been given the velocity, we have been given the B, and we have also been given the L, that is length of the side parallel to the motion. In this case, L is going to be 0.08 meter and magnitude of magnetic field is 0.3 Tesla, and velocity is always 0.01 meter per second. So we will get the answer to be 2.4 into 10 to the power minus 4 volt in this case. Now the question also asked duration of the induced voltage. Now for the time the flux will change, there will be induced voltage. Now for how long will the flux change? From starting from the movement of the coil till the coil has moved 100% out of the magnetic field, there will be the induced voltage. Now since this side is moving out of the magnetic field, so we can get the time with by dividing the velocity from 2 centimeter. So 2 centimeter by 1 centimeter per second, we will get 2 seconds. Similarly, for shorter side normal to motion is given by BLV, where L is the length of side parallel to the motion. Now in this case it is going to be 0.02 meter. Rest of the things will remain same. And similarly in this case also, since the motion will be in this direction, now this side will go out of the magnetic field. Now the how long will it take? 8 centimeter by the speed, that is 0.01 meter per second. So we will get time duration of 8 seconds. So 6.6 into 10 to the power minus 5 volt will remain for 8 seconds. Thank you. The question is saying that a 1 meter long metallic rod is rotated about an angular frequency of 400 radians per second about an axis normal to the rod passing through its one end. The other end of the rod is in contact with the circular metallic ring. A constant and uniform magnetic field of 0.5 Tesla parallel to the axis exists everywhere. We have to calculate the EMF developed between the center and the ring. Now there is a rod which is rotating about one of its end, and there is another end which is in contact with the axis, which is in contact with the ring, which has not been drawn in the picture. So we have to calculate the EMF generated between this point and this point 1 and 2. Now under given conditions, and the condition is there is a magnetic field that is parallel to the axis of rotation of the rod of magnitude 0.5 Tesla. So the magnitude of this magnetic field is 0.5 Tesla, and the omega is 400 radians per second. That has been given in the question. So we know by Faraday's laws of magnetic induction that EMF is induced when the conductor moves in the magnetic field, and induced EMF depends on the relative motion of the conductor and the magnetic field. And the formula for electromagnetic induction as per the Faraday's law is given by E, or the EMF, is equals to minus of d phi by dt, where phi is the flux, magnetic flux, defined as B dot A, where B is the magnetic field and A is the area vector. And now in this present case, the rod sweeps out an area as it rotates, changing the magnetic flux through it. Now for the sake of this question, we will consider a rod of length L. We have been given the measurement of this length, that is 1 meter. So let us assume that this is the length of the rod L, and there is a small element of length dx at a distance, that is x, from the axis of rotation. Now the motional EMF that is generated in this section is given by E is equals to B VL. We know that this is the formula for motional EMF. Now for this section, for the section of length dx, it would be equal to V times dx times B. Now V at the distance x in a circular rotation is given by V is equals to omega times x. So we can write it as B times omega x times L that is x. Now we will have to integrate this expression from 0 to L for the entire length of the rod. So total EMF would be equal to integration of B omega x dx from 0 to L, where B is the magnetic field, omega x is the V part of this formula, and dx is the length of the small section of the rod. Now after this integration, we will find out that EMF is equals to B omega L square by 2. And after substituting the values, we will get the value of 100 volts. So this is the EMF developed between the center and the ring. The question says that a horizontal straight wire 10 centimeter long extending from east to west is falling with a speed of 5 meter per second at right angles to the horizontal component of the Earth's magnetic field, that is 0.30 Weber per meter square.
What is the instantaneous value of EMF induced in the wire? What is the direction of EMF and which end of the wire is at the higher electrical potential? So in this question, it has been given that a wire of 10 meter in length, this wire, let us assume that this is 10 meter in length, it is falling down with a speed of 5 meter per second, and it is subjected to a uniform magnetic field of magnitude 0.30 into 10 to the power minus 4 Weber per meter square. Now we have to find out what is the induced value of EMF in this wire. So we know that when a conductor moves in a magnetic field, and EMF is induced due to the relative motion between the conductor and the magnetic field. Now Faraday's laws of electromagnetic induction says that the induced EMF is equals to minus of d phi by dt. In this case, the motional EMF would be equal to BVL, where the direction of magnetic field and velocity of the wire is perpendicular to each other, and this is the length of the wire. So let's calculate the instantaneous value of induced EMF. So using the formula above, we know that E is equals to BVL sin theta. Sin theta here comes from the cross product of V and B, that is V cross B. So here we know that theta is 90 degree because the wire is falling down, and we have to calculate the EMF due to the magnetic field and due to the horizontal component of the magnetic field, Earth's magnetic field. So the theta will be equal to 90 degree here. Now L is going to be 10 meter because this is the length of the wire that has been given, and V is the velocity at which it is falling, and B is the magnitude of magnetic field. Now substituting in this formula, we will get a value of 1.5 into 10 to the power minus 3 volts. Now for the direction of EMF, using the right hand thumb rule as well. So this is a vector of V, this is vector B, and this is 90 degree between them. Now if the right hand thumb rule says that the cross product of the two vectors is, the direction of cross product of two vector is along the thumb. So when V cross B is there, then the direction will come from west to east. That's how we know that the EMF is directed from west to east. Now the third question was higher potential end of the wire. The direction of the induced EMF determines the higher potential end. Since the EMF is directed from west to east, the eastern point of the wire is going to be at the higher potential. So this point, eastern point, is going to be at the higher potential. Thank you. The question says that current in a circuit falls from 5 ampere to 0 ampere in 0.1 seconds. If the average EMF of 200 volt is induced, give an estimate of the self-inductance of the circuit. Now we know that self-inductance is a property of the circuit where the change in circuit induces an EMF in the same circuit. Now Faraday's laws of electromagnetic induction says that induced EMF would be equal to E equal to minus of L delta I by delta T, where delta I is the change in current and delta T is the duration in which this change in current has occurred, and E is the induced EMF and L is the inductance of the circuit. Now we have to find out, give the estimate of self-inductance, that is we have to find out the value of L in Henry, which is the self-inductance. So we have been given the data of initial current, that is 5 ampere, final current, that is 0 ampere, since the current dropped from 5 ampere to 0 ampere in 0.1 second. So delta T, duration of time, would be equal to 0.1 second. Now average EMF is given, that is 200 volts. So after substituting these values in this formula, we will get a value of L, that is equals to 4 Henry. Thank you. The question says that a pair of adjacent coils has a mutual inductance of 1.5 Henry. If the current in one coil changes from 0 to 20 ampere in 0.5 seconds, what is the change of flux linkage with the other coil? Now mutual inductance, we know that it is a property of pair of coils that quantifies the ability of one coil to induce an EMF in the another coil due to the changing in current. So as there is a change in current in this coil, then the associated magnetic flux will change, and that changing magnetic flux will induce EMF, because we know that by Faraday's law, EMF is given by minus of d phi by dt. Since this change in flux will interact with the second coil, and this change will happen with time, so an associated EMF will induce in another coil. Now in this question we have to find out what is the
change of flux linkage. So we have to find out the change in flux. Now flux is given by mutual inductance times the current. Now change in flux can be given by mutual inductance multiplied with the change in current. Now here we have been given the mutual inductance, that is 1.5 Henry, and we have also been given the change in current, that is 0 to 20 ampere. So final current is 20 ampere and the initial current is 0 ampere. So we can easily find out using this formula the change in flux linkage, that would be equal to 1.5 times 20, and that will be equal to 30 Weber. Thank you. The question says that a 100 ohm resistor is connected to a 200 volt 50 Hz AC supply. What is the RMS value of the current in the circuit, and what is the net power consumed over full cycle? Now if we try to represent it in a circuit diagram, then it is like this. This is the AC supply of 50 Hz and 220 volt. Now unless it's specified, this voltage is in the RMS form, and there is a resistor of 100 ohm which is connected to the circuit in a series circuit. To express the AC power in the same form as DC power, RMS value is used, and RMS is defined as the square root of the average of a squared quantity. IT, if we define current varying with time as Im sin omega t, where Im is the peak current and sin omega t is the sinusoidally varying quantity. Now I RMS square would be equal to 1 by t of integration from 0 to time period, where t is the time period, Im squared sin squared omega t dt. Now if we find out this integration, definite integration, then we will come to know that IRMS squared would be equal to Im squared by 2, or we can say that IRMS is equals to peak current by root 2. Now in this question we have been given the VRMS, that is 220 volt, and the resistance, that is 100 ohm, and the frequency. So we have to find out IRMS. Now IRMS can be given as VRMS by R. So VRMS is 220 volt and 100 ohm is the resistance, so it is equals to 2.2 ampere. Now net power can be given by the formula IRMS squared times R, where we know that IRMS is equals to 2.2 ampere. So upon substitution we will get a value of 484 watts. Thank you. The question is saying that the peak voltage of an AC supply is 300 volt. What is the RMS voltage? And the RMS value of the current in the circuit is 10 ampere. What is the peak current? So we saw this derivation in the earlier question of the RMS value of current. Now RMS value in AC current is used to make it equivalent to the DC current, so that the formula for current and power can be used. So we have to find out here peak voltage of an AC supply at 300 volt. So from this derivation we came to know in the previous question that IRMS is equals to Im, or the peak current, divided by root 2. So here we have to find out what is the, now this goes same with the voltage, that is VRMS would be equal to V peak divided by under root 2. Now the question asked what is the RMS value of voltage, that is VRMS. We have to find out VRMS, and we have been given the peak voltage of 300 volt. So upon using this formula we will get to know that the VRMS is equals to 212.1 volt, and the second question was the RMS value of the current is given and we have to find out peak current. So again using this formula, in this question we have been given the RMS value, so we will have to find out Im. So rearranging this we will get to know that Im, or the peak current, is equals to 14.14 ampere. Thank you. The question says that a 44 millihenry inductor is connected to 220 volt 50 Hz AC supply. Determine the RMS value of the current in the circuit. Now we can pictorially represent this question in this form. Like this is the AC supply of 200 volt and 50 Hz, and the inductor is connected in a series circuit, and the value of inductance is 44 millihenry. Now we have to calculate what is the RMS value of the current in the circuit.
Now if we make it equivalent to the DC circuit, then we can see that we have found out the questions, we have found out the solution of the questions in which this was the resistance and this was the cell. So inductor also possesses some resistance that is known as inductive reactance XL, and that is defined as omega times L, where L is the inductance and omega is the 2 pi by T or 2 pi times frequency. Now this inductor will pose this much quantity of resistance, and the inductive reactance is also having the same unit of ohm. Now RMS current would be equal to Vrms by XL, as XL is representing the resistance in the circuit. So we can find out the RMS current using this formula, that is Vrms by XL. We haven't given the Vrms, that is 220 volt, and XL we have to find out, that is inductive reactance. Now inductive reactance can be found out as we have been given the value of L, that is 44 millihenry, and we haven't given the value of omega as well, because omega, as I said, that it is 2 pi times frequency. So 2 pi is 2 into 3.14 times frequency is given, that is 50 hertz. So the value of XL is going to be 2 pi 50 multiplied by 44 into 10 to the power minus 3, because it is 44 millihenry. Now upon calculating, we will get the value of XL as 13.82 ohm. Now IRMS is equals to Vrms divided by XL. So Vrms is equals to 220 volt, which is given in the question, and XL is 13.82 ohm. So the answer would be 15.92 ampere. Thank you. The question says that a 60 microfarad capacitor is connected to a 110 volt 60 hertz AC supply. Determine the RMS value of the current in the circuit. Now again, this question is similar to the previous question. Again, this capacitor is going to resist some kind of current, and that resistance is given by capacitive reactance, that is XC, and it is defined as 1 by omega C, where omega is 2 pi times frequency. Now again, since this represents the resistance in the circuit, we can give the expression for current as voltage divided by resistance, that is IRMS is equals to Vrms by XC. Now here we have to find out the capacitive reactance, that is XC, and since Vrms is given, we will substitute in the given formula and find out the value of IRMS. Now calculating XC, we will get the value of 44.2 ohm. Now calculating IRMS, that is current, using the formula Vrms by XC, we will get a value of 2.49 ampere. Thank you. The question says that in exercises 7.3 and 7.4, what is the net power absorbed by each circuit over a complete cycle? Explain your answer. Now in both these exercises, we saw that in exercise 7.3 there was an inductor in the series with the source EMF, and in exercise number 7.4 we saw that there was a capacitor in series with the source EMF. Now we have to find out what is the net power absorbed by each circuit over a complete cycle. We have to explain this answer. Now we know that power in AC circuit is given by the formula, that is IRMS multiplied by Vrms multiplied by cos phi, where phi is the phase difference between the source and the circuit. Now for a purely reactive circuit, let us assume that the first case of 7.3, that is the inductive circuit, we saw that current lags by the voltage of pi by 2, or the phase difference between the source current and the circuit is pi by 2. Now similarly, we saw that in the capacitive circuits, the current leads the voltage by pi by 2. That is, here the current is leading by pi by 2. Now in both the cases, we saw that there is a phase difference of pi by 2. Now average power, as discussed earlier, is given by Vrms times IRMS times the cos of phase difference. Now cos of pi by 2 is also always going to be equal to 0, since cos pi by 2 is 0. So we can say that power average is equals to 0 in purely reactive circuits. Thank you. The question says that a charged 30 microfarad capacitor is connected to a 27 microhenry inductor. what is the angular frequency of free oscillation of the circuit? Now free oscillations happen when the energy exchange between capacitor and a charged capacitor and an inductor is happening in the circuit. Now this only happens in purely reactive circuit. Now a capacitor and an inductor forms an oscillatory circuit with energy exchange between the electric and magnetic fields. Now angular frequency of the oscillation is determined by this governing equation. So this is basically the implication of Kirchhoff's law. So we know that EMF around the inductor is given by L di by dt. Now dq by dt is equals to L, so it is L di by dt. That is the double differentiation of charge will give us the, with respect to time, will give us the differentiation of current with time. That is L di by dt plus q by v. This is the potential difference across the capacitor. Now we will come to the conclusion that omega from this governing equation is 1 by LC. That is the angular frequency of natural oscillation in this reactive circuit is going to be 1 by under root LC. Now upon substituting this in the given formula, we will come to know that omega is equals to 1.1 into 10 to the power 4 radians per second. Thank you. The question is saying that a series LCR circuit with resistance of 20 ohm, inductance of 1.5 Henry and capacitance of 35 microfarad is connected to a variable frequency of 200 volt AC supply. When the frequency of the supply equals the natural frequency of the circuit, what is the average power transferred to the circuit in one complete cycle? Now this question can be pictorially represented like this, where this is the power supply, AC power supply of 200 volts, and the frequency is variable over here. Now we have to find out the frequency at which the natural frequency of the circuit meets or the resonance happen. And at resonance, what is the average power transferred to the circuit in one complete cycle? Now we know that resonance in the LRC circuit, that resonance occurs when the inductive reactance equals the capacitive reactance, or mathematically we can represent it as inductive reactance is equals to capacitive reactance. When the inductive reactance and the capacitive reactance matches, the impedance is equals to resistance, or it is purely resistive. So upon equating these two quantities, we will get omega, or the frequency, is equals to 1 by under root LC. Now we can find out the frequency at which the resonance happens by this formula, applying this formula, and after that the power given to the circuit, we have to find out what is the average power transferred to the circuit in one complete cycle. Now when this happens, since the impedance is equals to the resistance of the circuit, so power would be equal to V square by Z, or Z can be equivalent to resistance because there is no other resistance that is happening in the circuit. So R will be equal to, or Z will be equal to 20 ohm. Now upon using this formula for omega, we will find out the value of the resonance frequency about 1380.2 radians per second, and power, we can use this formula of V square by Z, and that will give us, since this is the given quantity 200 volt and Z is equals to the resistance, that is 20 ohm, we will get a value of 2000 watts. So at resonance in this LCR circuit, the average power transfer to the circuit is in one complete cycle is going to be 2000 watts. Thank you. The question says figure 7.17 shows a series LCR circuit connected to a variable frequency 230 volt source, where inductance is 5 Henry, capacitance is 80 microfarad and resistance is 40 ohm. We have to determine the source frequency which drives the circuit in resonance, obtain the impedance of the circuit and the amplitude of the current at the resonant frequency, and determine the RMS potential drop across the three elements in the circuit. Show that the potential drop across the LC combination is 0 at the resonant frequency. Now we know the driving condition for resonance is the frequency of the source matches the frequency of the circuit. So that is the main condition of resonance. And at resonance, the inductive reactance is equals to capacitive reactance, and upon rearrangement for omega, there is the angular frequency, we will get the value of omega is equals to 1 by under root the inductance multiplied by capacitance. And at resonance, the impedance is equals to R, because we know the formula for impedance is under root R square plus capacitive reactance minus inductive reactance whole squared. Now when at resonance Xc equals XL, this quantity becomes 0, so Z is equals to R. So at resonance the impedance is equals to R, or Z equals to R. Now current at resonance is given by voltage divided by the impedance or the resistance, and the peak current similarly is defined by the peak voltage divided by the resistance. And potential drop at resonance is given by VR is equals to Im multiplied by R, where Im is the peak current and R is the resistance. Similarly, VL, that is the potential difference, potential drop across the inductor, is equals to Im multiplied by XL, where XL is the inductive reactance. Similarly, the potential drop across the capacitor is equals to Im multiplied by XC, where XC is the capacitive reactance. So we have to calculate the resonant frequency, we have to calculate the impedance of the circuit and the amplitude of current at the resonance frequency, that is Im, we have to find out in the second question. We have to find out omega in the first question, and we have to find out potential drop across these three components, that is the resistance and capacitor and the inductor. So omega naught, or the resonant frequency, is given by 1 by under root LC. Upon substitution we will get to know that it is equals to 50 radians per second. And as discussed earlier, at resonance impedance is equals to resistance, and that will be equal to 40 ohm, because we have been given that the value of resistor, the resistance of resistor is equals to 40 ohm. So Z will be equal to 40, and the peak current is given by peak voltage divided by R. Now unless specified, the given potential difference is always the RMS. So for calculating the peak voltage, we will multiply it with root 2. So root 2 multiplied by 230 will be the Vm, or the peak voltage, divided by resistance, that is 40, will give us 8.13 ampere. That is Im, the peak current would be 8.13 ampere. So we have solved this question A and B. Now we have to determine the RMS potential drop across the three elements of the circuit. So we have to find out IRMS for that. So IRMS is equals to peak current divided by root 2, and this will give us 5.75 ampere. So potential drop across the resistor would be equal to IRMS multiplied by R. That will give us 230 volt, because R is 40 and 40 multiplied by 5.75 will give us 230 volt. And VL, that is the potential drop across the inductor, is equals to IRMS multiplied by inductive reactance. This will give us 1437.5 volt. Similarly, the potential drop across the capacitor would be given as IRMS multiplied by capacitive reactance. This will give us 1.37.5 volt again. We have calculated XC as 1 by omega times the capacitance, that is 80 microfarad. 80 microfarad, yes. Now we see that VL is equals to VC. Potential drop across the inductor and the capacitor is equals to 0. Thank you. The question is saying that figure 8.5 shows a capacitor made of two circular plates, each of radius 12 cm and separated by 5 cm distance. The capacitor is being charged by an external source not shown in the figure. The charging current is constant and is equal to 0.15 ampere. Now we have to calculate the capacitance and the rate of change of potential difference between the plates, and we also need to obtain the displacement current across the plates. And the third, we have to tell whether Kirchhoff's first rule or the junction rule is valid at each plate of the capacitor. Now we know that capacitance is defined as C equals to epsilon naught A by D, which depends upon the geometry of the plate. Here we have been given that the radius of each plate is 12 cm and they are separated by 5 cm distance. That is, the radius of this plate is 12 cm and they are separated by 5 cm. We also know that rate of change of potential difference is dV by dt. Now V in terms of the capacitance is defined as Q by C, where Q is the quantity of charge. Now if we differentiate V with respect to t, then we will come to the expression of 1 by C dQ by dt, and we can write dQ by dt as I, that is current. So rate of change of potential difference would be equal to I by C. Now let's find out the expression for displacement current. Now we know that displacement current is defined as epsilon naught d phi E by dt, or the rate of change of flux, and flux is defined as E dot A, the dot product of electric field and the area vector. Now E is defined as sigma by epsilon naught, where sigma is the charge density of the plate, so we can write it as Q by A. Now if we find out flux, then A will get cancelled out. Now flux would be Q by epsilon naught. Now displacement current is defined by epsilon naught d phi by dt. After substituting this flux in this expression, we will get epsilon naught multiplied by d Q by epsilon naught. So it would be cancelling the epsilon naught, and we will get the value of displacement current equals to I. So the displacement current would be equal to conduction current. Now let's compute capacitance. Capacitance was epsilon naught A by D. After substituting the area and the displacement and the distance between them, we will come to the conclusion that the capacitance is equals to 8 picofarad. Now computing the rate of change of potential difference dV by dt, we already know from here we have calculated that dV by dt would be equal to current by capacitance. Now substituting that in this expression, we will get a value of 1.87 into 10 to the power 10 volt per second. Now computing displacement current, we already saw from this derivation over here that displacement current would be equal to conduction current. So displacement current would be equal to 0.15 ampere. Now it follows the Kirchhoff's junction rule, as at each plate the conduction current flows into the one side while the displacement current flows out of the other side. The question says that a parallel plate capacitor in figure 8.6 made of circular plates, each of radius 6 cm, has a capacitance C is equals to 100 picofarad. The capacitor is connected to a 230 volt AC supply with an angular frequency of 300 radians per second. Now we have to calculate what is the RMS value of the conduction current, and is the conduction current equal to the displacement current. And in third question, we have to determine the amplitude of B at the point 3 cm from the axis between the plates. Now we know that capacitance is a relationship between the charge and the potential difference across the capacitor, and it is given by C equals to Q by V, where Q is the charge and V is the potential difference. And the conduction current for AC voltages, the RMS conduction current is equal to IC equals to omega C by omega C V RMS. Here it comes from V RMS divided by the impedance XC, and we know that XC is for the capacitor is 1 by omega C. So we will get the conduction current as omega C V RMS, and the peak current is related to the RMS current as I peak equals to root 2 I RMS, and magnetic field at a distance r from the axis between the plate is mu naught I peak r by 2 pi r square, where r is the distance of the point from the axis of the plate, and this capital R is the radius of each circular plate. Let's calculate the conduction current. We haven't given the capacitance, that is 100 picofarad, and VRMS is 230 volt, and omega, the angular frequency is 300 radians per second. So RMS current would be equal to IC omega C VRMS. Now substituting in this formula, we will get a value of 6.9 microampere. So the conduction current is going to be equal to 6.9 microampere. Now let's calculate the displacement current. So displacement current arises due to the changing electric field in the capacitor, and Maxwell's equation predict conduction current equals to displacement current. Now since the capacitor is connected to an AC source, the time varying electric field ensures IC equals to ID. So yes, IC is equal to ID here. The conduction current equals the displacement current. Now calculation for the peak magnetic field. Now for calculating the magnetic field amplitude, we will use the peak current. So we will use this formula mu naught I peak r by 2 pi r square. So substituting the values in this formula, we will get a value of 1.63 into 10 to the power minus 11 Tesla. Thank you. The question is saying that what physical quantity is same for X-rays of wavelength 10 to the power minus 10 meter, red light of wavelength 6800 angstrom, and radio waves of wavelength 500 meter. So basically it is saying that what quantity is same for all these electromagnetic radiations, or what quantity is same for electromagnetic radiations. So electromagnetic radiations has same speed because they all travel with the same speed of approximately 3 into 10 to the power 8 meter per second. Now this constancy arises from the Maxwell equation, which predicts the electromagnetic waves are self-sustaining oscillations of electric and magnetic fields. We also know that C, or the speed of electromagnetic wave, is equals to frequency times lambda. So this speed is going to be same. What changes is wavelength or the frequency. Thank you. The question says that a plane electromagnetic wave travels in vacuum along z direction. What can you say about the direction of electric fields and magnetic field vectors? Is the frequency of wave, if the frequency of wave is 30 megahertz, what is its wavelength? Now we know that electromagnetic waves consist of oscillating electric and magnetic fields that are perpendicular to each other and from the direction of the wave propagation. These fields are described by Maxwell's equation, which predict that E and B are perpendicular to each other. Both E and B are perpendicular to the propagation vector k, that is the direction in which wave is propagating, that is in the z direction. So both E and B vector is going to be perpendicular to the z axis or the k cap direction. Now for a wave propagating in z direction, E would be perpendicular to the z and B is also going to be perpendicular to z, and E and B are mutually going to be perpendicular. So you can assume that E is along the x axis and B is along the y axis. Now we have to find out the wavelength of the wave whose frequency is going to be 30 megahertz. So the frequency of the wave is given as 30 megahertz or 30 into 10 to the power 6 hertz. The formula for calculating wavelength is the speed divided by frequency. So speed is going to be 3 into 10 to the power 8 meter per second, which is going to be constant, and the frequency is 30 megahertz. So after dividing it, we will get a value of 10 meter, that is wavelength is 10 meter. Thank you. The question is saying that a radio can tune into any station in 7.5 megahertz to 12 megahertz band. What is the corresponding wavelength band? So we know that the wavelength can be defined by the speed divided by frequency, and we have to find out here that given the range of frequency, what is the range of wavelength? Wavelength band means the range of wavelength. So here lambda can be calculated by dividing the speed with frequency. So let's calculate. The highest frequency is 12 megahertz and the lowest frequency is 7.5 megahertz. So corresponding with the lowest frequency, there will be the higher wavelength, that is for frequency maximum 12 megahertz. The wavelength is going to be 25 meter, and for the lower frequency, lambda is going to be maximum, that is 40 meter, because lambda equals to c by nu and nu equals to c by lambda. So they both are inversely proportional. So if frequency is maximum, lambda is going to be minimum, and if frequency is minimum, then lambda is going to be maximum. So we come to the conclusion that the wavelength band is going to be 25 meter to 40 meter. Thank you. The question says that a charged particle oscillates about its mean equilibrium position with a frequency of 10 to the power 9 hertz. What is the frequency of electromagnetic waves produced by the oscillator? So we know that accelerated charges radiate electromagnetic waves, and the frequency of the electromagnetic waves equals the frequency of the oscillation of the charge. So we can say that the frequency of the wave produced is identical to the frequency of the oscillating charge, and it is going to be same, that is 10 to the power 9 hertz. So the frequency produced, the frequency of the electromagnetic wave produced is going to be of the magnitude 10 to the power 9 hertz. Thank you. The question says that amplitude of magnetic field part of the harmonic electromagnetic wave in vacuum is B naught equals to 510 nanotesla. What is the amplitude of electric field part of the wave? So we know that electric field and magnetic field are related, as electromagnetic wave consists of oscillating electric and magnetic fields. These fields are perpendicular to each other, and they are also perpendicular to the direction of the wave propagation. And the amplitude of the field is given by, they are related by E naught equals to CB naught. That is, electric field magnitude is equals to the speed of electromagnetic wave times the magnitude of magnetic field. Now here speed of the electromagnetic wave is 3 into 10 to the power 8 meter per second. Now we have been given the value of B naught, that is the magnitude of magnetic field. We have to find out the value of E naught. So in this formula, only E naught is the unknown. We know the value of C and we know the value of B naught as it is given in the question. So substituting in this formula, we will get a value of E naught, that is the magnitude of electric field, as 153 Newton per Coulomb. Thank you. The question says that suppose that the electric field amplitude of an electromagnetic wave is E naught equals to 120 Newton per Coulomb and its frequency is 50 megahertz. We have to determine the magnitude of magnetic field, omega, angular frequency, k wave number, and the lambda, that is the wavelength. So we know that B naught equals to E naught by C, or the magnetic field magnitude is equals to the electric field magnitude divided by the speed of electromagnetic wave. So upon using this formula, we will get the value of B naught, that is 4 into 10 to the power minus 7 Tesla. For angular frequency, we know that angular frequency is 2 pi by T, or 2 pi nu, or 2 pi into frequency. We have been given the value of nu, so we can easily calculate angular frequency omega over here, that is 3.14 into 10 to the power 8 radians per second. For wavelength, we know that the formula is the speed of electromagnetic wave divided by the frequency. After substituting the values, we will get the value of 6 meters. So this is the wavelength. For wave number, we know that it is 2 pi by lambda, or the wavelength. So after substituting the values, we will get a value of 1.05 radians per meter. So this is the wave number. Having calculated all these values, we have to now find out the expression for E and B, that is electric field and magnetic field. So we assume that electromagnetic wave is moving in the x direction. So electric field will be along y direction and the magnetic field will be along z direction. So this is the general expression for the electric field and the magnetic field. Now substituting the values of E naught, that is the peak magnitude of electric field, and k, that is the wave number, and omega, that is the angular frequency, we will get the expression for electric field of this electromagnetic wave. Similarly, substituting the values of corresponding values of the magnetic field, that is the magnetic field magnitude, wave number, and all, we will get the value of the expression for magnetic field in this electromagnetic wave. Thank you. The question says that the terminology of different part of electromagnetic spectrum is given in the text. Use the formula E equals to h nu for energy of quantum radiations, photons, and obtain the photon energy in units of electron volt for different part of electromagnetic spectrum. In what way are the different scales of photon energies that you obtain related to the source of electromagnetic radiations? We have to find out photon energy, or the energy of these electromagnetic radiations, and the band is this. For radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays, we have to find out their energy in electron volts, and also we have to find that we have to give a way, we have to tell in what way are the different scale of photon energies that you obtain related to the sources of electromagnetic radiations. So let's start. We know that energy of a photon is given by E equals to h nu, where h is the Planck's constant with the value of 6.63 into 10 to the power minus 34 joules second, and nu is the frequency of the radiation. Now if we relate joule with electron volt, then 1 joule would be equal to 6.242 into 10 to the power 18 electron volt. Now frequency and wavelength are related using this formula, that is C equals to nu times lambda, or we can say that frequency is equals to C by lambda, where C is the speed of the electromagnetic wave and lambda is the wavelength. Now this is the table which represents the electromagnetic spectrum with their wavelength and the energy level. So we can see that as the wavelength is reducing, frequency is increasing and energy is also increasing. We can see that the least energy is of that of the radio waves, which is having a much higher wavelength, much higher than 0.1 meter, and they have frequency of less than 3 into 10 to the power 9 hertz, and they have energy less than 10 to the power minus 5 electron volt. And the gamma rays is having the least wavelength, that is of order of less than 10 to the power minus 11 meter. They are having higher frequencies, 3 into 10 to the power 19, and the energy, they are having the highest energies of 1.24 into 10 to the power 3 electron volt. Now we in this pattern we see that the photon energy increases with frequency and decreases with wavelength, and also we see that higher frequency electromagnetic waves are more penetrative and interact strongly with the matter. Now these kind of these diversity in photon energies allows electromagnetic waves to be utilized in various applications. Thank you. The question says that in a plane electromagnetic wave, electric field oscillates sinusoidally at a frequency of 2 into 10 to the power 10 hertz and the amplitude of 48 volt per meter. Now what is the wavelength of the wave? What is the wavelength of the wave and what is the amplitude of oscillating magnetic field? Show that the average energy density of E, that is electric field, equals the average energy density of magnetic field. We have been given the speed of electromagnetic wave as 3 into 10 to the power 8 meter per second. Now we know that electromagnetic waves consist of oscillating electric and magnetic fields which are perpendicular to each other, and they are also perpendicular to the direction of the wave propagation. Here we have to find out the wavelength of the wave and the amplitude of the oscillating magnetic field, and that is B naught. We have to find here B naught, and we have to find out lambda over here. And we also need to show that the average energy density of E, electric field, equals the average energy density of magnetic field. So the formula for calculating wavelength is speed of the wave divided by frequency, but before that we should clear some of the facts. The speed of electromagnetic wave in vacuum is 3 into 10 to the power 8 meter per second, and the relationship between electric field and magnetic field is given by B naught, that is the magnetic field is equals to electric field divided by the speed of this electromagnetic wave. Now energy density of electric field and magnetic field is given by the electric field energy density is epsilon naught, the magnitude of electric field square divided by 2. Similarly for magnetic field, the energy density is given by the magnitude of magnetic field square divided by 2 mu naught, where mu naught multiplied with epsilon naught is equals to 1 by c square. So let's calculate the wavelength. The frequency of the wave was 2 into 10 to the power 10 hertz, and the speed of the light was c equals to 3 into 10 to the power 8 meter per second. So for formula for calculating wavelength is c by frequency, that is the speed of the wave by frequency. Now lambda, upon substituting the values over here, we will get a value of 1.5 into 10 to the power minus 2 meter. So the wavelength is going to be equal to 1.5 centimeter. Now let's find the magnitude of magnetic field. So we will use the formula, this formula over here, B naught equals to E naught by C. Electric field amplitude is given as 48 volt per meter, and the speed of light is given as 3 into 10 to the power 8 meter per second. So upon substituting the values over here of E naught and C, we will get a value of B naught, that is the magnitude of magnetic field, as 1.6 into 10 to the power minus 7 Tesla. Now we have to show that the energy density of electric field and magnetic field are same. So we will see the expression for electric field density, that is epsilon naught E square by 2. Similarly for magnetic field it is this. Now using epsilon naught into mu naught equals to 1 by c square, and this the relationship between electric field and magnetic field magnitude, we will come to a conclusion that EB is equals to UE, or the energy density of electric field is equals to energy density of magnetic field. Thank you. The question says that a small candle 2.5 centimeter in size is placed at 27 centimeter in front of a concave mirror of radius of curvature 36 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image, and describe the nature and size of the image? If the candle is moved closer to the mirror, how would the screen have to be moved? So in this question,
a concave mirror is given of a defined curvature, radius of curvature, and the object distance from the pole of the mirror is given, that is 27 centimeter, and the height of the object is given, that is 2.5 centimeter in size. At first we have to find out at what position should the screen be placed so that we can obtain the sharp image. So in a simple terms, it is asking the position V of the image from the mirror. And the second question is saying that describe the nature and size of the image. And the third question is, if the candle is moved closer to the mirror, how would the screen have to be moved? So the third question is saying that if we move this candle towards the mirror, then how would the position of this image? So let us proceed. So we can use the mirror formula over here, which is given by 1 by f equals to 1 by u plus 1 by v, where f is the focal length and u is the object distance and v is the image distance. So focal length of this mirror is given, that is of 36 centimeter by 2. So we can find out the focal length as 18 centimeter. Object distance is given, since it is in front of the mirror, so u is going to be negative, and it is going to be negative of 27 centimeter. So using this formula, we can calculate the value of v, because only v is unknown over here. So after we get the value of v, we can use it in the formula of magnification. So magnification we will get by minus of v by u, where v is the image distance and u is the object distance. So let's calculate the value of v first. So substituting the values of u and f in this equation, we get the value of v, that is v equals to minus of 54 centimeter. That is, the position of image is in the same side of the mirror as that of the object, because it is negative in size. Now we can negative in magnitude. Now we can calculate the value of m, that is minus of v by u. So substituting the values of v and u in this formula, we will get a value of minus 2, that is, the object is magnified and it is real. We can also see from the image diagram over here. So the at first we have taken the parallel to the principal axis, the array parallel to the principal axis, which is reflected passing through the focus, and the second ray is taken passing through the center of curvature. So it will retrace the incident ray, and since two ray must meet to form an image, so the image will form over here with a value of v equals to minus of 54 centimeter. Now we have got the value of v, that is where should the screen be placed. We have to find out what is the nature and size of the image. So since we have got the value of m, we can find out the we can find out the size of image, that is equals to magnification times the original size of the object, that is 2.5 times 2, that is 5 centimeter, and nature is real, the image is real. And now we have to find out, if the candle is moved closer to the mirror, how would the screen have to be moved. So that is, if this candle is approaching f and also approaching pole, then how would the position of image be moved. So let us make the diagram over here. So at first case, we assume that the candle has been placed at focus. So we see that these two rays have become parallel. So the image will be forming an infinity. So we can say that if the candle is moved towards the focal length, the position of image will be towards infinity. And if the candle is moved beyond f towards the pole, so we can see that the image is forming, that is virtual. No real image can be formed over here, and it is virtual and it is magnified. Thank you. The question says that a 4.5 centimeter needle is placed 12 centimeter away from the convex mirror of focal length 15 centimeter. Give the location of the image and the magnification. Describe what happens as the needle is moved further away from the mirror. So here the height of the object is given, that is 4.5 centimeter, and the value of the position away from the mirror is also given, that is of 12 centimeter, and the focal length of the mirror is also given. So we have to find out the location of the image, that is the value of v, and the value of m, that is magnification. So we know from the mirror formula that 1 by f equals to 1 by u plus 1 by v, where f is the focal length and u is the distance of the object from the mirror, and v is the distance of image from the pole of the mirror. And the value of the formula for magnification is minus of v by u. So let us substitute the values. We have been given the value of u, we have been given the value of f, we have to find out the value of v, that is the position of image. So
since focal length of convex mirror is positive, so f would be equal to plus of 15 centimeter and u would be equal to minus of 12 centimeter. So finding the unknown v, we will get the value of 6.67 centimeter. Now we have to find out the magnification, so we will substitute the value of u and v in this magnification formula and we will get the value of equals to plus of 5 by 9. Now let's revisit the ray diagram. Here we have taken two rays from the top of the needle. So one would be along the center of curvature, so it will retrace its incident path, and the another parallel to the principal axis, so it will reflect along the focus of the convex mirror, and if we retrace it behind the mirror, we will get a virtual image. So the nature of image is virtual. The image is diminished because the value of m is less than 1, so the image will be diminished, and the size of image we can calculate with the value of magnification, and the formula is magnification multiplied by original size of the object, and we will get the value of 2.5 centimeter. So we can also see that as the object distance is increased, or as the needle is moved away from the mirror, the image will tend towards the focal point, diminishing in size. Or if we move this object away from this mirror, so this image will move towards the focal point, and the magnification will reduce more and it will become more diminished. Thank you.
This question talks about the apparent height and the real height problem. So in this question, there is a beaker and it is filled with water at first, and the height of this beaker is 12.5 centimeter, and at the bottom of the beaker there is a needle, and if you see from the top, then the needle is appearing to be at a depth of 9.4 centimeter. That is the apparent height of this needle is going to be 9.4 centimeter when the beaker is filled with water. We have to find out what is the refractive index of water from the given data. So we have been given the real depth of the tank, that is 12.5 centimeter, and the apparent depth, that is 9.4 centimeter. Now we know that refractive index can be related by real depth and apparent depth, as the refractive index would be equal to real depth by apparent depth. So we have to find out refractive index of water at first. So the real depth is 12.5 centimeter and the apparent depth is 9.4 centimeters, so the refractive index would come out to be 1.33 centimeter. Now the question was saying that when the water is replaced with the fluid of refractive index 1.63, then what would be the apparent depth? And it is not asking directly what is the apparent depth, it is asking by what distance will the microscope move so that it can focus again. So in a nutshell, it is asking what is the apparent depth, what is the new apparent depth. So if we replace the value of refractive index to be 1.63 now in this formula, then we can find out apparent depth, as we haven't given the real depth, that is 12.5 centimeter. So apparent depth would be equal to 12.5 centimeter by 1.63. Now if we calculate this, then we can get a value of 7.67 centimeters. So the new apparent depth is going to be 7.67 centimeter if the water is replaced by another liquid. Now this means that the previous apparent depth was 9.4 centimeter as given. Now the new apparent depth is going to be 7.67 centimeter. So the question was asking that what distance should we move the microscope so that it can focus again. So the difference of these two apparent depth is the distance by which we need to move it so that we can focus again. So the difference between 7.67 and 9.4 centimeter is going to be equal to 1.73 centimeter. Thank you. The question says that the figure 9.27 A and B show refraction of a air in the air incident at 60 degree with a normal to the glass air and the water air interface respectively. Predict the angle of refraction in glass when the angle of incidence in water is 45 degree with the normal to the water glass interface. Now we have been given two cases of air glass interface and water air interface, and we have to find out what is the angle of refraction in the glass water interface when the ray is incident in the water and going to the glass media. So we will use Snell's law over here. Here for convenience I have taken the refractive index of glass as N1 and refractive index of air as N2 and refractive index of water as N3. Now let's revisit the Snell's law. So it says that when a ray is moving from one media to another, let's say that it is incident in the media of refractive index N1 and it is going in the media of refractive index N2, and it is making an angle of I with the normal in the incident media, and it is going to make an angle of R. So by Snell's law we know that N1 sine I would be equal to N2 sine R. Now we will use this in order to find the alpha, that is the angle of refracted ray in the glass media. So using Snell's law in the first diagram, we see that N1 sine 35 degree is going to be equal to N2 times sine 60 degree. Similarly, equations 2 we will get from the second figure, as N2 sine 60 degree is going to be equal to N3 sine 47 degree. Now similarly we will see here that N1 sine alpha is going to be equal to N3 sine 45 degree. Now solving equation 1 and 2, we will get N1 sine 35 degree is going to be equal to N3 sine 47 degrees. Now we will use this and the third equation to find out the value of sine alpha, because we can cancel out N1 and N3 from these two equations. So by dividing equation 3 by 4, we will get sine alpha by sine 35 degrees equals to sine 47 degrees by sine 45 degree. Now substituting the values, we will get sine alpha is equals to 0.6 approximately, and now if we take inverse, then we will get a value of 36.8 degrees. So we see that the value of alpha is going to be equal to approximately 36.8 degrees. Thank you. The question says that a small bulb is placed at the bottom of the tank containing water at a depth of 80 centimeter. What is the area of surface of water through which light from the bulb can emerge out? Refractive index of the water is 1.33, and we have to consider the bulb as a point source. Now here we see that it is a water tank. I have symbolized it with the black ink. It is 80 centimeter deep, and in the bottom of the tank there is a bulb which is a point source of light, and we have to find out of what surface area the light will come out. So we will use here the theory of total internal reflection. If we assume there is a ray that is emerging out of the bulb and it is making an angle of I, so in order for that ray to emerge out, it should be less than the critical angle. We know that the critical angle is defined as the angle of incidence, which provides 90 degree to the angle of reflection. That is, if IC is the critical angle, then the refracted ray would not cross the interface and it will just remain on the boundary like this, OA, and the ray will be on the boundary. And if the angle of incidence is greater than critical angle, then the ray will be refracted in the same media. And if it is less than IC or the critical angle, then the ray will come out. Now we have to find out in what area does the ray come out of the tank. Now, since using the Snell's law, we can say that mu of water and sine of I would be equal to, we first will find out the critical angle. So IC will be equal to, let us, the refractive index of the air is 1, so 1 times sine 90 degree. This is 90 degrees, so we will take 90 degree. Now we will find out sine IC. Now this will give us sine IC equal to 1 by 1.33, because we know that mu is 1.33. Now if we figure out what is IC, then IC will be sine inverse 1 by 1.33, and this will come out to be equal to 48.75 degree. So we have got a value of IC in this triangle AOB. We have got the value of IC. Now in order to find out this area, we must know the radius, that is OB, so that we can find out the area. Now radius OB can be found out using the trigonometric relation, that is tan of IC, that tan of IC would be equal to the perpendicular, that is OB, divided by AB.
Here we have to find out OB. We know that AB is the height, that is 80 centimeter, which is given. OB would be equal to tan of 48.75 degrees multiplied by AB, that is 80 centimeter, and which will give us something around 91.2 centimeter, that is radius of the circle. Now in order to find out area, we can use the formula of area of circle, that is pi r square, and which will give us 26110 centimeter square, or we can say that 2.61 meter square. The question is saying that a prism is made of a glass of unknown refractive index. A parallel beam of light is incident on the face of the prism. The angle of minimum deviation is measured to be 40 degree. What is the refractive index of the material of the prism? And the refracting angle of the prism is 60 degree. If the prism is placed in water, refractive index of 1.33, predict the new angle of minimum deviation. So here we have been given the value of minimum deviation. Let us symbolize it with dm. We have been given it is the value of 40 degree. We have to find out the refractive index of this prism, and one more thing we have been given, the refracting angle of the prism, that is the vertex angle, it is given as 60 degree. So we can symbolize it with a as 60 degree. Now we know why the definition of the minimum deviation, that dm is equals to 2 times I minus a. I is the angle of incidence and it is equals to the angle of emergence for the minimum deviation. We know that the refractive index of the prism is given by sine of a plus dm by 2 divided by sine of a by 2. Now here we have been given the value of a and dm both. So we can simply put it as sine of a plus dm would be equal to 100 by 2, that is 50 degrees, and the value of a is 60 degrees, so it will be equal to sine of 30. Now this will give us a refractive index of 1.53. So we have successfully found out the refractive index of the prism. Now we have to find out what if the prism is placed in water. What will be the new angle of minimum deviation? Refractive index of the prism, that is 1.53. This formula will turn out to be 1.53 by that of the incident media, that is on the water, 1.33. This will give us sine of a. It will be constant because the prism is same, and that is 60 degree, plus dm we have to find out. So dm will be unknown, by 2 divided by sine of a by 2, that is 30 degree. Now after solving this, we will come to a conclusion that dm is equals to 10.32 degree. So here this formula is used. Here the refractive index is refractive index of the prism with respect to the media in which the prism is kept. That's why we use this formula in the case of water, that is the refractive index of prism with respect to media in which the prism is kept. The question is saying that here we have to manufacture a double convex lens from the glass of refractive index of 1.55, and we have been given the focal length that is required, and it is of f equals to 20 centimeter. Since we know the lens maker's formula, we'll be applying it over here. It is saying that we have to make a double convex lens of focal length equal to 20 centimeter. So we know the lens maker's formula, that is 1 by f equals to n minus 1. Here n is the refractive index of the glass with respect to the media in which it is kept, 1 by r1 minus 1 by r2. Here r1 and r2 are the radius of curvature of this side versus this side. Substituting the values, we will get, since it is a convex lens, so focal length is going to be positive. So 1 by 20 would be equal to, refractive index is given, that is 1.55 minus of 1 by r1. Here r1, the radius of curvature is measured from the right hand side because it is curved, and its center would be in the right side, so it is going to be positive. So 1 by r, since r1 and r2 magnitude is going to be same because it is given over here with the both faces of same radius of curvature, so r1 would be equal to r2 in magnitude minus r2. Since the center of the r2 curvature is going to be on the left hand side, so we will term it as 1 by minus r. Here after solving this, we will get 1 by 20 centimeter is equals to 0.55 multiplied by 2 by r, and this will give us the value of r as 22 centimeter. So the radius of curvature of the glass required is 22 centimeter. Thank you. A beam of light converges at a point P. So let us assume that this is a point P, and a beam of light is converging at this point from the left hand side. And what if we keep concave lens and convex lens? The first is convex lens of focal length 20 centimeter, and the second case we have got a concave lens of focal length 16 centimeters. So here f is equals to plus 20 centimeter, and here f equals to minus of 16 centimeter. Now the distance between these two is 12 centimeter, that is given. So we have to find out where will the beam converge. So in the first case, we will use the lens formula, that is 1 by f equals to 1 by v minus 1 by u. Here object is virtual, that is light was coming to that point, but now it is obstructed, so it is virtual. So 1 by f is equals to, in this case, that is in convex case, 1 by f is going to be 1 by 20. 1 by v, we have to find out 1 by v, and u is 12 centimeter plus or 12 centimeter. So here solving this, we will get a value of 1 by v as 2 by 15, or v as 7.5 centimeter. So what we see here is that, and it is at 7.5 centimeter away from the lens of this convex lens. Now in the second case, we have got a concave lens. Here again we have to find out the distance, where will the light converge. So here again we will use the lens formula, that is 1 by v, 1 by f equals to 1 by v minus 1 by u. Now the focal length in the case of concave lens is negative, so we will use 1 by minus of 16 centimeter equals to, we have to find out the image distance, 1 by v minus object, that is virtual, and it is again 12 centimeter away from the pole of the lens. So, and the distance is going to be positive, so we will use 12 centimeter over here. Now solving this, we will get 1 by v is equals to 1 by 48, that is v equals to 48 centimeter. So again it would be 48 centimeter to the right of the lens, and in the first case it was 7.5 centimeter to the right of the lens. The question is saying that an object of size 3 centimeter, that is the height of the object is given 3 centimeter, is placed 14 centimeter in front of the concave lens. Here concave lens, the subject is concave lens, and the object distance is 14 centimeters. So we can write u equals to 14 centimeter in front, that is minus for 14 centimeter would be there, and concave lens of focal length 21 centimeters. So here f is going to be equal to minus of 21 centimeter because it is concave lens. Now describe the image produced by the lens. We have to find out image, and we have to describe the image. It means we have to find out v, and we also need to find out m, because that tells us the nature of image, that is whether it is diminished in size and it is virtual or not. So we have to also comment on what happens if the object is moved further away from the lens. Now what if the object is moved, this object is moved away from the lens, or it is moved on the left hand side, what will happen to the image? Now let us first use the lens formula over here. We will find the value of v, then we will find the value of n, and then we will comment on the nature of the image. So using the lens formula, we have got 1 by v minus 1 by u equals to 1 by f. So here 1 by v would be equal to 1 by u, that is 1 by f is minus of 1 by 21 centimeter, and then u will go on that side, and that too is negative, so it will remain negative of 1 by 14 centimeter. This will give us the value of 1 by v equals to minus of 5 by 42. Thus the value of v is going to be equal to minus of 8.4 centimeter. So the image is on the left hand side of the lens, because we have got a value of negative v. Now let us try to find out the value of magnification. Magnification for the lens is defined as v by u. So substituting the values, we will get minus of 8.4 centimeter divided by the value of u is 14 centimeter, minus of 14 centimeter, and this will give us a value of 0.6. So here magnification is less than 1, that is the image will be diminished, and it is positive, magnification is positive. That means the object is going to be virtual and it is going to be erect. Now let us comment on what happens if the object is moved further away from the lens. Now let us first draw roughly the image, the ray diagram of this. So here let us assume that this is the focus. So a ray parallel will go on from here, and then it will appear to diverge from the focus, and the second ray go from the center. Now the image will be somewhere like this. Now as we move this object away from the focus or away from the lens, let's assume that the object is placed over here. So what we will see is the image will tend towards the focus, because this parallel ray is going to be going in this direction only, but the second ray like this. So we will see that the magnification will drop further on, and as u is increased to infinity, the image distance v will tend towards the focus and the magnification will tend towards 0. Here the question is saying that what is the focal length of the convex lens of focal length 30 centimeter in contact with the concave lens of focal length of 20 centimeter? Is the system converging or diverging lens? Ignore thickness of the lenses. So we have been given thin lenses and we have to find out what is the effective focal length. Now we know that the effective focal length is given by 1 by f effective is equals to 1 by f1 plus 1 by f2 plus so on. Here we have been given only two lenses, so we will take f1 and f2 only. Now here f1 in the case of convex lens is positive and f2 in the case of concave lens is always negative. So let us calculate the value of f effective, and that is going to be equal to 1 by f1, that is 1 by convex 30 minus of 1 by 20. So after adding this we will get a value of minus of 1 by 60 centimeter. So focal length effective is going to be equal to minus of 60 centimeter. So here we see that the focal length effective is negative. That means it is diverging in nature, or we have got a concave length of focal length 60 centimeter. The question says that a compound microscope consists of an objective lens of focal length 2 centimeter and an eyepiece of focal length 6.25 centimeters separated by a distance of 15 centimeter. How far from the objective should an object be placed in order to obtain the final image at the least distance of the distinct vision, that is 25 centimeter, and at infinity? What is the magnifying power of the microscope in each case? Now here we have been given a compound microscope of which objective has a focal length of 2 centimeter and the eyepiece has a focal length of 6.25 centimeter. We have to find out how far from the objective should an object be placed. Like we have to find out the value of u objective in the case VE, that is the image formed by the eyepiece is at minus d. D is the least distance of distinct vision, that is 25 centimeter, and the second case is at VE is equals to infinity, that is the image is forming at infinity, which is good for relaxed eye viewing. Now we have to also find out what is the magnifying power of microscope in each case. We have to also find out the value of m. Now we will use two formulas in this question. The first is lens formula, that is 1 by v minus 1 by u equals to 1 by f. Here I have represented v, fe and fo as a focal length of eyepiece and the objective respectively, and subsequently u and v has been also represented with the subscript of e and o, as e as the eyepiece and o as the objective. Now let us move towards the first case where the image is forming at the least distance of distinct vision, that is 25 centimeter. So we know that in a compound microscope an object is placed over here in front of objective. Now this will form a virtual image between these two lenses, let us say over here, and this virtual image will be treated as a virtual object for eyepiece, and this eyepiece will form the final image, which is somewhere magnified. Now we have to find out the value of u naught in both the cases. So in the first case, the least distance of distinct vision, the image is forming, that is the final image, VE is forming at minus d. So we will use the lens formula for the eyepiece. We have been given the value of VE over here, that is minus of d, that is minus of 25 centimeter. So using the lens formula for the eyepiece, we have got 1 by VE minus 1 by UE is equals to 1 by FE. So d here 1 by V is minus of 25 centimeter. Now 1 by UE is equals to 1 by 6.25. We have been given the value of FE, that is 6.25, and since it is a convex lens, so FE is going to be positive. Now solving for this, we have got a value of UE as minus of 5 centimeter. So it means that the object for the eyepiece should be at minus of 5 centimeter, or with proper sign convention the object should be here with a distance of 5 centimeter from this pole of this lens, that is 5 centimeter. Now
for the image to form at minus t, the object should be here. Now for this lens, what is the distance between this lens and this image? So the image by the objective is going to be treated as the object for this eyepiece. So if the object should be at here, that is at 5 centimeter from the left of the lens, then the image formed by the objective should be at 10 centimeter on the right side of this lens. So V naught, that is the image distance for this objective, should be equal to 10 centimeter. So V naught or the VO is equals to 15 centimeter minus 5 centimeter, that is 10 centimeter. So we have got the value of FO, we have been given the value of FO, that is the focal length of the objective, that is 2 centimeter. We have to find out the value of UO, that is the object distance from the objective. So using lens formula again, we have been given the value of FO and VO, and we have to find out the value of UO. So solving this, we have got a value of U as minus 2.5 centimeter. So the solution of first case is here, that is if the object is kept at 2 centimeter from the lens of the from the left of the objective, then we will get a final image at a distance of 25 centimeter from the left of this eyepiece. Now we have to find out the value of magnification. So magnification in this case, we know the formula for magnification is given by VO by UO multiplied by D by UE. So here VO is the image distance from the objective and UO is the object distance from the objective. D is the distance of distinct vision and UE is the object distance from the eyepiece. So we have all the values over here. We will substitute it and we will get a value of 20x. So when the image is forming at the least distance of distinct vision, then we are getting a magnification power of 20. Now in the second case, the question was final image at infinity. That is, the final image formed by this eyepiece is going to be at infinity. So we know for image to form at infinity, the object will be placed at the focus. So UE, that is object for the eyepiece, is going to be minus FE, and we have been given the value of FE, that is 6.25 centimeter. Focal length of the eyepiece, that is 6.25 centimeter. So let us find out the distance of VO. Distance between the two lenses is 15 centimeter. So VO plus UE, that is, let us understand with this diagram. VO plus UE. VO is the image formed by the objective. VO is the image formed by the objective plus UE, that is, that image is going to be the object for the eyepiece. This will always be equal to 15 centimeter because the distance between the lens is fixed, 15 centimeter. So using this, we will find out the value of VO, that is the image distance from the objective, and this will give us a value of 15 minus 6.25, that is 8.75. Since this is from the right of the objective, so this will be positive. We will put it in the lens equation again, and for finding out the value of UO, so for solving this question, we will get the value of UO as minus of 2.59 centimeter. Now we have got the data for the second case as well, that is when the image is forming at infinity. So using the formula, same formula for magnification, that is VO by UO into D by UE, we will get a value of magnification as 13.51 x. That is, the magnifying power is less when the image is forming at infinity as compared to when the image is forming at the least distance of distinct vision, that is 25 centimeter. I hope you understood this question. The question says that a person with normal near point 25 centimeter using a compound microscope with objective of focal length 8 millimeter and eyepiece of focal length 2.5 centimeter can bring an object placed at 9 millimeter from the objective in a sharp focus. What is the separation between the two lenses? Calculate the magnifying power of the microscope. So in this question, it is simply asking that what would be the distance between these two lenses such that if object is placed at 9 millimeter or 0.9 centimeter in front of the object, the person with a normal near point of 25 centimeter sees that object clearly. So it is simply asking what would be the length between, what would be the distance between these two lenses such that the person can focus it, or the eyepiece can create an image at V equals to 25 centimeter in front of it. So in order to get the length between these two lenses, we will have to find out the distance between the image created by the objective, that is V naught, and the distance between the image and that eyepiece lens, or we can term it as object length UE. So length will be composed of V0, that is the image distance between the objective lens and the image, and UE, that is the object distance from the eyepiece. That will give us the answer. Now we have to also calculate the magnifying power of the microscope. So in order to find out V0, VO, and UE, we will use the lens equation. So we know that using the lens equation on the objective, we know that 1 by V0 minus 1 by U0 is equals to 1 by focal length of that objective. Now using these values that are given for VO, that is 9 millimeter, we will use it as minus 1 by 0.9. So we will get V0 as 36.5 centimeter. Now what is left is calculation of UE, that is the object distance between the eyepiece and the image formed by the objective. So using the lens formula again on the eyepiece, we know the value of VE, that is the image must form at the least distance of distinct vision, that is 25 centimeter in front of the eyepiece, and we haven't given the focal length of the objective, that is 2.5 centimeter, focal length of the eyepiece, that is 2.5 centimeter. So we only need to find UE. So upon calculation we will get a UE is equals to minus of 25 by 11. Now the length, as we saw earlier, would be composed of V0 plus UE, the magnitude of these two values. So after adding these two values, we will get a distance of 9.47. That is, the length of the microscope would be 9.47 for the clear vision. Thank you. We also need to find the magnification in this case. So magnification is given by VO by UO into D by UE. So we know the value of VO over here. We have calculated it as 36.5, and UO is given, that is 0.9. The distance of the object from the objective. D is known, that is 25 centimeter, and UE we calculated to a value of 25 by 11. So after this formula, using this formula and substituting the values, we will get a result of 88. That is, the magnification of this microscope is 88x. The question is saying that a small telescope has an objective lens of focal length 144 centimeter and an eyepiece of focal length 6 centimeter. What is the magnifying power of the telescope? What is the separation between the objective and the eyepiece? So in a telescope, we know that for the image to be forming at the infinity, image formed by objective must lie on the first focus of the eyepiece. That is, if image formed by this lens is on the focal point of the of the eyepiece, then the image will be formed at infinity. That is, the total length of this telescope would be given by focal length of the objective plus focal length of the eyepiece. Now here, since the rays are approaching from the infinity, so we assume that the image is formed at the focus of the objective, the second focal point of the objective, and that image will be used as a virtual object for this eyepiece to form the image, to form the final image. Now magnifying power is given by focal length of the objective by focal length of the eyepiece, and substituting the values of 144 and 6 centimeter, we will get a value of 24x. That is, the magnifying power of this microscope is 24x. And the question about the separation between the objective and the eyepiece, so we saw earlier that the separation is given by the addition of these two focal lengths. So it will be 144 plus 6 centimeter, which will give out to be value of 150 centimeter. Thank you. The question says that a giant refracting telescope at an observatory has an objective lens of focal length 15 meter. If an eyepiece of focal length 1 centimeter is used, what is the angular magnification of the telescope? The second question says that if the telescope is used to view the moon, what is the diameter of the image of the moon formed by the objective lens? The diameter of the moon is 3.48 into 10 to the power 6 meter, and the radius of the lunar orbit is 3.8 into 10 to the power 6 meters. So first question is saying that simply we have to find out the magnification of this telescope. So we know the formula for magnification. It is given by the focal length of the objective by focal length of the eyepiece. So after substituting the values, we will get a value of 1500x. Now the second question is asking what would be the diameter of the image of the moon given the given the diameter of the actual moon and the distance of moon between Earth, that is the lunar orbit or the orbit in which moon rotates around the Earth, that is 3.8 into 10 to the power 6 meter. So here let us revisit the ray diagram formed by the convex lenses. So if we see that an object is beyond the focal length, then height of the object is HO and height of the image is HI. So if we focus, so these are the two rays that I have shown over here. The first rays is parallel to the focus, parallel to the principal axis, so it will go from focus to the beyond, and then the second ray is towards the pole of the lens, so it will go unaltered, and the intersection will form the image. So if we focus on the two triangles over here, that is OAB and OCD, these two triangles are always going to be similar, and we know the property of similar triangle is that the ratio of the similar sides are always equal. So in this two triangle OAB and OCD, OA by OC will always be equal to AB by CD. So this question was asking what is the radius of the moon of the image? What is the radius of the image of the moon? So if we substitute the values, if we assume that this is the moon over here, now this is going to be the radius of the moon. So we can assume that AB is the radius of the moon and OA is the distance of the moon from the earth, that is the lunar orbit, and OC is the focal length of the objective. OC is the focal length of the objective, and CD is the radius of the image. So HI is the radius of the image. So moon will be forming like this. So we can assume like this condition, and from the property of the similar triangles, using this ratio, we can easily calculate the value of CD, that is the known over here, that is the radius of the image of the moon. So substituting the values, we will get CD equals to 6.86 into 10 to the power 2 meter. We will get a value of 6.86 into 10 to the power minus 2 meter. So we can easily calculate the diameter of the moon now. So diameter of the moon would be equal to 2 times CD, that is 13.7 centimeter. Thank you. The question says that use the mirror equation to deduce that an object placed between f and 2f of a concave mirror produces a real image beyond 2f. Now there are four similar given questions, and in each question we have to use the mirror equation to deduce the following statements. So let's continue one by one. So in the first statement we have been given an object placed between f and 2f of a concave mirror produces a real image beyond 2f. So here is a concave mirror, and we have to use this mirror equation. We don't need to rely on the mirror on the ray diagram. I have just used the ray diagram for the illustration. So we have to prove that when the object is placed between f and 2f, that is f and 2f, the concave mirror produces a real image beyond 2f. The image will be produced beyond 2f and it will be real. That is, it will be formed by the real intersection of light, or in a simple term, it should be formed on the left side of the mirror. That is, V should be negative. V, that is the distance from the pole of the mirror to the image, should be negative using the sign convention. So let's begin. I have assumed that the distance between the focus and the object is x. That's making u, that is the object distance from the pole of the mirror, would be equal to f plus x. Now using the sign convention, u can be substituted as minus of f by f plus x. So using this value in the mirror equation, we will get 1 by v, that is the image distance, minus 1 by f plus x equal to minus of 1 by f. Here minus is because the concave mirror, its focal length using sign convention is taken negative. So 1 by v would be equal to minus of 1 by f plus 1 by f plus x. Now using simplifying this, we will get the value of v as f multiplied by f plus x by x, minus of f multiplied by f plus x by x. Now in the question, it was an object placed between f and af, f and 2f. That is, when the object is at f, x would be equal to 0. So using this x equal to 0 in this expression, we will get a value of minus infinity, that is v tend to minus infinity. And when object is at 2f, x will be equal to f. Using the value of f in the place of x, we will get a value of minus of 2x. So in this expression, we see that the image lies between minus of infinity to minus of 2f. Thus, the image is real as it is forming by the real intersection of the rays. And in the question also, it was given that we have to prove that when the object is placed between f and 2f of the concave mirror, then it produces a real image beyond 2f. And the image is also beyond 2f. The second question was, a concave mirror produces a virtual image independent of the location of the object. So a convex mirror produces, the question B was, a convex mirror always produces virtual image independent of the location of the object. So here we have been given a convex mirror, and we have to prove that it will always produce virtual image irrespective of the position of the object. So here I have assumed again u, the magnitude of u as x. So using sign convention, we can write u as minus x. Substituting in this mirror equation, we will get 1 by v minus 1 by x equals to 1 by f. Here f is positive because it is a convex mirror. And simplifying this, we will get the expression for v, that is fx by f plus x. Here we see that for x equals to 0, v is always equals to 0. That is when wherever the object is placed, that is x equals to 0, the v is always going to be positive. The image is always forming on the other side of the mirror, or the image is always virtual. Since v is positive, it means that v measured from here is always going to be in this side of the mirror, that is in the right side of the mirror. Thus there there will always be a virtual image forming for this case. Now the third question was, the virtual image produced by a convex mirror is always diminished in size and located between focus and the pole. So the question is asking us to comment on the magnification, and it is also asking us to comment on the position of the image that is lying between the pole and the focus. So from the above calculation for v, we see that v is equals to fx by f plus x, and if we divide both the terms, both the numerator and denominator by x, we will get f by x plus 1. So when we increase the value of x over here, then we see that this term is going to be 0. This term will tend towards 0. Thus the maximum value of v that we can achieve would be v equals to f. That is, if we increase the value of x, then v will approach to f. That is, if we take the image away from the mirror, if we take the object away from the mirror, then the maximum position of the image is going to be at f. That's what the question said. Now we have to comment on the magnification in this case. Now magnification, we know that it is given by minus of v by u. So we will substitute it in the given formula, that is minus of v fx by f plus x into into 1 by u, that is 1 by minus x. So equating this, we will get f by f plus x. Now here we see that as x increases, f by f plus x is always going to be less than 1. That is, the object, that is the image will always be diminished. And m is always going to be positive, that is the virtual image will always be erect. Now let's focus towards the last question. Last question said that the object placed between pole and the focus of the concave mirror produces a virtual and enlarged image. Virtual and enlarged image. We have to prove that. So let's assume that the distance between the object and the pole of the mirror is x. Now using sign convention, we can write u as minus of x, and I have substituted it in the mirror equation, 1 by v plus 1 by u equals to 1 by f. So 1 by v minus 1 by x equals to minus of f, because it is a concave mirror. Now again, solving for v, we will get the value of v as fx by f minus x. So now for u equals to minus f x equals to f, that is, using this value of x in this expression, we will get the value of v as infinity. That is, when the object is at focus, the image will be at infinity. Now for the case when u is between f and 0, or the object is between focus and the pole, we will get a value of v as positive, because x will always be less than focus in magnitude. Thus this both term is going to be positive, thus v is going to be positive. And what it means that v is positive, we see that if v is positive, the mirror will always form the image in the right side of the mirror. That's why we can say that the image will always be virtual. Now let's comment on the magnification. So substituting the values of v and u in the magnification formula, we will get the value of m as f by f minus x. Now since f minus x will always be less than f, thus the value of m will always be greater than 1. Now here you should mark that I have used the sign convention for x over here. So x will always be positive over here. So that is why f minus x will always be less than f. So m will always be greater than 1, or the image will always be enlarged. That's how we have proved all those 4 statements that were given using the mirror formula. Thank you. The question is saying that a small pin fixed on a tabletop is viewed from above.
from a distance of 50 centimeter, by what distance would the pin appear to be raised if it is viewed from the same point through the 15 centimeter thick glass slab held parallel to the table? Refractive index of glass is 1.5 centimeter, 1.5, and does this answer depend on the location of the slab? So here there is a pinpoint on the slab, pinpoint on the table, and there is a slab through which an eye is there or a person observer is there, and it is viewing the pin top. Now we have to find out by what distance will this top be appear elevated. Like since the actual distance is 50 centimeter, then by what distance will it appear elevated because of this glass? So we know the formula for apparent depth or apparent length in this case, because the light is traveling from a different media, so there will be apparent shift. Now length apparent would be given by d1, that is the thickness of the glass, divided by mu1, that is the refractive index of this glass. Now substituting the values, we will get apparent depth of 10 centimeter. What means is that though the thickness of glass is 15 centimeter, but it would appear as if it is just 10 centimeter. So there will be a shift of 15 minus 10 equals to 5 centimeter, or the pin top will appear to be have moved 5 centimeter above. So we can say that the pin appears not to be at 15 centimeter as the thickness of the block rather than 10 centimeter. So the pin appears to be raised by 5 centimeter. The question is saying that figure 9.28 shows a cross section of light pipe made of a glass fiber of refractive index 1.68. The outer covering of the pipe is made of material of refractive index 1.44. What is the range of the angle of incident rays with the axis of pipe for which the total internal reflection inside the pipe takes place, as shown in the figure? What is the answer if there is no outer covering of the pipe? So this is a glass pipe in which ray of light is traveling. Now we have been given that this is the angle of incidence by which the ray enters, and this is the angle of refraction, first refraction, and we have to find out the condition over which what would be the angle of incidence for which total internal reflection takes place. That is, the light doesn't pass through the outer covering, it reflects totally inside. What is the criteria for total internal reflection for this interface, that is the outer covering and the glass interface? Now we can apply Snell's law over here. Now this is the first part of the question, like we have to find out what is the range of I, this I. Now the second part of the question says that what if we remove this outer covering, then we have to find out the range of I. So we will be using Snell's law over here. Now let's revisit the Snell's law. So it says that if the angle of incidence in one media of refractive index n1 and the angle of refraction in the other media of refractive index n2, then it can be related by n1 sin I equals to n2 sin R. So we will use this Snell's law in order to find out the critical angle. So let's calculate the critical angle. So using this Snell's law over this diagram, we can say that we can see that sin IC equals to sin inverse mu2 by mu1, where mu2 is the refractive index of the glass outer covering and mu1 is the refractive index of the inner core of the glass. Now this will give us IC as 59 degree, that is critical angle of 59 degree. So by now we have come to know that IC, that is I dash must be at least 59 degree for the total internal reflection to take place. Now the minimum value of I dash is 59 degree. So in this triangle we can easily find out what should be the value of R so that total internal reflection takes place. That is, if this angle is 59 degree, then what would be the value of R? So we know that this is a right angle triangle. So I dash plus R must be equal to 90 degree. So R plus 59 degree must be equal to 90 degree. So the value of R must be equal to 31 degree. So the minimum value of I dash should be 59 degree. So maximum value of R should be 31 degree. Now for this value of R to be 31 degree, what should be the angle of incidence? Again we will apply Snell's law over here. Now we can take the refractive index of this media as 1, and we know the refractive index of this media, that is the glass core media, as 1.68. So we will apply Snell's law over here. So calculating the condition for R that is less than 31 degree would be 1 sin I is equals to 1.68 sin R. Now sin I by sin 31 degree, that is sin R,
I've written sine 31 degree would be equal to 1.68. Now this will give us sine I equals to 1.68 times 0.52. Now 0.52 is the value of sine 31 degree. I have substituted it over there. Now the value of I would be equal to approximately 60 degree. That is, for the angle of incidence of 60 degree, we will get a value of angle of refraction in the glass core as 31 degree. Now, the angle of refraction must be less than 31 degree in order for the total internal reflection to take place. Now, if we increase this value of I, then obviously the angle of refraction will also increase. So, the angle of incidence must be less than 60 degrees so that the angle of refraction doesn't surpass 31 degree, or the IC or the I dash, the value of I dash shouldn't decrease from the critical angle, because if the value of I dash will decrease from the critical angle, then the total internal reflection will not take place. Now we have found out the condition for total internal reflection to take place, that is I should be less than 60 degree and greater than 0. Now let's cover the case when there is no any outer covering. Now in this case we can assume that mu2, that is the value of outer covering, refractive index of outer covering, mu2 is equals to 1. Now in this case we will see that again we will find out the value of IC using the Stinnes law. So we can write over here that I1 sin IC equals to mu1 sin IC equals to mu2 sin R. Now R is the angle of refraction over here and IC is this one. So substituting the values of refractive index, we will get 1.68 into sine IC is equals to sine 90 degree. R is 90 degree over here. So we will get a value of IC as 36.5 degree. Now for total internal reflection, we saw that since IC is equals to 36.5 degrees, so I dash must be greater than this critical angle, that is 36.5 degree. Now again, using this triangle, we can see that if the minimum value of I dash is equals to 36.5 degree, so the maximum value of R should be 90 minus 36.5 degree. That will give us a value of 53.5 degree. So maximum value of R should be 36.5 degree. Now we saw in this case that since this media and this outer covering apart from the glass core media is same with refractive index of 1, so we saw that for this angle I, automatically the angle of refraction is getting 90 degree. So we can conversely say that I is equals to 90 degree for R is equals to 36.5 degree. Now the value of R is 36.5 degrees. So this value will never cross the maximum permissible value for any given value of I. So we can say that for every value of I, the total internal reflection will take place. The question says that the image of a small electric bulb fixed on a wall of a room is to be obtained on the opposite wall 3 meters away by the means of large convex lens. What is the maximum possible focal length of the lens required for the purpose? Now, in this diagram, we see there is a electric bulb on a wall and there is a convex lens which will be used to cast an image of this bulb on that screen or the wall. And the distance between this wall that is carrying the bulb and the screen is 3 meters. Now this distance is fixed. We have to find out what would be the maximum focal length for which we can cast the image on that screen. So here we will use the lens equation. So for maximum focal length, we will solve for f maximum. Now we have assumed u to be x variable, that is distance of the object or the bulb or the wall that is carrying the bulb from the lens as u equal to x. Now obviously the image distance will be 3 minus x because it is fixed. The distance between those two walls is fixed. Now using the sign convention and the lens formula and substituting the values in this equation, we will see that 1 by v becomes 3 minus x, and since the screen is on the right hand side, it is going to be positive, so it would be 3 minus x, minus u is on the left side of this lens, so it is going to be negative. So I have substituted 1 by minus x equals to 1 by f. So using the values u equals to x and v equals to 3 minus x, we have substituted the values over here in this lens equation. Now solving for f, we get a value of f as 3x times 3 minus x by 3. Now upon simplification, we will get f as x minus x square by 3. Now for fx to be maximum, for this focal length function to be maximum,
We know the mathematical condition, that is this one: f dash x, or the differentiation of the function of focal length with respect to x, must be equal to 0, and the double differentiation of that function with respect to x must be less than 0. Now differentiating it for the first time with respect to x and equating it with 0, we came to the conclusion that the value of x is 3 by 2 or 1.5 meter. Now checking it for the double differentiation, we get the negative. That is, for the value of x as 3 by 2, fx is going to be negative. Fx is going to be minimum. Now, since we know that we have used as 3 minus x, and we have got the value of x, that is u. So we have got the value of u and v as u equals to 1.5 meter and v as well as 1.5 meter. Now, using those values in the length equation with proper sign convention, we come to the conclusion that 1 by f is equals to 1 by 1.5 minus of 1.1 by 1.5. Now, upon calculation, we will get the value of focal length as 75 centimeter. The question says that a screen is placed 90 centimeter from an object. The image of the object on the screen is formed by a convex lens at two different locations separated by 20 centimeter. Determine the focal length of the lens. So we have been given an object and a screen, and the distance of separation between them, that is 90 centimeter, and we have to find out what would be the focal length of this lens, given that there are two positions for this lens where the image can be casted on this screen, and those positions are separated by a distance of 20 centimeter. So let us represent it by d, the position of the difference between the position of the lenses which can subtend the image on the screen. So let us assume that the first position, the distance of the object from the lens from the first position is u1, and the distance of the object from the second position is u2, and subsequently the image distance would be v1 and v2. Now we know that since this distance from the object and the screen is fixed, and that is 90 centimeter, so u1 plus v1 or u2 plus v2 equals. Now using these relations, we have to find out the value of focal length of the lens. Now let us generalize this approach by saying the distance between the object and the lens, wherever it is, either in the first position or in the second position, be x variable. So automatically the image distance from the lens would be 90 minus x, because the total distance is 90 centimeter. So v would be equal to 90 minus x. Now let us use the lens formula over here. That is 1 by v minus 1 by u equals to 1 by f. With proper sign convention, we can write 1 by 90 minus x, that is v. Since v is in the right side of the lens, so it is going to be positive, and u, that is the object, is in the left side of the lens, so it is going to be negative. So 1 by 90 minus x minus of 1 by x equals to 1 by f. Since it is a convex lens, so focal length is going to be positive. Now simplifying this, we get the relation for focal length as 90 minus x times x by 90. Now for quadratic equation, so this is a form of quadratic equation which can be further simplified to is this: x square minus 90x plus 90f equals to 0. Now in this equation there are two variables, x and f. So let us first take a look at the quadratic equation solutions. So for a quadratic equation ax square plus bx plus c, we know that the solutions are given by minus of b plus minus root under b square minus 4ac by 2a. So using these coefficients, we can write the solution for this equation as well, as x equals to minus of 90 plus minus under root minus of 90 whole square minus 4 times 1 times 90f by 2. So one solution will contain plus of this determinant, and another solution will contain minus of this determinant. We know that x is the solution for the value of u, that is the distance between the object and the lens. So we also know that the difference of this position that we have taken earlier, that is u2 minus u1, would be equal to d, that is this distance of separation, that is 20 centimeter. So we can simply write over here, then u2 minus u1 is equals to 20 centimeter, or the first solution minus the second solution is equals to 20 centimeter, or we can say that the distance of the first solution minus the distance of second solution is equals to 20 centimeter. Let us use this relation to eliminate one of the variables among x and f.
So we can write that u2 minus u1 equals to d, that is 20 centimeter, or we can say that the distance without any sign convention, we can write it as x2 minus x1 equals to d. So using this and substituting the values of the two solutions of x, we come to a value of 20 under root of 90 square minus 4 times 90f is equals to 20. Now squaring both the sides of this equation, we will get the value of f as 21.4 centimeter. That's how we have found out the value of x. That's how we have found out the value of f, that is the focal length of convex lens. The question says that determine the effective focal length of the combination of the two lenses in exercise 9.10 if they are placed 8 centimeter apart with their principal axis coincident. Does the answer depend on which side of the combination a beam of parallel light is incident? Is the notion of effective focal length of this system useful at all? So in the previous exercise of 9.10, we were given two lenses, a convex lens and a concave lens, and we were asked to find the F effective or the net focal length of the system. Now in this question, it is asking that these two lenses are kept apart 8 centimeter. Now we have to find out what would be the effective focal length, and does that hold any meaning at all. Here we have to determine the effective focal length of the combination of the two lenses, and we also need to answer that will the effective focal length depend on which side of the lens the light is coming from, or which side of the lens the object is placed. And we also need to comment, is the notion of effective focal length of the system useful at all. Now here we can make two cases to find out whether the answer will depend on which side of the combination of the beam of parallel light is incident. We will first put concave lens on the back side of the convex lens, or if we imagine the rays coming from an object that is placed at infinite, or the rays are parallel. So at first we will put the convex lens on the left hand side, and then in the second case we will put concave lens on the left hand side and see will the answer depend. Now for an object at infinity on the left hand side, the image will form at the focus of the convex lens. Since we have been given the focus of 30 centimeter, so the distance of image from for this lens would be v equals to 30 centimeter. As u1 is infinity, u1 as in the case of convex lens, that is the first lens, we can say that v1 is equals to 30 centimeter, and u2 here represents the object distance for the concave lens, that is the second lens. When this lens is forming the image, it would be 30 centimeter on the right hand side of the lens. So 30 centimeter from this direction would be somewhere here. Now the distance of this image which will act as an object for this concave lens will be 30 minus 8, that will be equal to 22 centimeter. So for this lens, the object will be placed at 22 centimeter on the right hand side. So we can write U2 as 22 centimeter. Now using the lens formula for this second lens, we can find out the value of its V, that is the image formation, the position of the image. So using this lens formula for this concave lens, we can write 1 by V equals to 1 by F plus 1 by U, and 1 by U is 1 by 22 centimeter, and 1 by f is 1 by minus of 20 centimeter, because the focal length is given as 20 centimeter, and since it is a concave lens, we can write it as minus 20. So calculating this, we will get a value of v as minus 220 centimeter. So for this lens arrangement, we will get, when the object is at infinity, the final image will be forming at v equals to minus of 220 centimeter on the left hand side of this lens by a distance of minus of 220 centimeter. Now we will consider the second case in which concave lens is the first lens and the convex lens is the second lens. So here v1 would be equals to minus of f, because when the incident ray is there, it will virtually tend to form an image in front of the concave lens 20 centimeter or equals to its focal length. Now we can treat this image as a virtual object for this convex lens. So u2 would be equal to this 20 centimeter plus of this 8 centimeter distance. So the total value of u2 would be minus of 28 centimeter with sign convention. So again applying lens formula over here. So we will get 1 by v equals to 1 by f plus 1 by u, and we saw that 1 by u is equals to 1 by minus of 28 centimeter, and since focal length is positive for the convex lens, so it will be 1 by 30. Calculating this, we will get a value of v as minus of 420 centimeter. Now we can comment that seeing this results that we changed from the previous case of 220 centimeters, so that we can say that yes, the answer depend on which side the incident ray is coming from, because v has changed or the final image distance has changed. And we can also comment that no, the notion of effective focal length won't work in this case, because there can't be f effective, as the image position is varying depending upon which lens, which side, or the which lens is receiving the first incident rays. Now the second question asked, like, an object of 1.5 centimeter is placed on the side of the convex lens in arrangement A above. The distance between the object and the convex lens is 40 centimeter. Determine the magnification produced by the two lens system and the size of the image. So now using this arrangement, we have been given the value of u, that is the object distance from the convex lens, and that is of 40 centimeter, and the object size or the height of object is given, that is 1.5 centimeter, and we have to find out what is the magnification produced by the two lens system, and also we have to determine the size of the image. So let's go to the calculation. So this is the arrangement that we were talking about. The object is placed in front of convex lens and u has been given, and that is of value of minus of 40 centimeter. Focal length of this convex lens is 30 centimeter, and focal length of this concave lens is minus 20 centimeter, and the distance between these two lenses is again 8 centimeter. So we will consider this first lens and this as the second lens. So u1 would be equal to minus of 40 centimeter with the sign convention. So using lens formula for finding out the image produced by this convex lens, so 1 by v equal to minus of 1 by u, and that is u is minus of 40. So 1 by v equals to minus of 1 by 40, and that would equal to focal length. Focal length of convex lens is positive, so it will be equal to 1 of 1 by 30. So calculating here v, we will get a value of 120 centimeter. Now we can see that from the pole of this lens, the image will form, the first image will form 1 centimeter on the right hand side of this lens. So this image will act as an object for this concave lens. So we can find out the object length, object distance for this concave lens, and that would be equal to u2 would be equal to this 120 centimeter minus of this distance 8 centimeter, and that will come out to be equal to 112 centimeter. Since this distance is on the right hand side of the concave lens, so it is going to be positive, or u2 is going to be plus of 112 centimeter. Now applying the lens law over here, 1 by v minus 1 by equals to 1 by f. Here f is negative because it is a concave lens, and 1 by v minus 1 by 112 would be equal to minus of 1 by 20. So solving this for v, we will get a value of v as minus of 560 by 23 centimeter. That is, the position of image is on the left hand side of this concave lens at minus of 560 by 23 centimeter on the left hand side of this concave lens. So we have got this value of u1, v1 and u1, and v2 and u2. Now we can find out the magnification of each lens independently, and then we can find out the product of magnification so that we can get the net magnification. So magnification for the convex lens would be equal to m1 equals to 120 by minus of 40, as m is equals to v upon u. So we can divide it and get the value of magnification by the first lens as minus of 3, and by second lens similarly we will substitute the values in that formula, in this formula, and we will get the value of minus of 5 by 23. Now net magnification will be equal to the product of these two independent magnifications, and that will be equal to 0.652. That is, the net magnification is less than 1 and it is diminished in size. So the final height of this image is going to be equal to net magnification multiplied by the original height, and that we will get solution as 0.98 centimeter, because the initial height was 1.5 centimeters. So we can multiply it with 0.652, that is a net magnification, and we will get the value as 0.98 centimeter. The question says that at what angle should a ray of light be incident on the face of a prism of refraction angle 60 degrees so that it suffers total internal reflection at the other face? The refractive index of the material of the prism is 1.524. So here we are being talked about the faces of prism A, B, C, and the faces that are in consideration are AB and AC. Now, on the face AB, the incident ray ON makes an angle I of incidence with the normal, and it goes in the prism with the angle of diffraction equals to R1. Now, it strikes the second face AC with an angle of incidence of R2, and it goes out with an angle of refraction as E, or angle of emergence. Now, in our question, it is said that on the second phase, it should reflect such that total internal reflection happens, or the angle of emergence should be equal to 90 degrees. So, for that condition, we have to find out what would be the value of I. So, we know in a prism, the angle between two faces are called the angle of refraction. The prism, and it is given over here that it is 60 degree. So we also know the relation for prism that R1 plus R2, this R1 plus this R2 is equals to the angle of refraction of the prism, the angle between the two faces, and that would be equal to 60 degree over here. So R1 plus R2 equals to 60 degree. Now we will be applying Snell's law on these two faces AB and AC. So applying Snell's law on face AB, it would be equal to, if the outer media is having refractive index of mu1 and the prism is having refractive index of mu2, then it would be equal to mu1 sine I is equals to mu2 sine R1. So we can say that the mu1, or the refractive index of the media is, the media surrounding the prism is 1, and sine I would be equal to 1.524 times sine R1. Now applying Snell's law on the interface AC, that is the second phase, we could see that it is mu2 sine R2 equals to n1 sine E. n1 is the refractive index of the media that is surrounding the prism. Now for total internal reflection, as we discussed, E would be equal to 90 degree. So substituting the value, we will get sine R2 equals to 1 by 1.524. Now R2 would be equal to sine inverse of 1 by 1.524. This will give us R2 the value of 41 degree. Now substituting this value R2 equals to 41 degree in equation number 1, that was R1 plus R2 equals to 60 degree, we will get the value of R1 as 19 degree. Now substituting this value of R1 as 19 degree in equation number 2, we will get the value of I. So solving for the value of I, we will get the value of I as 30 degree. Thus, for the angle of incidence of 30 degree, we will get the total internal reflection on the second face of the prism. The question says that a card sheet divided into a square, each of size 1 millimeter square, is being viewed at a distance of 9 centimeter through a magnifying glass. A converging lens of focal length 10 centimeter held close to the eye. Now, what is the magnification produced by the lens, and how much is the area of each square of the virtual image? So, the question is saying that there is a convex lens of focal length 10 centimeter, and in the front of convex lens there lies a sheet. Let us assume it over here, and it is 9 centimeter in front of that convex lens, and on the sheet there are divisions pattern of a square, each of area 1 millimeter square. So we have to find out what is the magnification produced by this lens and what is the virtual area, or the area of the image produced by the lens. Now, how to approach this question? So the first thing over here is we have been given the value of object distance, that is minus 9 centimeter with the sign convention, and we have been given the focal length. So for the position of image, we can calculate the value of V. Now we also need to calculate the area of this virtual area of this square that would appear from the eye. So we need the value of magnification by the lens, and it is given by V divided by U, that is the position of image divided by the position of object. So here only V is the unknown quantity, and we can use the lens formula in order to calculate V. So we can get the value of magnification. Now the second question is saying that what is the angular magnification, magnifying power of the lens? So we know that the angular magnification and the magnification is different. We have to calculate angular magnification as well. And also the third question is the magnification in case A equal to the magnifying power or the angular magnification? Explain. So let us proceed with the unknown quantity V, that is the position of image. Now substituting the values, we have been given the value of U as 9 centimeter, and with sign convention it would be minus 9 centimeter.
focal length as 10 centimeter, we will get the value of V as minus 90 centimeter. That is, the image is produced on the left side of this convex lens on the side of the object at 90 centimeter. Now we can calculate the value of magnification for the lens, that is V by U, and we will get 10. Now we know that the magnification produced is 10. So let us assume the virtual area of the square be A dash and the given original area is 1 millimeter square. Now we saw that the magnification produced is 10 times. So 1 millimeter will appear as 10 millimeter. Now 1 millimeter square will appear as 10 millimeter cross 10 millimeter, that is 100 millimeter square. Since the linear magnification is 1 millimeter and area is having 2 dimensions, so we can say that 1 millimeter becomes 10 millimeter and the area subtended by this 10 millimeter would be equal to 100 millimeter square. So the two questions are clear. Now let us move towards the angular magnification or the magnifying power. So we know that angular magnification is defined as the factor by which image on the retina gets enlarged. Now it is given by visual angle by the final image divided by visual angle by the object. And visual angle by the final image will depend upon the image position. So for this case, the image position is different than the value of D. So the angular magnification formula would be equal to D by F. So we can get the value of 2.8. Now there are cases when this magnification is going to be equal to the magnification produced by the lens, and in that case the image is formed at the least distance of distinct vision, that is equals to D. So in this case, what is happening is that image is forming at minus 90 centimeter. That is why this value is different from the magnification of the lens. Angular magnification is different from the magnification of the lens. If this value, if the position of V or the final image is minus of D, then we can say that angular magnification is equals to magnification of the lens. The question says that at what distance would the lens be held from the card sheet in exercise 9.22 in order to view the squares distinctly with the maximum possible magnifying power. Now here it is asking what is the distance of the object from the previous question so that we can view the image properly with the maximum magnifying power. Now this question is taking the data from the previous question, and the data are focal length of the convex lens was 10 centimeter, and now here we have to find out the magnification, the magnifying power or the angular magnification for the image to be formed such that the eyes could see distinctly. So for the squares to be visible distinctly, the image should form at the least distance of distinct vision, that is 25 centimeter away from the eye. Now so that we can deduce from this is that V should be equal to minus of 25 centimeter. That is, the final image should be at least 25 centimeter away from the eyes. Now so we have got the value of V, we have the value of F. Now we have to find out the value of U such that this case is met. Now here we have to find out what is the magnification in this case as well. Now here this magnification, the value of M is going to be equal to V by U, and whereas this is small m, the magnification is represented by small m, and the magnifying power is represented by capital M. So we have to find out the magnification as well. So we have to find out the value of U so that we can use the formula V by U. Now we also need to comment that is the magnification equal to the magnifying power. Now we have to comment that is this magnification equals to the magnifying power. So we have the formula ready that is to be used, that is the lens equation. So 1 by V equals to 1 by V minus 1 by U equals to 1 by F. Now here 1 by V, we can put the value of V as 25 centimeter. With sign convention it would be equal to minus of 25 centimeter. We have to find out the value of U, and the value of F is given, that is 10 centimeter. Now the value of U from this calculation is minus of 7.14 centimeter. Now here we know that angular magnification is given by D divided by U naught, or the distance of object from the object. So this is the angular magnification. It comes out to be a value of 3.5, and this is the magnification. So this can be given by V divided by U, and this is same as the angular magnification. Now here we have found the value of linear magnification in this case, and we saw that is the magnification equal to the magnifying power in this case. Then we saw that the answer of this question is yes. Now how did this happen?
how did the magnification become equal to the angular magnification? So we know that this now angular magnification is given as the visual angle formed by the final image divided by the visual angle formed by the object at D. Now the formula for angular magnification is capital D upon U naught, where U naught is the object distance from the objective or the lens. Now linear magnification was given. Now magnification is given as V by U. Now here we saw that in this case, when the final image is at D, then we can write V as 25 and U is the object distance. So we can write it U naught. So we can see here that M is equals to M. Capital M is equals to small m, or the angular magnification is equals to the linear magnification. So we can say that whenever the final image is forming at D, then we can get the angular magnification is equals to the linear magnification. The question is saying that what should be the distance between the object in exercise 9.23 and the magnifying glass if the virtual image of each square in the figure is to have an area of 6.25 millimeters square. Would you be able to see the squares distinctly with your eyes very close to the magnifier? So we have been given the desired the area of a square that is desired, and we have to find out the object position for the desired surface area. So we can say that A dash is 6.25 millimeter square, where A dash represents the area of the image. So we can deduce from this the length of each square. So length would be the square root of this area, which will give us 2.5 millimeter. Now we saw that in this question number 9.23, the length of each square and the width of each square was 1 millimeter. So upon magnification, it is going to be equal to 2.5 millimeter. So we see here that linear magnification is going to be V by U, which is the final length divided by initial length, that is 2.5. So we can say from here that V by U would be equal to 2.5. Now here we are desired to find this value of U. So now we have got the value of V in terms of U. We can write V equals to 2.5 U from this relation, and we know the focal length of this lens, which is 10 centimeter. So there is only one variable, that is U, to be used in the lens equation. So we can find out the value of U. Now later we have to say that we have to comment on, would you be able to see the squares distinctly with your eyes very close to the magnifier? So for this value of U, we be able to see the squares distinctly with your eyes. Now in order to see the squares distinctly, the minimum distance should be equal to D. So let us find out whether U is greater than D or whether U is less than D. If U is less than D, then we won't be able to see it, and if U is greater than D, then we will be able to see the squares distinctly with our eyes. So let's use the mirror equation. Let's use the lens equation to find out the value of U first. So 1 by V minus 1 by U would be equal to 1 by F. Now 1 by V in terms of U is equals to 2.5 U. Now 1 by U is as it is. Now 1 by F would be equal to 1 by 10. Now the value of U calculated is minus of 6 centimeter. That is, the object should be 6 centimeter away from the objective or the magnifier. Now here we can see that the least distance of distinct vision is 25 centimeter, and U for this desired area is minus 6 centimeter. So U is less than D. So we can't see the square distinctly.
The question says that an angular magnifying power of 30x is desired using an objective of focal length 1.25 centimeter and an eyepiece of focal length 5 centimeter. How will you set up the compound microscope? So basically it is asking that what would be the length of this microscope if we have got an objective of focal length 1.25 centimeter and an eyepiece of focal length 5 centimeter. So we know that the length of microscope can be given by the distance of the image from the objective added with the object distance for the eyepiece. Now, we have also been given that the desired magnifying power is 30x. So we can write it as m equals to VO by UO, that is the position of final image by the objective divided by the object distance from the objective multiplied with 1 plus d by Fe, where Fe is the focal length of the eyepiece. Now in this expression, this first part is magnification by the objective and the second part is the magnification by
eyepiece. Now it is desired that m would be equal to 30, and let us calculate the expression for me first, the value for me. Now we have been given that the focal length of the eyepiece is 5 centimeter. So substituting the values, we will get the value of me, and that would be equal to 6x. Now we can substitute this 6x in this formula and find out the value of mo. Now finding the value of mo, we will get the value of 5. That is magnification by the objective is going to be equal to 5 times. Now we know that objective creates virtual image, so we can write it as -5. Now the magnification by objective is given by VO, that is the objective, the image, the position of image produced by the objective divided by the object from the objective lens would be equal to -5. So if we assume that UO, that is the object distance from the objective, is -x using the sign convention, then VO would be equal to 5x using this relation. Now using lens equation for the objective, we will find out the value of UO. So substituting the values that we assumed in the previous case. So 1 by V would be equal to 1 by 5x. Now 1 by U would be equal to 1 by x because U is -x. So finding the value of x, we will get a value of 1.5 centimeter. Now since we assume that VO is equals to 5x, so VO is going to be equal to plus or 7.5 centimeter, and UO, that is the object distance from the objective, is going to be equal to minus of 1.5 centimeter. So we have got the value of UO over here and the value of VO over here, and we also know that we have to find out the value of VO and UE. So only unknown quantity is the object distance from the eyepiece. We have the value of VO, that is 7.5 centimeter. Now let us find out the value of UE. Now for finding UE, we will use the lens equation for the eyepiece. So for finding UE, we have been given the data, that is final image will be at -d under normal adjustment. So it would be equal to minus of 25 centimeter, and focal length is given, that is 5 centimeter. So just we need to find out the value of U. We can use lens formula in this to find out just one variable. So using the lens formula, we will get the value of U as 4.17 centimeter. So the object distance from the eyepiece is going to be equal to 4.1 centimeter for the magnification of 6x. Now we have got the value of UE, that is this one, and we calculated earlier the value of VO. Now we can add it to get the length of compound microscope, and similarly we can substitute the values and find out the answer as 11.67 centimeter. The question says that a small telescope has an objective lens of focal length 140 centimeter and an eyepiece of focal length 5 centimeter. What is the magnifying power of the telescope for viewing distant objects when the telescope is in normal adjustment, that is when the final image is at infinity and the final image is formed at the least distance of distinct vision, that is 25 centimeter. So here we have been given two cases where the final image is forming at infinity and the final image is forming at the least distance of distinct vision, that is 25 centimeter. And in both the cases we have to find out what would be the magnifying power for the telescope. So we know that the expression for finding the magnifying power, or the formula for finding the magnifying power, is given by, if the image is forming at infinity, then it is given by focal length of the objective divided by focal length of the eyepiece. Now if we use this formula, we will get the answer for first case, that is the telescope is in normal adjustment, then its magnifying power would be equal to 28 times. Now similarly, for the case where the final image is forming at D, the formula is given by focal length of the objective divided by focal length of the eyepiece multiplied by 1 plus Fe by DE. Now using this formula, we get a value of 33.6. So we see that the magnifying power in second case is greater as compared to the first case, or magnifying power when the final image is forming at the least distance of distinct vision is greater as compared to when the image is forming at infinity. The question is saying that for telescope described in exercise 9.27a, what is the separation between the objective lens and the eyepiece for the final image forming at infinity? Write the separation between the objective and the eyepiece as focal length of the objective plus focal length of the eyepiece, and that will be equal to 140 centimeter plus 5 centimeter, and which will give us 145 centimeter. Now the B part of this question is, if the telescope is used to view 100-meter tall tower 3 km away, what is the height of the image of the tower formed by the objective lens? So let us move to this question. Now we assume that this is the convex lens or the objective with a focal length of 140 centimeter. Now here lies the image. Now we can see that if the image is lying beyond the center of curvature, first center of curvature of the lens, so the image will form between the focus and the center of curvature, and if the object is placed far beyond, then the image will tend towards the focus, the second focus. So here we see that the angle made by the object and the image is going to be same. Here it is denoted by theta 0 or theta naught for the object and theta I for the image. Now here we can see that the image distance or the v would be equal to approximately would be equal to f, because 3 kilometer is too much as compared to the focal length of 140 centimeter. So we can write that theta naught would be equal to theta I, and theta naught can be given by height of the object divided by the base, that is 3000 meter, and the theta I for theta image is given by height of the image by focal length of the objective. Now equating these two angles, we will get the value as HO by 3000 would be equal to HI by FO. Now HI would be equal to 0.047 meter or 4.7 centimeter. So height of the image would be equal to 4.7 centimeter in this case. Now the third question follows. What is the height of the final image of the tower if it is formed at 25 centimeters? So given the same arrangement that the image height is 4.7 centimeter, we have to find out what would be the final image height, what is the height of final image if it is formed at 25 centimeter from the eyepiece. So here in this case for the eyepiece, we have been given V, that is the final image position, that is 25 centimeter. We have been given the value of F, that is focal length, that is of 5 centimeter. Using this length equation, we can find out the only unknown, that is U, object length or object position from the eyepiece. So calculating U, we will get a value of 25 by 6. Now we have to calculate the height of image, final image. So height of final image can be given by the magnification formula, linear magnification formula, that is V by U. And since we know the value of U now, that is 6. So the height of image can be calculated as the height of image by the objective, or the height of the image formed by the objective multiplied by the magnification of eyepiece, and which will give us 4.7 times 6, that would be equal to 28.2 centimeter. Thus the magnitude of the height of the image, the final image produced, is 28.2 centimeter. The question says that a Cassegrain telescope uses two mirrors as shown in figure 9.26. Such a telescope is built with the mirrors 20 mm apart. If the radius of curvature of the large mirror is 220 mm and the small mirror is 140 mm, where will the final image of an object at infinity be? So when the object is at infinity, what is the position of final image? We have to calculate this. Given that the focal length of the larger mirror, I have denoted it as 1, is given as 110 mm. We have been given the radius of curvature, so we can deduce the focal length from that, and which will be equal to radius of curvature divided by 2. So focal length of the larger mirror is going to be equal to 110 millimeter, and the focal length of the smaller mirror is going to be equal to 70 mm, and they are positioned 20 mm apart. So for the object at infinity, the image formed by the first mirror is going to be at the focal length of the first mirror, and since the focal length of first mirror is 110 mm, so the image position is going to be equal to minus of 110 mm. I have denoted it as V1. So the value of OV1 is going to be equal to minus of 110 mm. Now this image is going to act as a virtual object for this second mirror. Now since second mirror is positioned 20 mm in front of the first mirror, so the object position for this second mirror is going to be equal to 110 minus of 20, and with sign convention it is going to be equal to minus of 90 mm. So for this second mirror, we had to calculate the position of final image, that is V. So in this mirror formula, we haven't given the value of F, and we know the value of U now, that is equals to minus of 90 mm. So we can easily calculate the value of V. So let's calculate using the mirror formula. So 1 by V plus 1 by equals to 1 by F, and 1 by V would be equal to 1 by F minus of 1 by U, and minus of 1 by 90 would be equal to plus of 1 by 90, and thus calculating we will get the position of final image, and that is 315 millimeter in front of the mirror of the smaller radius. The question says that light incident normally on a plane mirror attached to a galvanometer coil retraces backward as shown in figure 9.29. A current in the coil produces a deflection of 3.5 degrees of the mirror. What is the displacement of the reflected spot of light on the screen placed 1.5 meter away? So when light reflects off a mirror, the angle of incidence equals the angle of reflection. Now, angular deflection by the reflected ray, if the mirror rotates by an angle theta, the reflected ray rotates by an angle of 2 theta. It gets deflected by the magnitude of 2 theta. So imagine that this solid black line is the mirror in the initial case, and this red line is the normal to this mirror, and it is reflected by and it is tilted by theta degree. Then the reflected ray, this blue line, will get deflection of 2 theta degree. Now, if we assume that this is the length between the screen and the mirror, L, then the deflection is given by small d equals L times tan of 2 theta. Now, in this case of galvanometer, theta is equals to 3.5 degree. So, 2 theta would be equal to 7 degrees. And L is given as 1.5 meter. So, substituting these values in this formula, we will get the value of deflection as 1.5 times tan of 7 degrees, which will give us 18.4 centimeter. The question says that figure 9.30 shows an equiconvex lens of refractive index 1.50 in contact with liquid layer on top of the plane mirror. A small needle with its tip on the principal axis is moved along the axis until its inverted image is found at the position of the needle. The distance of the needle from the lens is measured to be 45 centimeter. The liquid is removed and the experiment is repeated. The new distance is measured to be around 30 centimeter. What is the refractive index of the liquid? So in this arrangement, there is a lens and there is a liquid layer, and this is a plane mirror. Now there are two cases. In one case, there is a liquid layer of some refractive index that is unknown, and we have to find out that refractive index. And in another case, the liquid layer is not present. So in the case when the liquid layer is present, the image of a pin that is on the position PQ is formed on the same position, and in the case when the liquid is not present, the same repeats as well. The only change is the distance between the object and the lens and mirror system. So in the case when the liquid is present, the distance is 45 centimeter, and the case when the liquid is not present, it is 30 centimeter. So this is a question of the combination of lenses and also the reflection of a plane mirror. So we know that a position of image in the case of plane mirror is same in magnitude as that of the object, that is u equals to v. And if the object is real, virtual image is formed, and if the object is virtual, real image is formed in the plane mirror. Now here, in both the case, with or without the fluid, the object is virtual for the plane mirror, so the real image is formed, which is being superimposed on the object. Now, if we remove this mirror, the question is very much simplified, the sign convention. Like if we remove this mirror, the image that was forming on the left hand side of this lens system will form on the right hand side of the lens system. We can simplify this question by changing the sign convention of V to a positive, because if there was no any plane mirror, then the image would have formed on the right hand side. And also plane mirror does nothing with the magnification. And also the position of image remains same, that is the magnitude remains same from the object. The image forms at the same distance. So let us assume the case when there is no any liquid. So when there is no any liquid, then we can calculate the focal length of this lens as 1 by focal length of the lens would be equal to n minus 1 by r1 minus 1 by r2. This is the lens maker's formula, where n is the refractive index of this glass that is used to make this lens, and r1 is the radius of curvature of this side, and r2 is of this side. R1 would be positive because its center of curvature would lie on the right hand side of this lens, and R2 would be negative, and they both are of same radius of curvature, so we can write it as R, and thus we will get 1 by F lens is equals to 1 by R. Now in this case, without the liquid, the image and the object were at 30 centimeter in front of this lens. So we can assume that V equals to 30 centimeter when there is no any plane mirror, And when there is plane mirror, then V would be equal to minus 30 centimeter. So for simplification, I have just removed this plane mirror. So V would be equal to 30 centimeter and U would be equal to minus 30 centimeter. So using length equation now, we will get the value of R or F. Since F of this length is equals to 1 by R, so we can easily write that 1 by 30 plus 1 by 30 equals to 1 by R. This will give us R equals to 15 centimeter. That is, the radius of curvature of this length is equals to 15 centimeter. Now we will proceed with this case when there is a liquid. Now when there is liquid, then the refractive index of this liquid be mu2. Then now it is a combination of two lens system, that is this lens of glass and this is the lens of this liquid. And for this glass we already know that the focal length of this glass I have represented it with 1. So the f1 by f1 would be equal to 1 by r, and we have now 1 by f2 would be equal to mu2 minus 1 by r1 minus 1 by infinity. Since other side is infinity, so other side is plane for this liquid, so we can say that it would be 1 by infinity. Now R1 for this would be this side, which is equivalent in magnitude with this one, and its center would lie on the left hand side, so we can write it as minus of 1 by R, which was calculated in the previous part. So we can easily write as R1 as minus of R. Now substituting 1 by R1 as minus of 1 by R, we can get that 1 by F2 equal to mu2 minus 1 minus of 1 by R. Now we would get that 1 by F2 would be equal to 1 by R into 1 minus mu2. Now we will calculate the equivalent focal length. So we know that equivalent focal length is equals to the addition of inverse of the focal length, since they both are in contact and they both are thin lenses. So we can write as 1 by F equivalent would be equal to 1 by F1 plus 1 by F2. Now 1 by F equivalent would be equal to that of the glass and that of the liquid. So this is one that contains the liquid focal length. We have calculated it just now, and this is one for the glass focal length. So 1 by F equivalent would be equal to 1 by R times 2 minus mu2. Now this is the F equivalent for the case when the liquid is present between the lens and the plane mirror. Now again we will assume that there is no any plane mirror, because the plane mirror is only changing this direction of V. If there is plane mirror, then V is equals to minus of 45 centimeter. If there is no plane mirror, then V is equals to plus of 45 centimeter. Now we will apply the length equation again with F equivalent. So using the values, 1 by V would be equal to 1 by 45 and U would be equal to minus of 45. So minus of 1 by U would be equal to plus of 1 by 45. And this we just found out. And substituting the values of R, we will solve this equation, and then we will get mu2 would be equal to 2 minus 2 by 3, and which will be equal to 1.33. That is, the value of mu2 would be equal to 1.33. Thank you.